Okay, welcome to the EcoSolar Home Tour. We are going to do 8 homes in Edmonton today. This should take us from noon till about till just before 6 o'clock before we're done today. We've got a bunch of interesting homes to go over today. I want to thank all of our homeowners who have put their homes up to be seen today. I also want to thank our Zoom helpers today. We've got a number of Zoom helpers today. Gordon is our quizmaster. Lee is our concierge. Shane is our chat help and will be able to help you if you have some issues. Visitor services is Malvika, and social media today is Shelley and Adrian. So thank you to our volunteers for helping out today. Also want to thank our Edmonton sponsors. I want to thank the City of Edmonton, their Change for Climate initiative, for sponsoring the tour as a gold sponsor. Also want to thank EPCOR for being a gold sponsor of the tour. We appreciate their leadership sponsorship. Our silver sponsors, we have DeWall Developments, who is a builder. We have Park Power, who is a power retailer. Habitat Studio is a builder in Edmonton. Innotech Windows and Doors are based out of Vancouver, but they make European style tilt and turn efficient windows and doors. And then Butterwick Developments, they are a builder in Edmonton, and they are doing some very interesting things with retrofits you'll see at Site 11 today. Our bronze sponsors, Skyfire Energy is a solar installer, Rosecrest Homes is a builder, and Camrose Energy is a competitive energy retailer. We also have some in-kind sponsors. Solar Alberta is the Association of Solar people in Alberta, and they have provided us with some services. Lynn Allen Photography helped us with some videos, and the Unitarian Church of Edmonton helps us with some meeting space and some storage. So on our online tour today, we're going to have 40 minutes for each home. We'll start with a presentation on the home. Most of these homes have a video interview that was prepared earlier. However, some today will also have live presentations. The available videos are all posted at our website at ecosolar.ca if you'd like to review them after the tour today. But we'll also be showing them during the tour today. Then we're going to have a time for questions with the homeowners. So please chat your questions to Quizmaster. You can search for the name using the pound sign or number sign, whatever you like. So pound sign Quizmaster should be able to find the Quizmaster in the chat. You're only able to chat to one person at a time today. So you'll have to find that name in order to enter your chat. You can also ask questions by email to info@ecosolar.ca. That email address will be monitored during the meeting today, and it will be available after the meeting, so that if you want to submit a question after you've watched the tour today, we'll be able to get that and we'll be able to respond to you. Now today, the participants who are not presenting will normally be muted with videos off. We had some issues yesterday, and so we are going to be turning videos off and keeping everybody muted throughout the meeting so that we don't have any disturbances today. So on our online tour, we're here today to listen to the experiences of the homeowners. So the participants will remain muted unless recognized during questions. We want everybody to remember to address everyone respectfully, to not criticize the homeowner's experiences, to not criticize the technologies presented, and to not distract the conversation away from the tour. Participants not following these guidelines may be removed at the tour organizer's discretion. Our schedule for today. We're going to be starting in a little while at 12:20 with the Fraser Net Zero Energy Home. Then we'll have the Cromdale Net Zero Energy Retrofit, the Sundance Retrofit. Then we'll talk about the Ritchie Secan Home, Creekwood Net Zero Energy Home, the Beaumont Urban Farm, the Beaumont Net Zero Energy Home, and then wrap up with the Strathcona County Solar Home later this afternoon. Okay, we have a presentation prepared by one of our sponsors, EPCOR sponsors, and they've prepared a short presentation on the applying to be a microgenerator, and that will be presented by our volunteer Shane Fraser today, who works with EPCOR and is going to be able to spend a minute to talk about how you would be a microgenerator in Alberta.
All right. Well, thank you, Andrew, for this opportunity to participate in this EcoSolar tour. For those of you who don't know me, I'm Shane Fraser. I'm the manager of customer engineering for EPCOR Distribution. My team oversees all new connections and upgrades to connections in the city of Edmonton. We also oversee and assist with all new connections of microgenerators, which includes solar PV primarily. Beyond my professional interest in microgeneration and solar, I have solar on my home. I'm currently in the process of a very long and arduous retrofit, hopefully towards net zero for my own personal home. And yeah, I'm also a personal member of the EcoSolar group. What I'm going to talk to you guys about today is just a high-level process of how to become a solar power user and how to retrofit your home. So if I go to the next slide there, please, Andrew. What I've done is I've taken this very complex process and broken it down to 6 primary steps that you as a homeowner should know and understand to help guide your path towards becoming a solar user. And the first step in all of this is to obtain your past consumption data. This is really important because it's in Alberta, the microgen regulation, which is written by the government of Alberta, mandates that you can't produce more electrical energy in an annual cycle than you consume in an annual cycle. This is a very nebulous situation for us utilities because everybody uses a little bit more or less electricity every year. But the first and best way to determine this, particularly if you have a home and you're putting solar on that you've lived in, is to look at your past electrical bills. You can contact your energy retailer because I know not everybody keeps their electrical bills for several years like I do. Or you can talk to your distribution utility or your energy retailer. They being the installer, can also act on your behalf and get this data from your energy retailer or distribution company as well. If you do ask one of your installers or prospective installers to get this information, ask for a copy of it. That way you can share it with the other installers you may be interviewing, and they can use the same data, and you're not waiting multiple times to get that from your utility or retailer. Next step is to interview your installers. I know when I put solar in my home, I work with all the installers and made sure I interviewed at least 3. My last point in this little box here is that you should get 3 quotes. That way you know that you're getting a fair price for your solar panels. But the installer should sit down and discuss your needs, wants, and goals. In the case of my home, I'm bound by the same rule of not being allowed to put on more solar than I can use. But I do want to eventually go to net zero, as I mentioned. I also like to get an EV, and I'd like to be able to charge that EV with my solar panel system. To that end, I worked with my installer to put in additional cabling and a little bit of additional inverter capacity and additional room in my main distribution panel to provide that future upgradability. They should discuss the whole process, not just this process, but their individual construction process with you. So you got a good idea of how this is all going to play out. They should review their system layout and configuration. This is an interesting one. Like I said, I went to 3 different installers, and they gave me 3 different layouts for the same roof. And the layout I went with, the final installer, wasn't the one they originally suggested. I actually took suggestions and comments made by the other 2 and asked the installer I chose to make some changes to meet my requirements. They should talk about rebates. There's some really awesome rebates out there right now for the city of Edmonton if you're blessed to live in Edmonton, and also from the federal government. They should answer all your questions and provide you with a written quote and a written timeline. I really see a lot of customers not get that written timeline, and they're surprised at how long it can take. Now, the big, most important decision is you're going to have to choose who you're going to go with. One thing I do recommend to customers that I speak to is the cheapest option isn't always the best. Get some reviews, talk to other people, people like those in the Eco Solar Home Tour, and see what their experiences were. You might actually end up paying more for the cheapest quote. And then the time's come to sign the contract and pay any deposits required. One thing I wanted to note is in some cases, they might have to come back multiple times to look at your home. I know in the case of my house, it's funny, I'm a structural engineer by trade, but I had structural issues with my roof. So there had to be some structural bolstering that took place before I installed my panels. So they might need to have some people beyond just the consultant that comes to your home, come to your house and look at some of the different components. Next slide there, Andrew. Okay, so step 4. Sorry, I have a little problem here on my side. There it goes. Applications and permits. This will typically be done by your installer, and I would suggest that you want them to do this. If they suggest you do it, it can be a rather tricky thing to navigate, going through the city permitting processes and other municipality processes. So get them to do this one, but they'll apply to the municipality, get all the permits, and they'll make sure the municipality will make sure that your intended construction is going to be compliant with the bylaws. Next part, they'll also reach out to the utility and get the approval from the utility. This is really important because you don't want to build your whole system and then find out it doesn't comply with a utility or municipal requirement. I've had a lot of awkward conversations over the last several years with customers who put more solar on than they were allowed to, or had some issues with maybe some neighbors they forgot to inform that they were putting solar on their roof. And we're always able to work through that, but sometimes it requires some expensive rework. So making sure you get that utility municipal involvement at this point is really important. Once you have that though, it's time for construction, time to build your system. Make some noise, make some sawdust, and once it's all up there, you'll get it inspected. Like I said, there are some upgrades that might have to take place and be inspected before you can do the construction of your solar panel system, or where it would be advisable to do that work before you construct your solar panel system. My home, for instance, the structural bolstering. In some cases, you might need to upgrade your main distribution panel or even your service to your home. Once the construction's done though, and you've adhered to all your approved plans, it's time to go into inspections. And this is where the city or your municipality will send out an inspector to look at the solar panel systems, make sure it was installed to your permits, and make sure everything's up to stuff. This is really important because electricity, can beyond being shocking, can actually be dangerous if things aren't installed properly, and could cause fires. And even the best installer sometimes just misses something. And this is where you're going to get a second set of eyes from a code inspector who's going to go through it and make sure everything's up to snuff. And you paid the installer to make sure everything was up to stuff. So it should, you want to have this second check. And then it comes time to commission and turn it all on, make sure your communications are all set up, that you can look at your solar production on your app, and enjoy the benefits of having solar on your home. I think we have a few extra minutes, so I'll go into some interesting numbers I'd like to share with you guys. So if we go to the next slide, Andrew. Solar and YEG. So 1995 was the first time we installed a solar PV generator on the EPCOR distribution system in Edmonton. It was 2.3 kilowatts in a residence in West Edmonton, that one little dot that you see there. We've come a long way since 1995, and I'm sure many of the people on the call today will talk about this. Let's go to the next slide and see what we're at today. So 2020, we're approaching over 2,000 microgeneration sites in the city of Edmonton. In the vast majority, I mean like 99+% of them, are residential solar PV. And it's amazing how this has really taken off in our city. There used to be a time that at FCOR where we treated these as unique and unusual situations, but this is just the normal day business for us now. So we've come a long way, and I suspect this map is going to have more dots and be more colorful now that the federal government is offering the energy retrofit upgrade rebates, which is my next slide. So if we could go to that. So yes, rebates, again, being EPCOR and working at Edmonton, promote the City of Edmonton Change for Homes for Climate program. This is a fantastic program that the city is offering, and I personally took advantage of for my solar. It offers homeowners 40 cents per watt towards the cost of a new system, which, according to the city, covers approximately 15% of the average cost to install a solar panel system. And newly constructed homes and residential buildings are also eligible for a rebate of 30 cents per watt. And new this year is the federal government offering $1,000 per kilowatt, so about $1 a watt, for solar PV as part of their Canada Greener Home Initiative. And this initiative caps out at $5,000, but can have a substantial impact on your cost of installing solar. So you may have noticed little did you knows down there, and I just want to point out this one. The typical home in Alberta consumes about 7,000 kilowatt hours per year. Actually, it's 7,200, but I rounded down a touch, which means the average solar panel system to supply that electrical energy would be about 6 kilowatts-ish. So if you do the math on this, you're going to be looking potentially up to about a $7,000 rebate for a 6 kilowatt system between these two rebates. Which substantially reduces the cost. And I would say you never know how long rebates are going to stick around with. So it might be a really good summer to consider putting solar on your home. So that's it. I thank you for this time and opportunity, and I'll be posting some links in the chat to some really wonderful documents, particularly one from the AUC that's been recently updated that really goes into the nitty-gritty and details of microgen and the rules in Alberta and what you need to know. Thank you.
Thank you, Shane. We'll also be posting this presentation and the links that he's talking about on our website later this week or perhaps the week after, but we will have that available for people who are interested in hooking up to the microgen. All right, we're going to go back here and we're going to talk about our first home. We're going to be starting in another minute here on the Fraser Net Zero Energy Home. And this is our first home for today. Every home today is going to be presented for about 40 minutes. And we have the homeowners available from the homes or builders, homeowners or builders from the homes, and they will be discussing what they did on that particular home with an introduction. It could be a pre-recorded video, or it could be done as a presentation. And then after that, we'll follow with a question period. If you have questions, make sure you send them to Quizmaster, and there's a pound sign or number sign in front of that. So number sign Quizmaster will get to that person. All right, our first home today is the Fraser Net Zero Energy Home, and we're going to be having that presented live by Shefi Kalat-Malo, who is the president of Net Zero Developments. He is the person who built the home, and this is his personal home. He also lives in this home. So we're going to have Shefi present this, and we'll just make sure that he is ready to go. He is live. Shefi, how's it going? Can you tell us more about your home?
Good, thank you. So yeah, like you said, I'm the homeowner. I'm also the builder. I started Net Zero Developments around 2016. I'm very passionate about environmentally friendly solutions, and obviously homes are a big impact on the environment. So I kind of started delving into it, developed the property a few years back. Once that went pretty well, I built my home, and in the meantime, I've been building and helping builders build and achieve net zero on some other properties. So if you want to move on to the next slide here, we'll kind of continue with this presentation. So a lot of people kind of know this, but what is a net zero energy home? It is an ultra efficient home that combines advanced design and state-of-the-art energy efficiency construction with on-site solar panels to produce the annual energy demand that a home needs. Net zero energy homes are comfortable, environmentally friendly, and the best all, finally pretty affordable. Next slide. So the difference between a traditional home and a net zero energy home. Next. So traditional homes are typically built with minimum energy specifications. Recently, those minimum specifications were a little bit better with the 9.36 introduction a few years ago. So they're better than what they were in the past, but they still kind of fall short in terms of meeting net zero energy of what the homes could be. Next slide. They're still largely reliant on natural gas supply. The mechanical systems include a natural gas furnace and gas hot water tanks. There's minimal insulation values. However, they got a little bit better in the last few years. Standard window specs, and they don't have a control for airtightness. Net zero energy homes, mostly they're 100% electric powered with electrical mechanical systems, including air source heat pumps for heating and cooling, as well as for the hot water tanks. They've got upgraded insulation values, usually around R40 walls, about R80 in the ceiling, some underground, under basement slab insulation, as well as triple pane windows, high quality triple pane windows. There's also close attention to air tightness, and obviously a solar PV system to offset the energy use that the home has in a year. In comparison, an average Canadian household uses about 100 gigajoules per year, whether it's natural gas, electric, or a combination of both. A lot of that comes into space heating. With a net zero energy home, it's quite a lot reduced. It's about a third to a half, depending on how well the home is built. Space heating is significantly less because of all the insulation, and a lot of it is basically just occupant load and use. So depending on how efficient the homeowners are, they can reduce that quite significantly as well. Next slide. So in summary, solar energy, so net zero energy homes incorporate a solar PV system and inverters that generate as much energy annually as the home uses. They have easy operation and maintenance. High efficiency electric homes with no gas lines usually means minimal equipment to worry and maintain, and no carbon monoxide to worry about. They're ultra energy efficient. They obtain an EnerGuide rating of 0 gigajoules through the use of high efficiency building envelope, lighting, and Energy Star appliances. They've got a superior building envelope, superior insulation using various products such as rock salt bats, spray foam, rigid foam, which effectively minimizes the thermal bridging and maintaining air tightness, usually of 1.0 air changes per hour or less. Once you get that tight, you have to ventilate mechanically, and that's when your HRV comes in. So their ventilation through the heat recovery ventilation system that filters dust, pollutants, and allergens, but also retains the heat in the winter and cools the air in the summer, making it easier for the furnace to work. The tangible benefits of a net zero energy home that's connected to the grid, and that is what we build. We haven't done any off-grid or battery storage solutions. It's pretty difficult in our area to go off-grid. So connecting to the grid gives you, resale values of high performance homes are generally higher, in addition to the rebates and tax credits for building an energy efficient home that the original homeowner can get. When on-site energy production is abundant, you can sell the excess back to the local supplier. This is your link to the grid, becomes an avenue to export the surplus and create money. This means that on sunny days, a net zero energy home can actually earn an income helping to pay its own bills. And at least with our home, we've actually been able to break even, not just on energy usage, but also on the billing annually. This is just a quick diagram showing you how the utility grid is connected to your house, your meter, your inverter, and then the rest of the appliances in the home, and how the solar panel connects to inverter. Next. So when I started looking at some of the net zero homes in the area, visited a few of them, and the one thing that I noticed is mechanical rooms are pretty complex. So like, I'm an engineer, I'm a pretty technical guy, and even like when I looked at these, I was kind of, you know, shocked with, you know, how complex they are, and thought like, how are they going to be maintained? What if there's a problem? Like, who can fix it? So we noticed that they were expensive to build. They had complicated mechanical systems, which led to, you know, possible operations and maintenance issues for, you know, regular homeowners. So the way we wanted to build them is we wanted to still kind of, you know, I thought that, you know, in order to kind of have mass adoption, they'd still have to be generally, you know, acceptable by most people. Like, they can't be, you know, complex systems where, you know, you need training to kind of figure out how to run your home, as well as trying to utilize readily available construction techniques and materials and equipment to make these homes. And we also have to obviously pay close attention to the details, like with blower door directed air sealing, to ensure design specifications are achieved. So we can say we want to model it, you know, to achieve these targets, but we actually have to like make sure that it is achieved. And especially with air tightness, a blower door is definitely something you can use to make sure you get that target. Next. So the case study we have is the Fraser Vista home. This is my personal residence that I built back in 2018. It's kind of showcasing what you can do with net zero, even on a large scale. This is a 4,050 square foot home. It's got a 2,000 square foot walkout basement, 7 bedrooms, 3.5 bathrooms. Next. And these are some pictures of during the build. We had the City of Edmonton permitting office come and visit, so they can kind of see what we were doing, and kind of like a meet and greet and a learn kind of session between us and them, just so, you know, everybody understands what's being done in this home. Good. Next. And I've got a couple of slides of what the home looks like. You know, from what you can see, it doesn't look like it's anything special. It's like just like, you know, the typical traditional home, and that's kind of what we're going for. Is it doesn't have to look you know, unique. It can look very traditional. You can still have the finishings that, you know, homeowners want, and you can still build it to be net zero. You can just pan through these few pictures here, Andrew. This is the living room. Once again, you know, pretty standard, nothing crazy. You can tell that the window wells are a little thick. They're 12 inches, and that's account for the 2x6 framing, as well as the 6 inches of foam that we had to use on this house to achieve our targets. This is just a little picture of the view from that family room there. Kitchen, once again, you know, could be built like many traditional homes. Energy Star appliances throughout, LED lighting throughout. Go next there. This is just the bathroom. Because we were able to make the home so comfortable, we used a lot of tile. Like, we like tile. Traditionally, that gets very cold, especially in the winters. But because this home is so well insulated and comfortable, we use plenty of tile in the home, both on the main floor, the basement, upstairs, and it works very well. This is a picture of the solar PV on the roof. So we designed it so that it faces almost due south. We've got half the roof that is on a pretty good pitch. It's not an ideal pitch for Edmonton, but it's good enough to help us achieve what we need. There's another little solar, I don't know if you can tell here on above the deck there. Yeah, right there. So that picks up a little bit more. Not quite a very good tilt, so definitely in the winter it doesn't produce as much as the rest of the roof. Even in the summer it produces a little bit more. It's I think it's a 312 as opposed to a 612 on the main roof there. Go next. So this home we tried to stick with traditional readily available construction techniques. So it still uses 2x6 framing. We've got mineral bats in between the studs with exterior EIFS. We have EPS foam on the interior of the basement walls and XPS rigid foam under the slab. The HVAC system was an air source heat pump with in-floor and ceiling electric backup. Because we had a lot of tile, we were able to use heated resistance wiring in the tile, and it made it extra, comfortable. We couldn't put it all over the tile just because there's so much of it, and we didn't need that much electric backup. So we kind of just did it around the perimeter of the floor. 66-gallon air source heat pump hot water tank, which did well. We had, we were a family of 4. We had lots of family come and visit over the summer, and plenty of hot water to go around. Like those heat pump hot water tanks work just as good as the natural gas ones, if not better, because they're super efficient. The air barrier, we did not use poly on the walls. We just used it on the ceiling. The walls had a liquid applied air vapor barrier that helped us to achieve a 0.7 air change per hour on this home. So it was better than the 1.0 that we designed for. The solar system was 16.5 kilowatt PV. We had an energy recovery ventilator as opposed to a heat recovery ventilator, just to see how well the humidity aspect of the energy recovery ventilator works. And it worked pretty well. We don't have a humidifier in the home, and we never needed to worry about humidity, especially in the dry winters. It worked very well. We used a 200 amp panel because that's a service we had in the home. We didn't need to upgrade to anything greater. We were able to stuff it all into that 200 amp panel. A little bit of a challenge, but it's doable. We had an air source heat pump dryer that comes with no exterior penetrations. We had a recirculating range hood, same thing, no exterior penetrations. That helped us to achieve our 0.7 air change per hour. And we made sure we had 2 EV chargers in the garage. One is actively being used. The other one is for future additions. So we kind of future-proof the home so that we can have, an all-electric type of lifestyle eventually. Next slide. This is a picture of the utility room. So nothing overly complicated. We've got the ERV, which is that big gray box you see on the wall with the tubes coming out of it. We got an air source heat pump hot water tank, drain water heat recovery coil in the back. We do have a water softener installed. That's what that little box in front is. Our electrical panel, and then solar inverters on the side there. The fan coils, because they're so small and compact, we actually put them in the walk-in closet of the mudroom upstairs. So that's why you don't see any kind of fan coils out here. And then the other part of that air source heat pump is just the outdoor unit, which just sits on the outside of the house. It looks like a small air conditioner. So definitely, brings the maintenance room or the utility room, makes it pretty simple, which is nice from a homeowner's perspective. Go to the next slide. So I summarized the data for 2019. So we moved into the home about summer of 2018. We got data up until the summer of 2019. So the total actual heating, we were able to figure all this out because we had what's called a TED energy monitor. And this energy monitor had little circuit transducers that would connect to each major circuit on the electrical panel. So we knew exactly what our heating system would use, the hot water tank was using, the car charger, other devices that we wanted to monitor. So it's a pretty cool device and it's very accurate. So with that, we were able to see how well the home did in relation to how we modeled it. So as you can see, the total actual heating came in at 9,377 kilowatt hours. We modeled for 9,208. So a difference of 169. pretty close. I think we had like maybe a little bit of a colder year that year. Total actual cooling came in at 1422. We modeled 1856, so we didn't need quite as much. It wasn't a particularly hot summer, I'm guessing. Hot water was pretty surprising at 932, even though we had a few weeks in the summer we had much more family there, a lot more hot water use. We modeled it at 1024, so we came in at 9200. Total actual usage minus the electric car came in at 17,577. Our total modeled was 19,371. So we were technically under on our modeled usage. We didn't have a particularly great generation year. We came in at 17,438. We modeled 20,000 with the system. Might have been a little bit conservative or ambitious. So could have been our fault and kind of over assuming how much we can get out of those panels. But at the end of the day, we came in at very, very close to what we consider net zero. So we're pretty happy, and I'm pretty sure we achieved something similar for 2020 because we were able to take advantage of the solar rates in the summer. So we had higher credit for generating in the summer, and we were just paying the regular 6 cents or so for usage in the winter. Our annual bill minus the electric car came out to just over $1 for the year, which was pretty awesome. You go to the next slide. We've built a couple of these now. I'd like to share some lessons learned in considering the grid load considerations of resistance electric heating devices. Air source heat pumps need backup resistance heating elements in most of Canada. So they work well down to about -15 or so. Past that, they're going to need some kind of backup help in order to get them down to the days where you get to -30. So that's quite a load on the electrical grid when you're -30 in the middle of winter. You're using your home and you're using your stove and you've got all your resistance heating kicking in to keep the house warm. I'm not sure how that impacts the grid. It's probably not ideal. So we've considered geothermal for the heating needs on our future projects. There's one that we're doing right now where we've got a geothermal system that's spec'd. They work very well. They're a little bit more expensive, but they minimize the load on the grid, and they minimize your solar PV heating requirements. So you can kind of save money there as well. They don't need that electric resistance heating device that's going to be kicking in all winter long when it gets down to -30. So it's definitely easier on the grid. This also allows more solar PV energy for general use, which was slightly underestimated in another home that we built. So it's good to pack in a little bit more if you can. Like Shane said, with EPCOR, you have to kind of design for what you need, so you can't really over design on how much solar you're going to put in, but it definitely helps when your heating system is a little bit more efficient. PV estimation should be based on ideal conditions. That's kind of hard to meet, so a little bit of maybe a 10% greater would be okay, just to meet those times when those summers we don't get a lot of heating or don't get a lot of energy out of the solar panels, and it could be a particularly cold year. As I mentioned, the ERV worked better than an HRV that we had in a previous home. Our humidity control was a lot better. They're still very high efficient items, but the ERV kept the home a little bit more comfortable. Air source heat pump hot water tank. Room requirements are greater than 100 square feet. Otherwise, it cools the space and the room that it's in, thus affecting the efficiency. In my home, we had quite a big utility room, so we didn't really feel that issue. Another home that we built, it was closer to the 100 square feet. Even that seemed to be, a little low because that room was considerably colder, and I don't believe the hot water tank was quite as efficient as it could have been. Air leakage is extremely important, and even more so in net zero energy homes. That's how we use blower doors to direct our air sealing during the construction process. And then once again, we verify our air tightness towards the end, just to make sure we achieved it. Next slide there. Um, so energy saving tips for net zero energy homeowners. Your thermostats with, especially with air source heat pumps, they work most efficiently when you just set them and you forget them. So set them for the temperature you want during the winter, set them for the temperature you want during the summer, and then just leave them. It's not good to have setbacks just because they have to work so much harder to come up to temperature in the winter than like a gas furnace, and they lose some efficiency there. It's good to close your blinds in the summer and open your blinds in the winter to take advantage of solar irradiation. Run your appliances during sunny periods of the day to take advantage of solar panel production. When you're using your solar directly rather than feeding it to the grid, you don't have to pay those, transmission fees that you do like later on in the evenings, when even though you bank that during the day, when you pull it back from the grid in the evening when the sun's not shining, you get charged a little bit more on transmission. So it's definitely good to use your sunny days for whenever you have to do the washing machine, do the dryer, whatever else you want to do in the home. And as our mentor once said, there's no such thing as net zero energy homes, just, net zero energy families. So it's good to consider your load and your usage in your home. Future considerations, like we said, geothermal systems and technologies to be considered when feasible, depending on, if you've got an acreage, or if you've got a lot of land, you can definitely make use of geothermal systems. There's in the horizon, there's air source heat pumps that use CO2 for better cold performance and efficiency. So, that's a technology that could be considered if you're building a home. You want to maximize the use of exterior foam with an exterior air vapor barrier with close attention to controlling condensation and the dew point. We found that the liquid applied barrier works better than poly, especially, considering during construction that poly can be compromised by other trades, after it's been put in, and you don't really know what happens if you're not keeping a close eye on it. Whereas with the exterior air vapor barrier, once it's applied, it's solid. It goes, it doesn't really change even through the years. Electric vehicle charging with the possibility of using a load sharing device to minimize panel loads. A lot of homes, if you've got only a 100 amp panel or 200 amp panel, it's tough to dedicate, 40, 50, 60 amp breaker just to an electric charger. There is devices that are out where you can share a circuit, let's say for the stove. So this way you can have the electric charger and the stove use the same circuit, and the device would let the stove run and pause charging if it's being used until the stove is done. This way you can have both without having to have another circuit or more current to worry about. And these devices are becoming a little bit more popular, so they're only going to get better. UV light in HVAC systems to further improve air quality in light of the recent issues we've got with the pandemic. Air quality and such is very important, and putting this device inside of an HVAC system is not too hard to do. Next, so why go net zero energy? The building makes for a better, more comfortable home and has become more financially viable with an aggressive payback of approximately 10 to 12 years, depending on your project, how big your home is, how small it is. It increases the building longevity. The adoption of all electric homes and vehicles will get the society off fossil fuels faster. Another good term that I heard is the cost of action now is dwarfed by the cost of inaction in the future. What little it costs us to put these into homes now is going to save much more than what it will cost to deal with the consequences in the future. And that's it for me. Sorry if I kind of went a little quick there, but I just want to make sure I got through all of it. So thanks again to Andrew and the Eco Solar Home Tour for letting us present and spread our passion, and hopefully there'll be a lot more adoption throughout the years.
Well, thanks very much, Sheffy. That's very nice. I love the presentation. So your home was on the tour a couple of years ago. So I'm just going over to some other pictures over here, and the one I wanted to show, which if I can find it quickly, is the where am I? Sorry, there it is. I wanted to show the air handler in your that's in your closet. So that was very interesting. I thought that was quite quite cool that you were able to move them out of the mechanical room and into the closet. So there was a picture of them from a previous tour.
Yeah. Yeah.
I'm going to pass it over to Gordon now and see, Gordon, do you have any questions that have come in for Sheffy?
I do indeed. What a great presentation.
Thank you.
Thank you so much. I love your use of the tiles, I think you said. It was on the floors and the walls. That's magnificent. We do have a number of questions, and I thank all the questioners for asking them. One of the questions is, can you put geothermal on a city lot as a rule?
You know, I think it depends on your lot. I'm pretty sure when I've talked to the geothermal contractors that they've done it on city lots, they got to do vertical boreholes to achieve that. The lot that we're working on right now is a horizontal loop system because it's on a 10-acre lot, so we definitely have the room to do it. But it is possible on city lots with vertical drilling. It costs a little bit more, but definitely doable.
Thank you.
So,
Gordon, I'm actually going to speak up on that because I actually have geothermal on a 33-foot city lot, and the boreholes are in fact vertical and they're 200 feet deep, and I have 4 of them.
Yeah.
4.
Yeah, which is probably because it's a very highly efficient home. Otherwise, you'd probably need a lot more. That makes it not so feasible. But when you go net zero and you require, not too much heat load, you can get away with 3 or 4 or maybe even 5 boreholes.
I'd like to speak up on this too, being a geothermal guy that I am. I've done about 60 of them in the city. The biggest one we did was with 6 boreholes, 230 feet deep. But most of them are in the range as the same as Andrew's, 4 or 5 boreholes.
Thank you. I appreciate very much that extra expertise in responding to the question. I'm getting lots of questions coming in right now. So I'm going to have to do some special handling here. So can you use the room with a heat pump hot water heater as a cold room? And my suspicion is the question then implies that since the heat pump water heater takes the heat out of the air to heat the water, and thus since it's taking heat out of the air, it's cooling that room, could you then put that water heater in a cold room and have it keep the room nice and cold?
Well, you can't have the room get too cold because that's going to affect the efficiency of the air source heat pump hot water heater. I think it needs a minimum of 16 degrees Celsius, which it's a cold room, but it's not going to be as cold as, people might require for storing, whatever they want to store in there. So it's technically doable, but it's definitely going to affect the efficiency of your unit, which might defeat the purpose.
Thank you. With respect to the exterior walls, what are the pros and cons of, first of all, a double stud wall with dense packed cellulose versus number 2, a single wall 2x6 with Roxol and exterior polystyrene? And we appreciate that, of course, lumber is a huge cost this year, but let's look at a normal year.
Yeah, so cost is definitely a big factor. So they both achieve a similar thing in, minimizing thermal bridging, getting you that big, large wall to get the insulation value that you need. We just found that with the double stud wall, it was a little bit more difficult to find, trades guys that worked, that knew how to put them in. Obviously, their cost is a little bit high as opposed to the 2x6 framing, and any construction crew can do 2x6 framing. So we went with that because we just knew that it was easier to find people that can do that. And then EIFS, there's lots of EIFS trades, stucco guys. The difference between a standard 1.5 2 inch versus 6 inches is just it's a little bit harder to work with, but they can still do it. So we wanted to make sure that it's something that's going to be very accessible, depending on no matter what home we build. And I believe that the cost is a little bit better with using the standard construction techniques rather than going 2x4 double stud wall or even ICF or SIP panels. Like we explored a lot of different options when we were first looking at it.
There are lots of options, aren't there?
Yeah. Very, very, and that's
Um,
we wanted to simplify it just one in general and stick with it, and it's done pretty well for us.
Yeah, thank you. You've mentioned the acronym EFIS a couple of times. Could you unpack that a bit, please?
I think it stands for exterior insulation framing system or something like that.
Can you help our listeners understand, though, how it's applied, or
Well,
Do you have any-
essentially,
do you have any
yeah.
pictures, Andrew?
So regular stucco is you've got your OSB, then they put their scratch coat on, then they usually use a mesh system, and then they apply like a thick layer of the final whether it's acrylic or no, they don't use acrylic, they use stucco. With EFIS, you still have your scratch coat, but then you apply a foam EPS foam layer, whether it's an inch and a half, or 2 inches. And then you can finish it with acrylic stucco. So it gives you a little bit of a finer look. So it adds insulation value. The EFIS system adds insulation value to the exterior of your wall, as opposed to a standard stucco system that doesn't add any insulation.
Uh-huh.
Yeah.
I see that somebody wrote into the chat and said that EFIS means externally insulated finishing system.
Yeah, that's what it was. Sorry.
I had a very interesting question here from the chat room. How is the 2030 Canadian Building Code minimum standard affecting and influencing home builders now regarding the net zero requirement, the net zero energy ready requirement that will be coming down in 2030 with the code? Do you have any comments on that?
Well, we're already building purely net zero homes. We're not even building net zero ready homes. We're already going to net zero. So I think it will impact most other builders because they obviously have to, apply that. The costs are going to change, things like that. As far as us, like we've already basically adopted that and then some. So yeah.
Did you find it was hard to adopt at all?
It's definitely more challenging to build these homes in the traditional home. You got to work with the tradespeople. There's a lot more supervision on site, and you got to kind of explain it to some of the trades guys why you're doing what you're doing. Obviously, not everybody's going to want to build net zero, so it limits our market. But we only build a few homes a year at top, so we're not too concerned.
I was quite fascinated last year. Another builder, a very small builder, he wanted to do net zero in his house, the house that he was selling for the market. And at the end of the project, he said, I don't know, net zero is so easy. I don't know why everybody's doing it. This was just amazing. That's what he said. And I was thrilled with that kind of an attitude. Another question, what was the cost per square foot of your house?
Well, that one's a little bit tough, and it is built with the finishings were substantially upgraded in this home. So I don't know if it'd be fair to use that as what people can expect.
Right.
But I think it was about close to the $300 a square foot mark.
Right. Okay.
Finished basement, landscaping, definitely higher end materials. So
could you remind us what the R value was of the typical 6-inch wall?
A 6-inch wall, I believe it's about effectively, I think R16 or R17, something like that.
Okay, thank you.
And what were your walls, Sheffy?
They were about R40.
40.
Yeah.
Sheffy, I have a question for you. You talked about an energy recovery ventilator versus a heat recovery ventilator. Could you tell us a little bit more about the energy recovery ventilator? So the main difference between the two is the energy recovery ventilator accounts for humidity as well. So it will try to capture the humidity or control for humidity in the house, as opposed to just the heat in a heat recovery ventilator.
Thank you. Does your ERV, your energy recovery ventilator, manage the humidity does it manage the humidity well? Does it remove and add humidity?
It prevents humidity from escaping during the winter, and it prevents humidity from entering the house during the summer. And It worked pretty well. Like I said, we were comparing this to a previous home where we used a heat recovery ventilator.
Yeah.
I know for sure it was drier in the HRV home than it was in the ERV home. In the HRV home, it was still good. We didn't get like, shock when we were, on the carpet and then you touched, light switches like some homes do. But we used a monitoring device. I think it was around 15% humidity is what we got to in the HRV home, and the ERV home managed to be around 20% or, just under 20%.
By what set point do you run the ERV in your house? Do you set the humidity, for example, and then it turns on and off as a function of humidity, or what?
For the Zender unit, I think I just left it on the defaults. I don't actually know if it's got a humidity set point per se.
Oh, okay.
I'm sure it might somewhere, but I think we just kind of left it at default. It's the same thing with the temperature. They have a temperature set point they use as well. I think that one I did set to, I think, 21. And that it changes how it allows cool air to come in during the summer. So it will bypass the HRV during summer nights to allow cool air to come in, and then it will put it back on during the day. And it uses that set point to control that.
Thank you. We do have lots more questions to ask, and we have now 5 minutes left on your presentation. So I just want to zip through these questions.
Sure.
Is there a way to add additional solar PV to offset your electric vehicle charging needs?
My house is pretty maxed out. So I would say not on my property. On a different property, if you wanted to, you can probably, squeeze that in, especially if it's, a brand new construction.
Yeah, right. Thank you. It was great to see that your annual bill, except for the EV charging, is I think you said $1.58 or something. Are you on the Solar Club pricing?
Yes.
Oh, you are? Oh,
yeah.
Okay.
Yeah, so it's like 22 or 23 cents during the summer and like 6 or 7 cents during the winter. And I can just change it during the spring and the fall as I choose.
And it's actually now this year raised to 25.85 cents.
Yeah.
Which is great. Yeah. There's a question here that says your main distribution panel board is very full. Would you consider a large panel board if you were to do it again?
Actually, you don't see a little sub panel that comes off that. So I do have a little small sub panel on the adjacent wall that's used for the backup heating system. But no, that panel did well. There's still a few circuits that are open on that panel, and my house is fully built out, basement's built out, so I don't see the need for anything extra in the future.
With the air handler that you have, where are the air filters for them?
They're upstairs in the mudroom, and they're built in a way where those filters are accessible. So I have a little kind of latch that I can, an opening that I can open up, remove the air, the filters, clean them, and put them back.
Okay, thank you. There are a few questions here on geothermal, but that doesn't really apply to your house. So in the interest of time, we'll go on to a couple more questions. Did the energy monitor require an electrician to install the current transformers on all the branch circuits?
Yeah, we had the electrician do it. It's not super hard. Like, it's something that you can easily retrofit into an existing panel. But it's better to have it done by, because you have to remove the wires that go into the circuit, loop the transistor through, and then put them back in.
Yeah.
All right. Well, thank you, Gordon. Thank you, Gordon and Sheffy. We'll need to stop there.
Yeah.
We are going to be moving on to site number 10, which is our Cromdale home. And today we have the owner of that home, Shelley Robichaud, who's going to tell us about it. And we're going to start today with a video interview that I recorded earlier, and we'll run that first, and then we'll come back and we'll ask Shelley some questions. So let's run the video. Solar Home Tour. My name is Andrew Mills, and today we're going to be talking about an eco-friendly retrofit of an 80-year-old home in the Cromdale neighborhood in Edmonton. With me today is Shelley Robichaud, who's the owner of the home. Welcome to the Eco Solar Home Tour, Shelley.
Thank you, Andrew. Pleased to be here.
Your home's an interesting example of a retrofit of an older home where you've managed to get the home all the way to net zero energy levels. That's fantastic. Give me a bit of background on why you chose to build your home like this. What were the main things you were trying to accomplish?
So our home was built in the 1930s, and we bought it in 1996. And ever since we've bought the home, we've been attempting to bring it to the most environmentally friendly standards that we can. Without disturbing the original structure. As I said, it's a 1930s home. It was built with old materials that we don't feel that should be wasted. We've revamped or renovated just about every inch of this house. We replaced the wood shavings that were in the attic with proper insulation. We've upgraded the asphalt roof to the metal roof, which has a 75-year lifespan and can be recycled when it's finished. We replaced the lath and plaster from the inside of the house and added insulation to the inside of the house because we didn't want to disturb the beautiful stucco on the outside of the home. This is a really normal house. We do have an induction cooktop and we have a heat pump hot water heater, but we cook and we use our hot water heater. And what basically runs the energy efficiency of this home is our lifestyle. We hang our clothes to dry. We run our major appliances during the day so that we try to run them as often as we can using the solar power rather than using regular or pulling electricity from the grid. That's our choice on how we run the house.
Well, let's take a look at some of the pictures of this house. This sounds really interesting. First of all, what would you say is the most outstanding feature of your home?
I think the standout feature of my home, again, is that it's just a normal home. We've retained many of the original features of the house. We just happen to use very little power or water. We didn't do this with complicated automation or expensive automation. We're just really cognizant of our need to conserve. You very seldom see an extra light on in our house. Our neighbors often comment that they don't think we're home because there's no lights on. We don't run the dishwasher unless it's full. We don't run the laundry unless it's full. We keep the house at 19 in the winter. We're just very conservative people.
So when we build energy efficient homes, we make a series of energy efficient choices. What would you say were the main choices you had to make as far as energy efficiency?
I think every decision that we made regarding this home had energy efficiency in mind. When the windows needed to be replaced, we replaced them with the most energy efficient windows that were available at the time. We changed the wood shavings to fiberglass insulation. We buy our appliances based on their energy efficiency rather than anything else, mostly, you know, whether the price or how well they run. One of my silliest stories is that I bought a $35 light bulb and had it shipped from Saskatchewan when LEDs first came out because I wanted the most efficient light bulb on the market. As part of that, we're really early adopters. We bought a programmable thermostat in 1987, and that programmable thermostat got moved to 4 different houses that we lived in. And I'm sure that programmable thermostat saved the environment, but it also saved us thousands of dollars on our gas bills.
Interesting. So
when solar became affordable, we put on a 3.5 kilowatt system, or affordable to us, I guess. We put on a 3.5 kilowatt system. And since then, we've increased it to a 9.4 kilowatt system. Last year, our energy costs, I'm very pleased to say, was minus $340.33. So I'm really excited about that because that's heating our house, running the electricity in our house. It's just great to me that we were able to do that.
That's really good.
Yeah. So I guess the biggest reason that we increased the size of the solar was that we knew that we wanted to install the heat pump, and we knew that we wanted to get rid of natural gas. At some point, we'll probably end up with an electric car, but they need to come out with a good, inexpensive electric truck before I do that. To supplement our home, because our house because it's an older home and it's not as energy efficient as it probably could be. The heat pump works fine. To supplement our heat, we also have a wood stove. Although we put in the wood stove years ago, probably when the Montreal ice storm happened, and as part of resiliency as well. Put in the wood stove because I knew in Alberta, if the grid ever went down, we would be in such trouble very quickly in the wintertime. So the wood stove also just provides extra heat, and we bought the most efficient wood stove available at the time on the market, and it has a catalytic converter in it. So the particulate matter is very low that comes out of this guy.
That's really good.
We have a heat pump hot water system. We put that in 2018. We also have a drain waste recovery. So that heats up the water from the from the water that's going down the sewer, heats up the water that before it goes into the hot water heater. It mostly is used with the shower. When you're having a shower, it's heating the water that's going into the hot water heater before you do that. We also have low flow shower heads. We have a low flush toilet. Everywhere that we can conserve water, we conserve water.
That's great. Are there any other features of your home that you'd like to feature, such as permaculture? You mentioned you're looking at an electric truck in the future. Anything else you want to talk about?
Yeah, so I've been a composter probably for 30 years. This is an example of my compost. I'm not a crazy composter. I dump my compost into my compost pile once when it needs to be, and about every 2 years I pull the compost out and I put it on my garden. So my garden has eggshells and etc. in it. I'm not much of a gardener. My lawn is nothing special. I use my electric lawnmower to cut my lawn, and I have never put any herbicides or pesticides on it. Live and let live is what I try to live with. I'm not sure that all my neighbors agree with that, but that's the way we do.
All right. So what would you say is the most challenging aspect of building your energy efficient home?
So one of the things that we've had a problem with, or not a problem, but a challenge with, is with the air source heat pump, the controller I find is a little bit difficult. As I said, when we had a programmable thermostat, it was very easy. Just let it run. This takes a little bit more energy to use, physical energy to use. We haven't been able to modify it to be programmable to the way that we would like it to be programmable, and the fan runs constantly. So what I end up doing is turning the thing off because I just don't want the fan to be running cold air. So if there was anything that I could change about it, that would be something that I would change about it.
Well, I hope you're able to find a controller that will be able to update that in the future.
Yes.
What were the key costs in building your energy efficient home?
I would say that the solar and the heating system were probably the key costs on the project. As far as time, I think the biggest time we spent was doing all the insulation, because we did have to take down the lath and plaster and re-insulate the walls. We did that over several years, so it was built in.
Is there anything you would have done differently in building your home?
So when we bought the home, obviously in 1996, solar was unaffordable. But the orientation is if we could have gotten a full south-facing big wall or big roof space, it would have been great. As it stands, the east, west, and south that you can see in the picture works fairly well for our solar, and it's on the garage, so that the trees, thankfully, are not much of an issue as well.
So what aspect of this build would you say was the most satisfying to complete?
I love the solar. I really love the solar. I love that I am able to look at my energy consumption on my phone. I love that I'm able to look at my solar production on my phone, and I look at it constantly. I hate the days that the solar is covered in snow, and in fact, you'll see me out there with my roof rake taking the snow off the solar, just because I think, oh my goodness, it's a sunny day and we really need to get, we could have be having production right now, even though I know the production is low.
So is there, thanks very much for all of that, Shelley. Is there anybody you'd like to thank that helped you design or construct these aspects of your home?
Yeah, so Evergreen and Gold Renewable Energy put in all the solar. So would like to thank them, especially like to thank my husband, who is long suffering at all the ideas that I have on how we can make this place more energy efficient. And he just happily goes along with my ideas. Thomas Barr really saved our butts on the heat pump hot water, or the heat pump, air source heat pump. We couldn't find anyone else to put it in, and it was December and we needed to get it in, and he happily came along December 23rd and put that air source heat pump in.
Nice. Okay. All right. I think you have a picture of Warren here too. There he is. All right. Well, thanks very much, Shelley. Thank you for joining me today and sharing pictures of your home. I'm really looking forward to coming out and seeing what you've done with the home on the tour this summer. All right. Well, thank you, Shelley. And I'll hand things over to Gordon so that he can take any questions that are there. Gordon, will you start the questions?
Yes, thank you so much. My goodness gracious, Shelley. It's so delightful to see something so old being made so environmentally appropriate for today. Thank you. I'm actually very keen myself on the wood stove for resiliency purposes. I really like that idea, and I'd like to do it in my own house too. So what brand of wood stove did you find?
It's a Dutch West wood stove. We put it in, I think it was in the late 90s, early 2000s.
No, we did it right away.
Oh, sorry, Warren's with me as well. Yeah, it's a Dutch West.
And you said it had some filters on it?
Yeah, it's got a catalytic converter in it. So it's got a secondary burn that burns off the particulate.
Aha. What do you do about cleaning out the chimney?
So we have chimney comes once a year. I do it in the spring, have them come out and clean the chimney. And about every 5 years, I have them inspect the wood stove. My dad was a fireman, fire chief, so wood burning or fires have always terrified me. So I want to make sure that this guy is as safe as he possibly can be.
I actually used to heat my house years ago with wood, and I loved it. I loved it to pieces. And we would purposely use green wood and purposely have a chimney fire every once in a while to clean out the chimney. And everybody thought I was crazy, but hey, it worked fine. What effect did the wood stove have on your insurance of your house when you added it?
Okay, well, the wood stove, when we first had the house, was not a problem. Because it was professionally installed and it was inspected by the city of Edmonton, it wasn't a problem. But we recently tried to change carriers, and it was a problem. The carrier accepted our insurance, and then they the insurance carriers accepted our insurance and then they canceled it about a month later, saying that we can't have the wood stove. So we were able to reinstate it with our old carrier, but that, in my mind, that just means from now on, we will never change insurance carriers again. They asked me all kinds of questions about the solar. I had to show them pictures of the solar. I had to get all kinds of stuff on my solar panels, but they asked me no questions about the wood stove until it was too late. So it was an interesting process.
And I find that some insurance companies are fine for solar and some are not. So it does pay to shop around.
Yes.
Some other questions here from the chat room. How many square feet is your home?
It's about 1,700 square feet.
And how many occupants?
2. You're looking at them. Well, and 3 dogs.
3.
But they have their own, they come with their own fur coats.
How much wood do you use in a typical winter to supplement your heat pump?
Oh, 2 cords.
Oh. And if, I forgot, I apologize. Did you upgrade the wall insulation or ceiling?
Yeah, so what we did is it was basically wood chip, 2x4, 16-inch centers. And it was good. It was actually quite good. It was hadn't fallen or anything, and it was real well packed in there.
Yeah, it was right to the attic, or right to the top of the walls.
But we removed that, and so we bought the house in 1996. At the time, I was fully aware of R2000 was basically the standard to try and achieve at that time. It's long before. To put it in context, it was around the time you put your first system on the grid.
Yes.
And so even if solar was affordable, it wasn't grid connectable at that time. And we certainly didn't know anything about net zero. And so we renovated the house we tried to do a R2000 standard. So we took the shavings out, we put batt insulation in, and then we put rigid foam horizontally across the inside of the studs to remove the thermal bridging.
Ah.
The house was built in the 30s, had not really been renovated, which is what the attraction was for us when we bought it. And then it had a cosmetic renovation in the 70s where they did a bunch of structural problems. They removed low-bearing walls and didn't replace them with beams and things like that. So we basically took the house back. Exteriorly, it looks much, they put in like picture windows and stuff like that. We took those out, put the sash windows back in, stuff like that. So we have wood frame windows, wood windows on the inside that are aluminum clad on the outside. And they may not quite be as energy efficient as, modern casement and stuff like that.
But aesthetically pleasing.
But we're kind of in a historical area of the downtown area. So we tried to maintain that from the exterior as much as possible.
And we also, there was no insulation in the basement when we bought the house, and there was no insulation in probably half the attic, like 0, or maybe a little bit of vermiculite actually. So we blew cellulose into the attic, and then we furred out the walls in the basement and added insulation into the basement. So
Yeah,
your
the
base.
walls are, sorry.
Go ahead.
Well, the walls upstairs, so we have a story and a half, or what's known as a semi-bungalow in this area. The walls upstairs actually had 0 insulation.
yes,
And so it's kind of hard to imagine that for 60 years, they had, I don't know what they did upstairs, froze, I guess. And so, we did it, and it was really, really hot in the summertime upstairs, and of course, cold in the wintertime. And so after we were done insulating the building envelope, for the most part, we did them kind of one room at a time. Substantially, we replaced all the plumbing, all the electrical.
yeah, we had tube and knob. There was tube and knob.
Yeah,
Wow.
and then we renovated basically one room at a time. And so as we did each room, we upgraded the insulation primarily, and obviously did the electrical and stuff like that. And now people think we actually have air conditioning. So even though we have a heat pump, we don't use it as an air conditioner. But most people, when they come in our house in the summertime, think we have a heat pump. And it's really because the house is sufficiently insulated for that.
That is so magnificent that you were able to achieve that.
Mhm.
Yeah, and I would say the differentiation for us, Shelley mentioned it in the video, is our home is probably, it's not nearly as airtight as a net zero home. Doesn't have the super levels of insulation. And so as Gordon's aware, and I think Andrew as well, obviously, because we were on the tour a couple of years ago, this is our second net zero retrofit. The first one we did was our office, and that building was built in 1959. And that's more of a typical net zero, because it was easy to demolish the interior. It's very, very well insulated and very airtight. And so we did things a little bit differently. And the reason is that we basically had renovated our house already when we decided we had, in the 90s, we put in a new furnace and a new hot water tank. It was time, they were aged out basically. And so it was time to replace the furnace. It was time to replace the hot water tank. So we decided, again, like we've always done it, we'll do it in stages. Okay, it's a little bit easier to afford it that way. And also, had great difficulty finding good contractors to do the kind of work, especially back in the 90s. If I'd said something like this to a contractor, they would have just looked at me like I was weird. So we did a lot of the work ourselves as well. Mm-hmm. And so, but also on the budget side, it's a little easier to do this bit by bit by bit by bit. And so we kind of had a roadmap of what we wanted to get to at the end of the day. And so we knew when the furnace aged out and the hot water tank aged out, that we would just replace them with and go off gas. And what Shelley had mentioned was that our heat pump was installed in December, and this is because, and Shelley alluded to this a bit. So Shelley is the Imagineer, so yes. She dreams up what we're going to do, and then she hands it over to me to make it happen. Oh, and so she just called up
it on the honey-do list.
No, more than.
No, it's a little bit. It's more like the crack the whip honey-do list. But she called up ATCO in April and told them to pull the meter.
And we pulled the meter before we had the heat pump in place, or even a contractor or anything. I thought, I don't want to pay transmission fees for the summer, because why would I? We're getting a heat pump. But then it wasn't as easy to get one.
Well, the company we had chosen was, as you know, it was New Energy, and that was unfortunately the year they went bankrupt.
Yeah.
And so we were in the process of working with them, and then they kind of disappeared. So one of the principals came back and helped us out to complete it. We used A1 Heating out of St. Albert as the contractor, and but it speaks to, I think, our energy use and probably the quality of the building envelope, that we were able to heat the house with just the wood stove.
Yes.
Until Christmas.
Yes.
Yes, which
is great. Nobody froze to death.
No.
Our firewood consumption that fall was a bit higher than it had been in the past, but and of course we had to get up and stoke the fire in the middle of the night and stuff. But I grew up in northern BC, and my parents had a wood furnace, forced air furnace, and so that was not so unusual for me because I grew up that way. The challenge with those systems is that if you want to go on vacation, it becomes a bit of a problem. So they years later bought a hybrid system, which is a propane/wood.
Oh yes. Got actually lots of questions here, and probably only a few minutes left. But there was a really good question from somebody that says, "Do you have a referral to a contractor to renovate an older farmhouse built in 1940? We'd like to renovate it with a net zero goal."
You know, you'd probably have to ask some of the other builders, because we did a lot of this stuff in-house. Yeah. I'm quite knowledgeable about building stuff. We did the net zero retrofit on our office, and we did the vast bulk of the work on our own home.
Okay.
So you'd have to, probably some of the other homes on the tour is probably better source of that.
So for the person who sent in that question, if you would like to send me an email message to info@ecosolar.ca, then let's chat about finding you a contractor. So there's some questions about air leakage. Do you know what your air changes per hour at this point are? And since older homes tend to be more leaky, did you ever get a blower door test done to see how much you improved it? And if so, what was the result?
So we did. We had an EnerGuide test done on the house. Unfortunately, I went to work when it was being done, And I had talked to the guy who was doing the job. All the windows upstairs were left open. And so it wasn't a very good score.
No, I guess not.
And so when we went to put the heat pump in, we just had a heat loss calculation done without a blower door test. Okay. And so we don't have, I'm not a huge fan of, and don't take this personally, Gordon, because I know you're an engineer.
I will.
But I'm not a huge fan of this kind of getting caught up in the minutia of the details, right? It's the end results. So basically, we overgenerate now. So we generate about 8.7 megawatt hours, which is 8,700 megawatt hours or kilowatt hours a year.
Yeah.
But we use 20% less than that. Okay. And it's because of the way Shelley had alluded to it. It's because of the way we use energy. Okay. So there was somebody on a tour yesterday who had a 32 kilowatt solar array.
Yes.
And ours is 9. And so before we were heating our house with electricity and stuff, our array was at 2.5 kilowatts. Shelley had said it was 3.5, but it was really only 2.5. And so we don't actually use a lot of electricity. And so
No, we don't.
last year we made $220 on our electricity above what we paid. And this year, because the increase of the solar club pricing is higher, we're right now, the last 12 months is about $330
Uh-huh.
that we're making. We're making that kind of money.
So a credit of 330.
Yeah.
Credit total a net credit over a year.
Yeah.
Okay.
Yeah.
And so in context of what other people have talked about, because we've had this house a long time, this is what also sets us apart from most people on the tour.
Yeah.
Is we paid $125,000 for this house. Our neighbors are selling their homes for close to $700,000. So we're probably in the low 700,000, mid $700,000. So whatever we put into the house as an investment, I think we're going to get our money back. We're unlikely to sell the house.
Right.
So we really don't care once we're dead.
Right.
Oh.
And that's from my perspective, it's also part of our retirement program, right? So we now do no longer have gas bills. Our electricity bills are a lot lower. So for the next, 25, 30 years, we have money coming in are not spending that money for our retirement. So it really was part of our long-term retirement plan as well.
Yeah, and we didn't deliberately oversize the solar. It was intended and estimated to cover 100% of our needs.
Yeah.
Okay.
Yeah.
It just turned out to be that this is the way we actually use electricity. Yeah. It's very low.
That's an important point. Okay, so you didn't get a blower door test done?
No.
Not one that I would give you a number on.
Okay, no, that's okay. Somebody was asking, to remind them again, what's the R value of the walls and attic at this time?
It's probably, an R4 wall is it's R12 insulation plus stud thermal leakage, right? Yeah. And then it's a 2x6 wall, basically. So it's got 2 inches of rigid. That's usually another R10. Okay. Yeah. But because we were very conscious to make them as airtight as possible as well. Most of our windows are double glazed. We do have some triple glazed windows in the home as well. I would say you could probably say it's an R15 and R18 wall, something like that. The attic is cellulose blown in. And so it's probably more like an R40. Okay. Nothing crazy. This is not a freakishly over-designed, over-insulated home. I would call this, if you had built a home in the 90s, this would be a good quality, well-built home in the 90s from an insulation point of view.
Yeah. Some other questions. What was the total cost to the retrofit?
That's a really difficult one to say because we started it in 1996, so we didn't calculate it over the time. The cost of our solar and our heat pump hot water heater was about 35 grand. So,
No, I think it was a bit more than
well, okay.
that. Our solar, yeah.
Another question.
Yeah.
What electrical upgrade did you need to do to accommodate the increased electrical consumption?
So we have 100 amp service, and it is stretching that, I would say. We don't use our clothes dryer. Okay. We have a high technology clothes dryer. It's a wind solar hybrid,
Oh, yes.
which in English people call it a clothesline. And so we really don't use our clothes dryer. And so that's a fairly major load that we've taken off, potentially off the house. If we had done this from scratch, I would have put in a 200 amp service. But we had already done all these renovations. We had done, when we bought the house, it had a 60 amp service. We took it up to 100.
Yes.
All of that. So, yeah, we try to make it work, right? If I had been concerned about the overloading of this service, we would have upgraded it. So that was always in the plans. Let's just try it, put it in, try it, see how it works. If there's issues, then we upgrade the electrical service. Okay.
All right, we do have the electricity comes into the garage. All of our solar's on the garage. And so we have a sub panel in the garage, and then it runs underground into our big panel in the basement.
Yeah. I'm going to be retrofitting my house and putting on a large PV system, going all electric for the heating and putting in an EV. And I'm going to be keeping it 200 amp service also. I think if you know what you're doing and you understand the code and the regulations, you can do this.
I'm going to speak up. I'm going to speak up here.
Yes.
When I did my garage, I brought 200 amps to the garage and updated the panel in the garage, and then took a 100 amp circuit back to the house, to the old house circuits. And you've already got your 100 amps to the house, so you could easily do that when Shelley buys her new Rivian.
That's right.
Well, and that's actually exactly what we're planning on doing, because it's quite cheap, right?
Just to do the garage, yeah, it's
Yeah.
quite inexpensive. So
Yeah,
when you get that big electric pickup truck, you might
That's
need
right.
the extra.
Yeah, the power pole is right next to our garage, so it's about a 10-foot drop for EPCOR.
Yeah.
Yeah, so the cost of doing a 200 amp into the garage is relatively cheap, for sure.
How much more time do we have, Andrew?
We've got about 2 minutes before I give you the 5-minute warning. How about that?
So,
Okay.
so the other thing I would mention is that I don't think anybody's really mentioned this before. So we don't have batteries, but we do have energy storage, okay? And our energy storage is in the form of a hot water tank. And so when we bought the hot water, it's a heat pump hot water tank, and it has a smart grid capability. And what this is intended for is, in some jurisdictions, the utility actually can connect and disconnect smart grid appliances for peak shaving purposes, okay? That's not a feature that's utilized at the moment in Alberta. And so instead what we do is we utilize this ourselves with a timer. And so we actually tend to use the most hot water in the mornings when we shower. And so then we delay the hot water tank reheating the water until the sun's out and our solar is generating. And then we maximize the self-consumption of it. And it's just through very simple technology. It's just a timer. And so our assumption is that by 10 o'clock in the morning, the sun's going to be generating enough that it'll, like if it's not in the middle of the wintertime, that we will be able to use most of our generation to reheat the water, okay? And so this is, the earlier house to ours today went through this a little bit. It's your better economics because you have both delivery and energy savings. And so you're saving both the energy charge and the delivery charge.
We also have I have a consumption meter on my phone. So as part of our SolarEdge inverter, I have a consumption meter, so I can see as soon as anything turns on and what the consumption is. And I have become obsessed with it, and I look at it all the time, and I'm running around turning off things. And like if there's an extra load on my house, I have got that off. We don't have any vampire, what do they call those?
Vampire loads.
Vampire loads. We don't have any of those. We like everything's on a switch that I can turn it off. It's like I am ridiculous at this. I've will not buy an appliance with a clock in it, because why would I use that 1 watt of energy to run that clock? So we're really, really energy conscious.
But you can certainly utilize, smart appliances for
Yes.
some of these features as well, rather than doing it yourself, running around.
Yeah.
And so, but this is what I find is that a lot of people get really bogged down on the technology, right? And that tends to also scare people away too. And they also get deep into the numbers as well.
Oh,
So for me, what's important is we don't have any gas.
Right.
All of our
That's-
energy needs are met by electricity.
Yes.
And we do about 120% offset of that annually. And so this is the big difference. And the reason we chose to do this is because it was actually to put a larger solar array on our home was the cheapest thing to do. It was far cheaper than gutting the house and rebuilding everything, especially this year. If you look at the price of what wood is, solar is the cheapest option, and it's fast. It's like a week to put solar on. It took us 25 years to get to the point
yes.
where we could do it.
And
Yeah.
as Warren said with the wood, that's a real concern of mine, is that this house was built with old growth forests that come from BC. It was built in the 30s. You know that fir in the basement is old growth wood. That's going to take another 800 years for those trees to become those trees. It seems a little crazy for me to be knocking this house down and getting rid of all that, just landfilling that wood after 80 years, when it took 800 years for that tree to grow.
That's such a great statement.
I think we
It's
need to respect
wonderful
that.
that you said that. I'd never thought of that before. And I also love the fact that you think of your water heater as energy storage. And yes, absolutely, that's perfect. But I'd never thought about doing it that way before.
Yeah, and I mean, some of the inverters today, only in the last couple of years even, have features now where they can do these kind of self-consumption automatic. Right.
And I'm understanding that the Solar Edge inverter you can get now also has a feature where it will charge your car only from the sun if you set it up that way.
Yep.
So very easy.
Yep.
So my new truck, when I get that Ford F-150, will only be charged during the day.
Yeah, I think.
The Lightning.
Yes.
And so I think the other thing as well is that our solar is, we just took what we had. And so our garage actually is a great location for solar. And what people don't appreciate either is because we live so far north, everybody realizes that in the summertime, the sun comes up in the northeast and sets in the northwest. Well, our solar array predominantly faces east and west. It's a 412 pitch, so it's relatively flat. And so the picture that Shelley had in the video, aerial picture, shows that we're actually generating a long time throughout the summer days. This is when the bulk of our generation occurs, but it's also occurring, it also allows us to do our self-consumption for a longer period.
Yes.
It's not facing south. It's facing east, it's facing south, and it's facing west. And throughout the day, we're generating for a more constant period of time.
Thank you, Warren. I'm going to just break in there and thank you, Shelley and Warren, for sharing the pictures and the information on your terrific retrofit. I love to see an old house retrofit to net zero. I've done the same. So it's great to see that. We're going to move on. The next thing that we have coming up is the Sundance retrofit. So here's another retrofit, 2 in a row. And this is being done by Butterwick Construction, led by Peter Amarongan. And Peter is going to do a presentation now on the actual Sundance retrofit. Let's just hand it over to Peter right Now, Peter, tell us more about what you're doing.
Thanks, Andrew. Can you hear me okay?
I can.
Good. So let's just start with the big picture. So greenhouse gases in the atmosphere are a lot like water you left running in the bathtub. If you don't turn the tap off, it's eventually going to wreck your house. And it isn't enough to just crank it back a little. You've got to turn it right off. And at the rate we're going, Edmonton will have dumped its global share of emissions into the atmosphere in the next 6 to 8 years. So this is an emergency. And next slide, please. Buildings are responsible for about 40% of those emissions. Next slide, please. And of those buildings, 70 to 80% are that we'll be using in 2050 when we need to be carbon neutral are already built and filling that tub. Next, please. So there's just no path to a decent future for our kids without industrial scale deep energy retrofits to existing buildings. Next slide, please. A few years ago, some NAIT students came to me looking for suggestions for an energy conservation related capstone project for their Bachelor of Technology. And I suggested they do a deep energy retrofit feasibility study for the Sundance Housing Co-op because I knew the co-op would be interested. And in their research, they came across the Dutch Energy Sprong system where they build a whole new energy efficient shell around existing buildings. The panels are built in a factory. They come to the site with new windows, new siding, insulation, and they turn these old townhouses into net zero energy buildings in a matter of weeks or months. They even have solar panels that go on there, and they call the whole system zero on the meter. They guarantee zero utility bills. So the Sundance Co-op was built in the 1970s. It's a 15 building, 59 unit townhouse complex run by very far-sighted co-op members who manage for the long term. When it was being built in the 70s, the building code was about to change from 2x4 to 2x6. And the co-op made the decision back then to give up closet doors so that they could afford the 2x6 walls. And more recently, they were about to renew their mortgage and their lease with the city. And they knew this would be a good time to look after some maintenance backlog and any upgrades that they might need for the foreseeable future. Fix foundation issues, grading, add egress from basement windows, and prepare for a zero emissions future and higher carbon taxes. And the approach was, let's do this once and do it right. And they had Stuart Fix from Renew Engineering do a building condition assessment. He hired me to help him with that, and Dave Butterwick from Butterwick Construction to do the pricing. And it came in, the initial price was around $5.4 million. Next slide, please. While the co-op was considering the next steps, we heard about some R&D funding from National Resources Canada, which we applied for and got. And the $2.5 million made the co-op, the financial decision for the co-op easy. And we're enormously grateful to Enercan for this opportunity. But I can tell you, they're getting their money's worth R&D wise. Next slide, please. So we're starting with some pretty complex buildings to just start with this approach. We've got tight little jogs, we've got cantilevers, we've got porches in the way, we've got a few member built additions, mature landscaping, and a number of complications. In preparation, I had a tour of some buildings in the Netherlands, and I showed my tour guide, Simon Verdoen, these photos and said, Simon, what would you do with this cantilever? What would you do with that jog or these doors that are so tight into the corners of porches? And Simon said quite cheerfully, well, for us, that would be a no-go. So we knew we had our work cut out for us. So we're basically wrapping these buildings in a nice warm parka that reduces heating by about 70%. The wall panels are part of the wall system. We fill the gap between the panels and the existing walls with cellulose, make it airtight, and essentially wrap the whole thing in a nice warm parka. Our panels are made by our partners in Killam, Alberta. They're very lightly framed, 2x4, 2 foot on center, just enough structure to carry the siding, insulation, windows, and withstand wind loads and the stress of handling and transport. They arrive with the windows and most of the siding installed. But before we can, before they can start building, we need to know exactly the size of the buildings, where the windows are, where the doors need to go. We really need to accurately dimension the buildings. And we're using some pretty cool technology to do that. We start with a laser scan of each building. And well, actually there are 55 scans across the whole site, which results in zillions of laser dots in space, like points essentially, that get registered together into one gigantic 170 gigabyte file of points. And then he clips out our surveyor who did this for us, clips out the individual buildings and sends us a 5 to 10 gigabyte file for each building. Next slide, please. Which we then bring into SketchUp to draw the panels from. So we were able to import the point cloud using a software called Undet from Lithuania, and it can, with some direction, look at what looks to be a sheet of points, and say and find the best fit plane that incorporates most of the points that look like they're in that plane. And it's fuzzy and it takes some interpretation, but we're finding it to be pretty reliable. Once we get the basic wall forms established, we install windows that we slide back and forth until they are the very best fit with these somewhat fuzzy points. Then that turns into essentially the building geometry that we're interested in. It's kind of nerve-wracking because the whole time we're doing that, we know the consequences of a mistake. If we put a window in the wrong place, we're going to be stopped in our tracks. All of the advantages of panelization will essentially be out the window, because the windows will be installed. They'll be well sealed into the panels with most of the siding on. And so it's while it's nerve-wracking, it's way better than a tape measure. If we're off, we're going to be off by millimeters usually, where with a tape measure, you might put that wall on the wrong side of the building and not realize it once you got back to the office. So that turns into wall panels with all of the elements. We then divide those into individual wall panels, and we have 4 views of each of those. Next slide, please. Sorry, Andrew, I hope you're keeping up. The one for the framing that shows every framing member, every stud. One for the sheathing that shows the lift points and the cellulose fill holes, and then detailing the water resistant barrier, which I'll talk about again a bit more in a second. And then we show exactly where the siding stops and starts, what goes on in the factory, and what we put on in the field. And it's we end up with 20 to 30 drawings for the panel guys, and they have another file of about 15 drawings that show standard details. And then we do another set of drawings for our crew on site, and another 15 or so standard details for them. So it's a huge amount of work with very careful protocols for checking for accuracy. So while the panels are being made, we're getting the building ready. And we remove the existing porches, and anything that's in our way. And we use a hydrovac truck to essentially suck a very narrow slot around the building that we can drop foundation insulation into. And then we install a ledger around the building and a pressure treated plywood box that looks after the wear and tear that happens at grade. It insulates that area, gives us some adjustability, and it supports the weight of the panels, any overhang that ends up on the roof, and gets us ready for the panel install. And this is a huge amount of work that we're so fortunate. We've got an amazing crew, and we've got Justin Corsero here, our site foreman / construction site manager, who is totally relentless in seeking out faster and better ways to get this done. We have a wonderful, very productive working relationship where we're constantly looking for faster, better, slicker ways of doing this. Justin's on the line today, and will help answer questions toward the end. So then comes the big day. You know, what if they don't fit? Like we've got a crew of 6 people, a crane. We're stopped dead in our tracks if these things don't work. And so far, we've done 2 buildings this way, where we brought in panels from Killam, and we have a 10 millimeter tolerance at both ends of each panel, so that we can slide them back and forth a little bit to get the best fit. And I'm just thrilled to say that we're hardly using that 10 millimeters. It's a huge relief every time. Well, the 2 times we do this, it's a great, really cathartic experience to talk to the guys and say, nope, they're all fitting. And you might notice the flaps of black membrane on the panels. Next slide, please. So we use those to tie together the panels to give us an airtight, waterproof membrane that sits behind a 3/8 plywood rain screen. So any moisture that gets through the hardy siding can drain harmlessly to the bottom. It also, any moisture that happens to breathe from the inside of the building out through this vapor open barrier can actually then evaporate to the exterior. So it also is giving us wonderful airtightness results. Like so far, on average, the starting airtightness on these buildings has been 3 to 4 air changes an hour. And now we're roughly at about 0.6 to 0.7, depending on the building, the exact place, which is exactly where we hope to be. And it really is thanks to the diligence of our panel partners, and especially our guys on site. So at the end of the day, because of this, the co-op will have a very durable fiber cement siding building that will last even longer than normal because it can dry to the back. And these buildings should be virtually maintenance free for a very long time. Next slide, please. To wrap it all up, we're installing a new scissor truss roof over top. But first we install a 6 mil poly vapor barrier that's tied into our water resistant barrier on the wall panels. And then on top of that, once the scissor truss roof is built, we add another R50 cellulose insulation with on top of the R28 that's already there. It gives us basically overall for the whole envelope about the same insulation levels that we would expect to see in a net zero energy building. Next slide, please. And of course, because we've made them airtight, we need to add our HRVs, which have the added bonus of saving even more energy and giving a controlled supply of healthy, fresh air. But in a retrofit, it's a lot different from new construction. We have to install the ducting to the bathrooms and kitchens kind of laparoscopically to minimize the amount of repair and repainting, and also the disruption on the owners who are, or the members, co-op members who are living there. And then we use the existing furnace ductwork to distribute that fresh air throughout the house. Next slide, please. And so the co-op was, with the envelope upgrade so close to net zero energy, they wanted to go all the way and get rid of gas altogether. This would save them another roughly $38,000 per year just in the fixed monthly charges for 59 meters. And electricity is more expensive than gas, but heat pumps are about twice as efficient as well. They produce about 2 units of heat for every unit of electricity you put into them on a seasonal basis. And as the carbon tax ramps up, by using clean electricity, the economics of this will only get better. So then the icing on the cake is that the original 60 amp electrical service was never designed for this electrical extra heating load. It wasn't even designed to the modern code. And so, and the system was too old to upgrade. So we ended up putting in an entirely new electrical system using underground drilling, one new large transformer, and some remote distribution sheds, and effectively setting the co-op up with its own mini utility. They'll send out the bills themselves. We configured in a way that avoided crippling demand charges, which is another discussion. But the icing on the cake was the 350 kilowatt solar array that's being installed and will produce about 75% of the total annual energy that the co-op needs for everything: heating, cooling, hot water, lighting, and appliances. And the rest will be purchased from off-site renewable sources. So it was expensive, or is expensive. It's costing approximately $100,000 per unit, plus about $10,000 for the electrical upgrade and another $8,300 per unit for the solar system. And these costs are being offset by energy savings, including carbon taxes, lower long-term maintenance and replacement costs, enhanced value. The NRCan funding, as I said, helped a lot. And plus they got a favorable lease renewal rate from the city of Edmonton, who were very keen on supporting this project because of its pioneering nature. So whenever we build anything, our job number one is to make life better. And there's no doubt that what we're doing here will make long-term life better. These houses are warmer, healthier, more comfortable. The exteriors are beautiful. We've added skylights in the porches to put light in the kitchens. Nice deep windowsills at every window, bay windows that we've added on the living rooms. And so we've really looked after the long term, but we're also really concerned about the short term. We've got to get this work done with people living there and doing it without disrupting them unduly. So we're working hard to reduce the time that they're in their spaces. And we're working with a co-op committee of hardworking, wise volunteers who are helping us navigate, manage expectations, and solve the inevitable problems and friction that will arise on a project like this with over 100 members, not 100% of whom are totally bought into it. And we are so grateful to that committee. So the learning how to do this is a big part of what we're learning. I want to wrap this up really quickly here because I'm dying to get to the questions. But I've got to mention that we're trying this out on 3 single-family houses starting this fall. And this is just a teaser. One of these houses for sure will be on the EcoSolar Home Tour next year. And we'll hope to see you there. So this is a big story and way too big for the brief time we have here. I would love to get into a lot more detail. We're committed to sharing the lessons learned. We've started an entity called Retrofit Canada, where in the near future we'll be sharing the gory details of this project, how to get started on this kind of thing, and also providing details and case studies from similar projects across the country. So we're just scratching the surface, but I think we should leave it there because I really would like to get to the question. So thank you, Andrew. Thanks very much. And thanks to all of the great sponsors who make this possible.
All right. Well, thank you very much, Peter. That's a fascinating project, and I'm sure there'll be lots of questions. So I'll hand that over to Gordon. And in the meantime, I'll just go back to the first slide here for a second. And Gordon, what kind of questions have we got?
Oh my goodness, do we ever have lots of questions. We definitely need more of these retrofits in future years. So thank you, Peter and Justin and team for doing all the hard work. What I didn't understand in your explanation was you mentioned something about near the beginning about in the design process on SketchUp sliding some windows back and forth. Could you clarify a bit what that was about?
So our program pulls out the geometry, and all we can see the newly drawn SketchUp wall and the point cloud at the same time. They're superimposed, and we have to make sure that the new windows fit exactly where the old ones are. If we get a window out of place, so we have a SketchUp component that sticks to the window, and I can slide it back and forth and up and down until it is as close a possible fit to those fuzzy points as possible.
Oh, I see.
Does that explain that?
Yeah, absolutely. So yes, I see. It's just it's a mechanism of making.
We'll be doing a whole webinar on this in the near future.
How have people from other parts of Canada related to this project when they found out about it?
Well, we've had lots of interest from other people who are trying to get it going. And so far, we've barely started to tell the story. We've been so busy with this fire hose of learning that we're deluged with every day that we haven't really been able to take the time to start to tell the story properly. We're just about to start doing that. But it's like you learn so much every day, you wonder whether what I told them yesterday was still right. It's not exactly that. I mean, there's some rock solid stuff we know, but we're just getting down to that. And there is a parallel project in Ottawa that we're going to include in our webinar series. So there's in Halifax and Pembina, there's interest across the country.
So you think your system will actually work on a single family house?
You know, ask Justin that.
Justin.
Yeah, I think our process would work much easier on a single family home. I think one of the main obstacles that we have is just kind of the complexity of these buildings and the access with the crane to get into these little, to get to these buildings, because we only have a few parking lots to reach from. And so with a single family, the access is going to be a lot easier, and our actual extraction is a lot more accurate with those simpler buildings.
So are people lining up for you to put this on their houses? Or not yet?
Well, we haven't been talking about it enough. I mean,
Ah.
we're one of the reasons we're thrilled to have it on the tour. We're working in that direction, but we're fully our panel partners in Killam are keen. We are going to develop a more like systematic offering as quick as we can. And Butterworth Construction is doing projects like this on a stick-by-stick basis every day.
How much do you think you can get the cost down by doing this a bunch of times and maybe getting any kinks worked out on it?
Justin, do you have a?
Oh yeah, I think we can bring it down vastly, because for us, from the very first building to about the fourth building, each iteration we've changed and reworked our processes. We've tried to simplify the phases, because at first the whole goal was just to get the building structurally sound, get the panels on. We weren't so concerned about the timeline. And then once we've got and proven the method, we simplified the processes and then minimize resident disruption and so on and so forth. So I think we can bring it down quite a bit. Another complexity that we kind of ran into is you kind of have to retrain carpenters to think more lean and to be able to function on a high skill and a high adaptability level, because you're going from taking, tradesmen that are used to working in specialized fields such as framing or cribbing or only siding, and you're requiring them to master all of those. So once we get that kind of training program focused and simplified, I think that will help lean out the labor costs for sure.
It sounds phenomenal though. Fantastic. Are there any products or product ideas you think that you think that would help you get there faster and more efficient?
Yeah, I think like one issue that we had is trying to develop a flexible, quick and easy scaffolding system that allows us to access the entire building during the building prep and during the panel install. Another one that would be really interesting is a nimble, small, accessible crane. So right now we've been using quite a large 50-ton, 128-foot reach crane. And, we're constantly looking at different smaller, more nimble cranes that can get into these tight spots that allow us a little bit more flexibility in terms of timelines and access to buildings. Those are the two main ones, I'd say.
So as you do more of these, how much faster do you think you could get?
That's a great question. I mean, my goal is to get, 10% faster each building until you hit that precipice where you just can't go any faster. I think we've right now, I'm not really necessarily worrying about how fast. I'm worrying about specific stages, like from the previous building to the one we're doing now. My goal wasn't to necessarily go faster. My goal was to minimize the disruption to the homeowners. So in the previous building, right when the project started, we were kind of in their homes, working in the basements, kind of doing some prep. But in this next building that we're doing right now and we're just finishing, we actually reduced the amount of disruption inside their space by half, right? So that process was my main focus on this one. And then on the next building, I anticipate that, we can shave off 10% of the time each time.
Uh-huh. What does the cost of the exterior insulation approach, how does the cost of the exterior insulation approach compare to re-insulating from the interior? In other words, removing drywall, double stud insulate, and re-drywall.
Can I, yeah, so that just isn't practical really. You're gonna have so many barriers, the existing partitions, the existing floors, kitchen cabinets. rooms. They can't afford for you to take out that much space. And even with all of that, you're going to be really challenged to get anything close to the kind of airtightness results that we're getting fairly easily. Plus, it's going to take longer in total and cost more, way more on-site labor, and the owners are going to have to move out.
So Peter, just to be clear, throughout this entire construction, the people that are living in these units are not moving anywhere. They're actually living in this as you're under construction.
That is absolutely true. And Justin and his crew, like, I keep getting these emails, just another one the other day from one of the people in the units that we're working on right now, just thanking him for the huge, high level, consummate professional, they said. Like, so far, the efforts to minimize that disruption and to reduce any kind of unpleasantness or, just to kind of maintain the forbearance of the owners have been very successful for the most part. And
Peter, one of the things you mentioned in your presentation, you were saying that some of the things were put in laparoscopically. Maybe you or Justin could explain that.
Go ahead, Peter.
Okay, well, I mean, in our pilot, we did one building, and it was on the tour in 2019, in summer. We opened up quite a few walls to get into the ducting, and we found that because we were taking out the old chimneys, we had this space that we could drop pipe in from the top. And so we took advantage of that and really dramatically reduced the amount of drywall we had to open up to get that ducting where we needed it to. Plus, just by fine tuning and being really careful about pre-planning and that kind of thing, we've got that down to a minimum.
One thing I'm quite fascinated about is your electricity demand charges. So how did you go about avoiding that?
Well, with the help of a certain solar engineer who just asked that question, we were originally going to put in one large meter that would have put us in. Well, let me back up. Demand charges are the costs that the utility has to pay for building the infrastructure to deliver you the electricity you need. So if you have a big factory and you're only occasionally using some ginormous motors in your factory, the utility has to still put in a line that's big enough to do that, and that line sits there year round. Well, we're in a similar situation. We're using quite a bit of electricity for our heat pumps when it's minus 30 in January, but most of the time we're asking the utility to take our electricity. And the single meter approach would have put us into a demand class that attracted a demand charge that would have been more than all of the electricity we're going to use. And by dividing it into 8 solar co-ops, the utility allowed us to drop into have 8 meters that are in rate classes that are very similar to residential electricity rates. But this is something that as a society we're going to need to deal with as we electrify everything.
EPCOR was really great to deal with on that, weren't they?
They were amazing.
Yeah.
We're so grateful to them. In some respects, we're sort of, as we build electrically heated houses in our climate, we're kicking the can down the road. When the numbers get up to where they need to be, we're going to have to figure out some storage solutions that really reduce the cost to the utilities.
If I might interject, what is the approximate, what would you say would be the amp load per unit in this particular project? I mean, we're talking about 100 amp and 200 amp services. What would you suspect is the amp service to each of these units right now?
Well, the system we're putting in has a peak capacity of 120 amps per unit.
Okay.
Except for two larger units that have 150. And, you know, we probably could have finessed our way to, if had they been 100, much as you and some others have, but we weren't even close with 60. So yeah, does that answer your question?
Yes, it does. Thanks.
So nominally what, just a minute, I got another comment coming in here. It may well be, Peter, actually, that this project and maybe a couple others in town would be really good examples of us going to the government and the Alberta Utilities Commission to come up with better cost tariffs to promote this kind of a retrofit. I think that's a really good opportunity for leadership from the government electric utilities for this. What percentage of the project is done now, do you think?
We're just finishing up our 4th building, so 4 out of 15.
Sorry, 4 out of what?
Out of 15.
We're 26% complete.
So how much of it will we be able to see on the Eco Solar Home Tour next year when we're actually able to come in person to the site?
I would think we'd be 75. Is that, what do you think, Justin?
I'd say, to be generous to ourselves, I'd say we'd be at more like a 66%, 60%.
A year from now.
Yeah, with no future complexities outside of our control.
But however, wouldn't that be a fabulous site for the tour, because we could see it, part of it under construction and part of it completed at the time.
Yes, ideally, like Peter and I were kind of excited for the Eco Solar Tour. We've done it a couple times, and we expect that when we do it next year, we will have a lot of buildings complete and hopefully one large building kind of in progress to see.
Well, that would just be a fabulous site for the tour then, to see both of those hand in hand.
And wow. You know, it's all happening on the outside. Anybody, I mean, we're not inviting tourists to the site, but if you happen to be riding through the valley on your bike, have a look. Like, these things are beautiful. Like, I get a shiver down my spine every time I walk past it.
It'll be interesting if you can get one of the unit owners to show the inside as well on the tour. So we'll look forward to that next year.
Our odds are good. We've got 59 of them.
Well, Peter, I want to recognize that your own personal house was on the tour when the tour started 20 years ago. So it's really great to see that you're continuing to. Well,
and the Riverdale Net Zero house, which is right next door to both, was on the tour for a couple of years, and was really where we learned, you know, the fundamentals that are making this possible. And we're so grateful to the tour for the degree to which it's helped to build a market, so we get to do this stuff.
Yeah.
Well, thank you, Peter. I'm going to interrupt there. We need to look at moving on to our next home today. So thank you. I do encourage everybody to, if they would like to ask Peter additional questions, send questions to info@ecosolar.ca, and we will pass them along to him. All right, our next home today is the Richie Secan home, and this is a home that's actually built out of shipping containers. We're probably going to be seeing more pictures from one of these homes that was built a couple years ago that was on the 2019 tour. We have Adam Morris with us today, who's going to take us through a presentation on this. And Adam, take it away. It is your time to tell us about a CCAN home.
Thank you, Andrew, and thank you to everyone for attending. I just want to first give a shout out to Andrew and the rest of the team for their tireless effort to put this thing together. I know it's been a challenge this year, so congrats to you guys for getting it done. Looks like it's a successful turnout. So thanks very much for the opportunity to tell you about our shipping container homes, or our CCAN homes, as they're sort of colloquially known. So we've developed a number of shipping container homes, both here in Edmonton and across Alberta, as well into British Columbia and down in Ontario. We chose to build with shipping containers initially because we were frustrated with the time that it took to build conventional houses, as well as the quality that was capable or that was, expected as a result of sort of on-site trades. I'm a real estate developer by trade, and I had frustration buying pieces of land if the zoning wasn't right, waiting for 6 to 12 months to get my zoning, sometimes more, certainly during COVID, definitely more. We just submitted a zoning application for another piece of land, and they're expecting that we won't get into C Council until March of next year. So sort of 10 months. So you buy a piece of land, you create the plans for it, do the design for it, and then you go to council. So you go to actually planning, submit your request. You have a pre-dev meeting with them. You sort of do the back and forth. They give you a bunch of feedback. Then you finally submit your request, and you get scheduled to go in front of city council. So that process takes about a year. And then once you finally get approval, then you can go ahead and start your development permit and building permit drawings. Another 6 months later, you're into ground. So if you buy a piece of land and you want to get into the ground as quickly as possible, you don't have the right zoning, you don't have the right entitlements, it's a painful process. Even if you do have the right zoning and you want to get your BPDP, it's a minimum of 6 months. And I was frustrated because I said, in this case, we had the right zoning, but we knew exactly what we wanted to build, and it was going to comply with the requirements based on the zone, based on the community, based on the mature neighborhoods overlay, et cetera, et cetera. But it was still going to take us 6 months. And so I said, how can we get into ground quicker? And how can I battle the sort of quality woes that we all in sort of Alberta experience? And of course, those quality woes that we experience are just as a result of the boom bust nature of Alberta real estate. You get a bunch of trades that come in, trade subcontracting companies get extremely busy. They hire as many guys as they come, they rush through homes, and then they move on to the next job site. Well, that's in boom times. In bust times, of course, you get a lot of quality trades that leave, and it can be a challenge to schedule work. Okie dokie. 1 second, I apologize.
Okay, well, while Adam is over there, I'm just going to advance to the next slide.
Yeah, apologies, I'm back. I got a newborn son here, and my wife's trying to get our newborn son's car seat into the car, and it's not working. So I apologize about that. So anyhow, so we set out to try and understand the best way to build. And so we understood that best way to build offsite, that is. And so we understood that there were a variety of options. Modular building offers 3 options. Number 1, you've got modular wood. Number 2, you've got modular steel. And number 3, you've got shipping containers. Well, modular offsite wood is okay, except it uses an incredible amount of wood. So to build a module offsite in a factory requires an incredible amount of wood. In fact, twice as much wood as you would require to build on site. Building modularly with steel, not shipping containers, but steel, is incredibly expensive. You get great quality, but it's incredibly expensive. And so we said, you know what, why don't we try building with shipping containers? So 5 years ago, we started building with shipping containers. As you can see here, we went out and we got a bunch of repurposed shipping containers, and we began the process of trying to figure out how we could build with these things. So we got a site initially, it was a field out in Devon, and we started modifying the containers. This is the site that we have in Queen Alexandra. This is not our Ritchie site, but if you just move forward, Andrew, this is the site that we have in Queen Alexandra. And so you can see what we ended up doing, as you can see the container in the back, is we ended up doing most of the modification initially in a yard that we had. And then from there, we moved into a factory setting. Our big idea was, listen, there are lots of benefits with shipping containers. Shipping containers, certainly you're using repurposed product. The steel is fantastic. The strength of them is fantastic. But our big idea was, if we're going to make these things go, and the market's actually going to like shipping containers as a replacement for site construction or wood modular or steel modular, we've got to outfit them in such a way that they look and feel conventional. And so what you see here is a full basement foundation. We said, listen, we can't, in the neighborhoods that we're building, Queen Alexandra, Ritchie, Westmount, Inglewood, the inhabitants, the buyers, whether it's buyers or renters, they're going to expect a full basement foundation. So we said, listen, we got to figure out how we put a full basement foundation. So you can see what we did here is we poured a full foundation with window bucks. You can see the window buck in the top middle for, again, a full developed basement. And then we ran steel I-beams across. So we sunk steel I-beams into the foundation, wet set those into the foundation all the way across. And then we put a number of teleposts in to support the steel beams on footings. Brought the containers to site after we did our initial modification in the field. And so what you can see top left there is a shipping container. There we go, perfect. So what you can see is a shipping container that's been modified in the field. So we took this, we cut the front out, the back out, and then we cut an aperture on the left-hand side there for what is effectively your front porch. And then cut a large piece out of the middle section, as you can see here, because of course that is going to combine with other shipping containers. So we've got 2 other shipping containers that are going to go on this house. So for us to achieve a 2,000 square foot home, we decided that we put 6 shipping containers together. So the math is your typical shipping container is 8 feet wide by 40 feet deep. We use high cubes, so 9 foot 6 inch high cubes. Shipping containers also come in 8 foot segments, but of course an 8 foot finished ceiling, by the time you actually fur it down, you end up somewhere around 7.5 feet. So that's a little too small. So we use 9 foot 6 inch. So we craned these into the foundation and set them on the foundation. Now, of course, shipping containers aren't like building with wood on site. You don't have the flexibility to shim up or shim down. So you have to be really incredible with your foundation tolerance. So you have to be very, very level all the way across, because of course you're dealing with a flat piece of steel. You don't have the ability, as I say, to shim up or shim down much. You can shim up just a little bit, but really you're looking for less than a ½ inch tolerance from front to the back of the foundation and left right on the foundation. So you can see we put 3 shipping containers on the bottom and then a number 2, and then 2 more on top. Again, you can see apertures, that large aperture on the yellow shipping container at the very top in the middle of your screen. That's for a large window at the front of the house. That's in one of the bedrooms. And then on the right-hand side, in that sort of teal, mint, greeny looking container, you can see, again, we've got another aperture there. And then when the 3rd container on the top came across, we had another aperture there because there were 2 bedrooms side by side. And I don't believe there's a picture of that 3rd one coming in. You can see we required a very, very large mobile crane to deliver it on site. And here's what the home ended up looking like when we were finished. So the home was, again, 6 containers, but the idea was that we wanted to make this thing look and feel conventional in absolutely every way. So we clad the outside. Actually, if you can just pivot back to that, Andrew, that'd be great. We'll pivot back then. I'll just talk about some of the other features on the finished product. And I believe those are some of Andrew's pictures. Those are phenomenal pictures from the last tour. Yeah, so what you can see here, again, you can see that aperture that we cut out on the bottom for the front door and the porch, as I mentioned. And then that large, the large yellow container with the large aperture is that primary window on the top. And then the green container had that, yeah, thank you, Andrew. And then the green container had that smaller window there. And actually that window and the window beside it, the larger window that we've got there beside it, that is one of the hallmarks of shipping containers. There's sort of 2 primary issues with building with shipping containers as opposed to building with wood or building with modular steel. You're working with fixed dimensions. So again, as I said before, shipping containers 8 feet wide, 9 foot 6 inches tall, 40 feet deep. At every 8 foot segment, what gives the shipping container the rigidity or its strength is the posts. And so that post that we've got on the far right hand side, that has to remain undisturbed. And so if you go into a shipping container house, our goal is that the shipping container house looks and feels conventional in every way, except for that. There will be occasionally windows that you would like to adjoin, in this case, that smaller window and then the larger window that was beside it in the previous picture. That, if I was building a typical infill, would be one large window. But in this case, because you have to leave that corner post undisturbed, you're not able to actually adjoin those two. If you actually parry back to that other picture, I'll just point out a couple other things on that shipping container itself. And then we'll move to this and we can talk about the interior as well.
All right.
Thank you very much. So windows, you can see on top, we've got a large parapet wall. So that's a black parapet wall and that hides the roof slope. So this isn't actually a completely flat roof. It's effectively a flat roof, but we put a small slope package on it. It's about 8 inches front to back, and it's domed in the middle, and then it pulls off into the corners where we've got scuppers and downspouts all the way along. On front, we've got some black, just some black awning features. Again, there's nothing structural there, just meant to look add a bit of a architectural interest. We've clad these with stucco, so our method allows us to clad these containers with really any exterior feature and really any interior feature that you're looking for. So we can clad them with stucco, stone, brick, vertical lap, hardy board, vinyl, ACM, ACP, anything you want, anything you can imagine on the outside you can put on. You can put a traditionally sloped roof on these as well, like you would see on the houses on either side. So that's sort of an 8-12 pitched roof, something like that. So you can put an 8-12 pitched roof with traditional asphalt shingled on it. And to accomplish that, you simply would use wooden trusses to create your slope package there. But again, we opted for a flat roof. That creating a more traditionally sloped package as opposed to a flat roof is more expensive. It's sort of an architectural feature that's not necessary because the shipping containers will withstand so much snow load. And again, by using just a small parapet wall, so we've got a 24-inch parapet wall there, we can hide the minimal slope without having to cover it with anything else. Incredible. Back to the interior pictures, if you can, please, sir. Thank you. So what you can see here, we did this on site, but the interior of the shipping containers, with the exception of the structure, is all built conventionally. So in this case, we used wood to create the demising walls between every room. So you just frame it like you typically would. Running along the top, you can see we've run studding all the way along the top to fur down the ceiling. So we fur down the ceiling here by about 5-6 inches. So we end up with about a 9-foot ceiling. You can see wire running all the way across, that Lumex coming out of the ceiling, the white wire, that's for pot lights that we installed everywhere. And then around the windows, you can see some HSS columns. So that's black around the windows. They're just beyond the gentleman. Thank you. Yeah, that's just high strength steel, angular high strength steel that we use to reinforce the windows, because of course you can't build a traditional window buck, with sort of a framed wall. So you need to create some additional structure there around your windows. So we've done that around all the windows. And you can see where the telepost is. We hide teleposts very strategically. We can accomplish up to 25-foot clear spans left to right, front to back. What we've got here is, you place your telepost very, very strategically throughout your wall system or throughout your interior layout to hide that support that you need once you actually take out those partitioning walls between the containers. Because again, we've got 3 containers loaded up here. That's the upstairs. Again, you can see same thing here. You've got on top of your marine grade floor. So shipping containers have a marine grade plywood floor. We installed regular plywood to fur it up a little bit, but also to create a sort of a level surface all the way across. By using repurposed shipping containers, you do get some degradation of the natural wood floor that's there, the marine grade plywood that's there. So we put plywood on top of that, and then a little bit of leveling cement just to level it all out so that you can minimize any humps and achieve a totally flat floor. Anything else to see here? Yeah, sort of a conventional, you end up with, a really conventional, I'm not sure what this is. Skip to the next one. I'm not sure what that is right there. It's office, I believe. It's a mistake. There we go. So between the shipping containers to prevent us from having to fur down the ceilings quite significantly to run mechanical and HVAC chases. What we do is we actually create an artificial chase by putting a steel I-beam between the lower level of containers and the upper level of containers. So a steel beam all the way across, and then that creates a chase where you can run horizontally all of your ducting that's required, any of your plumbing pipe that needs to run horizontally across your building. On to the next one, please, Andrew. Yeah, and then we move on to some of the interior finished pictures. So you can see, again, our goal was to build these things so they looked and felt conventional in every way. So we built this unit off-site, did as much modification off-site while we were waiting for our building and development permit, and then delivered the containers to site modified, and then finished them, took a traditional site finish approach. What we actually do now is we actually build them out in the factory. So we've got a certification that allows us to build these things out 90, 95% complete in the factory. But again, the distance that we're standing to that corner is roughly, I'd say 15, 18 feet, something like that. So you can see nice, clean, open all the way across, no beams, no, unsightly sort of knockdowns for any front to back transitional supports that are required. We're able to get all of those inside of that sort of 4-inch ceiling that we've furred down. Again, at the back.
But on the left side there, Adam, if I just say, you've got two windows there where normally you'd have one, but you actually have a beam in the middle of that. That's the shipping container joint in the middle, isn't it?
That's right, Andrew, and that's what I was pointing at before. I hate when you go into a restaurant and you say, "Hey, what's good?" and the waiter says everything on the menu. It's not that way. There's always a sort of a drawback, and this is the drawback with shipping containers, is that number one, 9-foot ceilings is kind of the max you can accomplish economically, and then number two, your window placement has to be considerate of where those corners are. So yeah, right there where Andrew had his mouse, that's 8 foot from the far wall, from the exterior wall into that section. That's 8 feet right there. So you've got your posts on either side that are running vertically, and those have to remain undisturbed. If you were to modify those or cut those out, you lose a ton of structural rigidity. So that's exactly it, Andrew. Typically, you put one large window in the back, and that would be your massive window in your living room that would allow all the light in. In this case, that's not something you would accomplish. Yeah, continuing on, again, you can see all conventional finishings. There's nothing here in this home that alludes to anything that alludes to a shipping container in any way. This should look and feel conventional in every way. Moving on, nothing really to show there other than conventional finishings. Moving on, yeah, same thing again. So from where we're standing to that far distance, about 25 feet, you've got a dining room over there. Just at the back door, mudroom again at the back door. That door that you see to the left there, we created a suite in the basement. We allowed for, that's not true. We didn't create a suite. We allowed for this unit to be suited by putting in a secondary entrance. So that's your door to your basement. And then you've got conventional stairs moving upstairs. Yeah, there's your dining room with a full mudroom in the back. Again, just interior sort of polish on it. You can see a little bit there. We put a conventional deck on the back, quite a large conventional deck. We also built a conventional garage. We ran conduit to the garage, which was sloped in the direction of the sun, so that's sort of pre-fit for solar panels if necessary. And then run that conduit all the way to the basement. Again, you can see conventional bathroom here. And if the next picture is of the bathtub, there you go. So there again, that's our 8-foot separation. So you've got 2 posts on either side, in between that sort of interior wall space there that can't be covered. So you've got to put 2 smaller windows there. Proceeding on. Yeah, and there's the finished look. So again, stucco on the outside. You've got your parapet wall and your window separations all the way across. So this home performs incredibly well from an energy perspective. Number one, obviously, it's green. And I think, we all sort of hate the term green because green doesn't really mean much. It's kind of this big fuzzy term, but it's green from the perspective of we've used repurposed shipping containers wherever possible, which at one point prior to the pandemic, up to 96% of shipping containers were abandoned in North America every year. So, and the reason for that was it was cheaper to cheaper to build new shipping containers and send more full goods than it was to send a used shipping container back to Asia to be loaded up with goods and then brought across. So with 96% of shipping containers abandoned in North America, you have the ability to buy shipping containers quite cheaply. 40-foot shipping container, iCube, runs a public around $4,000. Used to run the public around $4,000. A used shipping container, we bought them for around $2,800. But now they go for about $5,000 or $6,000 a repurposed shipping container, and that's just based on supply and demand. There's more goods moving around the world right now than there ever has been, thanks to everybody sitting at home with their stimmy checks. So we use repurposed shipping containers. As I said, we always try to use repurposed shipping containers. This home, we use 3 inches of closed cell spray foam on the outside, as opposed to insulating. So the shipping container itself actually acts as the vapor barrier. By using 3 inches of closed cell spray foam on the outside, you can achieve, really incredible energy usage, a really tight envelope. You can also expand it by another 2 inches to achieve net zero equivalent very, very easily.
All right. Well, thank you, Adam.
Yes,
so I'm going to hand things over to Gordon here for questions. And Gordon, what kind of interesting questions have we got?
Oh my goodness, do we ever have interesting questions? What a fabulous presentation. Oh my goodness, I love the inside photos of how it looks. Who would ever know?
That's right. That's a big idea.
Yeah, totally. So thank you so much. Some questions here. How did building with secans actually solve a quality of work issue? It looks like you had raw steel structures to work from, which left a lot of on-site work to bring the building to completion.
That's right. So our thesis going in was 2 things. Number one, it was, listen, if we can build off-site while we're waiting for our building and development permit, because of course you can build anything off-site in a field, in a yard, or in a factory without relying on your building and development permit. So what we did is we went in and got our foundation permit, and we built off-site while we were waiting. So that allowed us to sort of modify the containers. So that allowed us to advance much quicker than you typically would, because of course, the moment we got our building and development permit, we already had our frame built. However, you're right, we didn't address the sort of quality. So our other thesis was, listen, we can build quicker by building off-site, but also if we build more out in the field, then we can actually ensure, greater quality, because we've got sort of the same trades working on the product over and over and over. On this project, we weren't actually able to build, thanks, that's a great picture, Andrew. On this product, we weren't actually able to build much out in the field. We said we got our building permit actually much quicker than we expected, so we craned them into site and actually finished them there. But what we ended up progressing to was a manufacturing facility. This is just over in the Roper industrial area. So this is a 25,000 square foot manufacturing facility whereby we could employ the same trades over and over and over again to do the same work. So we had electricians that were working in-house for us, plumbers, tin bashers, and then framers that were working for us constantly. So we're modifying the containers in the facility. By doing so, you can ensure that sort of greater quality is achieved. But on that project, very good pickup, we weren't able to achieve that sort of pre-built nature that would allow you to deal with the sort of quality issues that you would expect typically. The quality you can solve by building a factory.
So for an ideal project, perhaps, how much of it could you do in the factory versus how much would you do on site?
So ideally, you can build these 100% complete in the factory. So we actually do build them 100% complete in the factory now. You can go out and get a designation called the CSA 277 designation. CSA is Canada Safety Association. That same body. Yeah, Andrew, please feel free to go through these. There's a lot of different interesting pictures. The CSA 277 Canada Safety Association, the same body that certifies, hockey helmets or, your sticks or, roller blades, so on and so forth. So they will actually certify manufacturing facilities. You can achieve a certification that's like basically a mobile home builder, whereby you can get that designation that allows you to build actually complete in the factory. By getting that designation, then there are no site inspections, no framing, no structural, no plumbing, mechanical, or electrical. All of that can be done in the facility, and then you just crane actually finished units at site. So the way we build now is we build 95% complete in the factory, ship them out to site complete, and then that remaining 5 or 10% that's left over is just the seams all the way across.
I think this picture is from the Ritchie site, and so these are partially finished. So you can see a lot of the wood and a lot of the interior studs are in place.
That's right. That's a great point. Exactly.
Thank you. Another question that came in, with all of the interior framing required to finish the interior and exterior of the building, how did that actually save on lumber materials instead of just framing the house with wood altogether?
Yeah, so not a lot of wood was actually required inside. What we do now relative to sort of a conventional build, what we do now is we actually use steel stud to build our walls, our partitioning walls, and to fur out all the way across. In this case, though, the amount of wood that you see there, yeah, you can see the steel stud there. This was when, you know, wood prices and steel was a little bit more competitive. Of course, steel stud is actually cheaper than wood stud now. But by saving wood from the exterior, so not having to frame all of your exterior walls, OSB and, you know, plywood all the way around, you actually save a ton of material. So in this day, when we were building this about 2 years ago, to have your entire house framed would be typically around a 2,000 square foot, probably around $15,000 to $18,000. Somewhere around $8 to $10 per square foot is what you were looking at typically. Now that cost has gone up to about $18 to $20 a square foot, and so a framing package here would cost roughly $35,000 to $40,000. We were able to build these by buying these 6 containers for around $2,800. Get around 18,000, and then from there you're about 4,000 or 5,000 actually to frame the interior. So compared to today's prices, it's significantly cheaper. The big benefit on this was the ability to build it more significantly off-site. It was also building a different crop. Yeah. Again, by using shipping containers, you can build a little bit further off-site than you would in the field.
Thank you. Another question that came in was, is there a problem with moisture and the steel?
No. So the way we deal with that is we outsulate. So this is the same way you deal with thermal bridging as well. So we use the shipping container as vapor bearer, and then from there we actually apply the 3 inches of closed cell spray foam. So that's what you can see, the yellow here on the outside of the shipping container. That's closed cell spray foam. So that prevents both thermal bridging as well as condensation on that side of the container. And then on the other side of the container, you know, again, it's treated just like the interior of vapor bearer. If you were to pull off one of your walls right now, you wouldn't, a piece of drywall, you wouldn't expect to see any condensation between your drywall and the vapor bearer.
Mm-hmm. What insulation did you use and where did you place it? Exterior or interior? That was one.
Yeah, so it's closed cell, as I just said, closed cell spray foam, 3 inches we applied, and we applied it to the exterior. So we call that sort of colloquially outsolation as opposed to insulation.
Oh, yes, right. Another comment was, this is very cool, Adam. Do you hear outside noise, such as traffic or rain, more, less, or about the same as in a conventional home with 2x6?
Actually less. The envelope here is significantly tighter. So if you take a thermal camera and actually run around the interior, you get significantly less leakage around windows and, you know, throughout sort of the body of your home than you would with a conventionally wood-built home. So that same envelope tightness keeps sound out as well. So we call that STR, sound transmission ratings. Your STRs here are at the same, if not better, than conventional buildings.
I'm just asking the questions as they come in. Pardon me if some is repetitive. How does the cost compare to an equivalent conventional wood frame house?
Yeah, so in these days when these houses were built a 2 years ago, this was about on par, if not a little bit higher than conventional building. So it cost us roughly $160, $170 per square foot to build these. Complete conventional cost to build infill is roughly $150, $160. So we were a little bit better than conventional. We're a little bit worse than conventional. Now with that increase in lumber, we are the same, if not better than conventional. Where you can really experience cost benefit or cost savings is if you're building more significantly off-site. So you know ultimately that your building permit and development permit is going to be granted based on your compliance with your development permit requirements. In that case, you can build off-site. In fact, you can build these things entirely off-site while you're waiting for your building and development permit. The day you get your BP, you can actually crane these things into site and button them up within 3 to 4 weeks, and you've got yourself a finished home. there is a general misnomer out there that, oh, you're building with shipping containers, it must be significantly cheaper. That is not, in fact, the case. You can end up with a quicker product and a product that is a little bit more solid than building conventionally stick built, and certainly in today's world can be a little bit cheaper, depending, of course, what happens with the cost of lumber, but it is not significantly cheaper, not in the manner that we built it. Now, if you were to use your shipping container walls as both your exterior and your interior finishing, or you were to insulate a little bit more traditionally, and again, use that sort of corrugated raw shipping container exterior as your exterior, then yes, potentially you could save money. Or if you just used a single shipping container and didn't actually modify the containers, again, it would be significantly cheaper.
Mm-hmm. Thank you. There was a question here. Steel has a much higher carbon footprint to manufacture versus wood. How is building with steel containers and steel studs sustainable for the future? And I myself would add into that, of course, steel is the carbon footprint of steel is probably going to come down somewhat because of
certainly
getting rid of coal in manufacturing steel. But I would imagine that might be a decade or two.
No, but you know what? That's a great point. And there would be no benefits if we were using brand new shipping containers. So if we were buying new shipping containers used specifically for building with homes, then you're right. Building with wood harvested from a sustainable forest would certainly be a more environmental approach. We, however, are using repurposed shipping containers. So our world is set up to move goods via shipping containers, and that's not poised to change anytime soon. In fact, there's no other suitable replacement for shipping containers that really anyone has conceived of that would allow goods to be transported globally the way they are now. So if you assume that shipping containers are going to be moved around the globe, are going to be manufactured strictly to move goods around the globe, in fact, on an increasing basis in the coming years, based on the advent of Amazon and sort of at-home ordering. If you assume the consumption and the manufacturing is going to continue to be incredibly high, then you've got all these shipping containers that are moving around the globe. In fact, every year there's, I believe, the equivalent of 36 million shipping containers, 36 million new shipping containers that are manufactured every year. So we're simply, again, taking old shipping containers, those that have traveled around the globe for 3, 4, 5, 6 years, and converting them into housing. So taking a product that's at the end of its life and turning it into something else.
So it's a fancy way of recycling.
That's exactly what it is, yeah. And so we try to use repurposed products wherever possible throughout our homes. Reclaimed wood for our floors if possible. Sometimes you can use other windows, doors, hardware, et cetera, et cetera, et cetera.
So we have one more question. I don't know. I think we still have, 7 minutes, Andrew?
That's correct.
So the one last question at this time is recycled plastic lumber ever going to be feasible for a building material?
Sorry, can you say that again? I apologize. It sort of cut out there.
No worries. Is recycled plastic lumber ever going to be feasible for a building material? Do you know?
Recycled plastic lumber. I'm not sure what plastic lumber is, but I've never heard of that before.
Pop cans.
And Andrew will step in on that as the plastics expert. So in fact, what he's talking about is lumber that's made out of recycled plastics. And will it ever be feasible for using? One of the issues is that depends on the recycled plastic stream. If the recycled plastics is coming post-consumer, then the actual quality level of the plastic that goes into it is not necessarily consistent, and so you're not sure what the strengths are of that particular lumber. There are people working at coming up with better ways of recycling plastics to come up with the base chemicals that they can then make into new plastics. But to just take all the plastics out of your recycle bin, put them into melt them down and put them into a mold and make a piece of lumber, the consistency of that typically is not. You can't rely on the strengths.
Interesting. Yeah, in terms of the way the construction industry is going, and I'll please jump in if there are any other questions. But I can just chat for a minute as a real estate developer, talking about sort of modular housing and eco-friendly housing.
Yeah.
the construction industry is moving more and more towards modular construction. We understand that there are a number of drawbacks to building on site, chiefly the time that it takes to build on site from start to finish as well. Obviously in northern climates, you've got this sort of exposure to, changes in weather. It's not unusual to see a home that's being framed in the winter with 6 inches of snow, all the way across it. And so, we understand that building modularly, building in a factory is wise. Now, again, as I say, there are 3 primary modes of building in a factory. One is with wood. Again, in order to sort of reinforce wood modules as you're moving them from one location to another, requires roughly twice the amount of lumber that you would use to build on site. Using steel, sort of a steel modular system. Steel is great from a structural strength perspective. It's also great for high rises. But again, the carbon footprint is really incredible to make that new steel required for sort of that Atlas system. Or building with shipping containers. Now, a lot of builders haven't adopted shipping containers because figuring out how to do it economically has been very, very difficult. But we think we've got a solution here that will allow folks to build in the factory, folks to utilize repurposed ship containers to build in the factory and apply those to housing in a way that's significantly quicker, can be significantly less expensive, and significantly better for the environment than building on site.
How are people responding to your CCAN homes?
Yeah, the reception has been incredible, and that's really on the basis of people thinking it's sort of cool. That's the thing that first draws people. They go, oh, I've heard of shipping container homes, or I've seen it on HGTV. They love the idea. And then when we show them that shipping container homes can look and feel conventional, and then talk about the benefits, being able to build off site, being able to build out or below the cost of conventional, and then the environmental benefits, they really, truly love it. And so what it's about now is about perfecting the manufacturing process so that you can, meet that sort of market demand. It's really, really tough for folks to do it on a one-off basis though. So, for you to build a single shipping container house, there's a lot of learning that goes into it. And, it's probably not going to be more cost effective nor significantly better for sort of the environment, nor significantly quicker than building with wood. We know how to build with wood. We've been doing it for 100 years. So if you can apply sort of, manufacturing principles to it and sort of build in a factory line, then you can build significantly quicker. But building one at a time is very, very difficult. So again, people love what we're offering so long as you can build, as I say, quicker, faster, and at or below the same cost as, quicker, better quality, and then at or below the same cost as conventional.
How have real estate agents been responding?
Yeah, real estate agents love it. They typically will sell it to sort of an eco-friendly crowd as repurposed shipping containers, or to those that they don't think will like it as repurposed shipping containers. They simply sell it as a steel frame home, which it is, meets all the qualifications of a steel framed home. When we initially sold these, so these were the first 2 shipping container spec houses sold in the world, actually. The market didn't know quite what to think about it, or the brokers didn't know what to think about it. We ultimately put those 2 homes on the market, and the first home we sold actually above market, above cost that conventional homes were going for, and above the price that we listed it for. So we listed that house for, I think, $750 and sold it for $780,000. And we sold in roughly half the time the conventional. So we had a really incredible interest, and the market loved it, and there's been no issues with sort of the quality of the product as you go. So it's been great.
Mm-hmm.
Okay, well, Adam, thank you very much for that. I appreciate you coming and doing your presentation today. We're going to get ready for our next presentation. The next item that we have up is the Creekwood Net Zero Energy Home, and this is going to be presented by Tara Bloom. And Tara has a very interesting video that she's put together on her home, and we'll start with that as soon as we hit the time here of 3 o'clock. I will start her video, and we will get to hear what Tara has to say about her home. Just waiting for the time to hit 3.
Can you put the sponsor slide up?
Sorry. I'm going to move to the video, which is what I need to do next.
Okay, sorry.
There we go. And at 3 o'clock, we start.
Hi, welcome to my net zero home and welcome to the 2021 Eco Solar Tour. It's the virtual version. So I'd like to take a quick moment, introduce myself. My name is Tara Bloom. I built this house, I took possession of it in 2014. I've always had a thread of the living alternative and living more in the sustainability realm. So building net zero fit perfectly into my overall values and mandate. Today, I'm going to take you through the energy efficiency of my home, some of the build and the tech. I'm going to take you through intentional living, and I'm going to take you into my garden, my food garden, and some of the stuff, additional stuff that I've done to bring value to my micro-generating net zero home. We're going to take a moment and talk about the technical aspects of building a net zero and some of the things that I did that made it a little bit different. So right off the top, I was building with a production home builder. So I was really lucky. They were able to do up a board with a lot of my words in it. And I placed this board right at the front of the front door. So as soon as any trade bodies or anybody came into the home during the construction period, they knew that there was something different with this build. I highlighted all the specifications that made the home net zero. So it was a great reminder for them to check their paperwork. This is something that was really an ounce of prevention saved a pound of cure. So this board was really a winner for me on that aspect in construction. So moving along, instead of going to the mechanical room today, we are going to go through a few boards just to talk about the construction of the home. So one of the things that the builder did is that they manufactured everything, panelized it, and brought it to site. I've got a few pictures that demonstrate how the home was just lifted and put together within a day or two. So it makes it a lot better structure, a lot stronger structure as well in that build. We did spray foam insulation for extreme efficiency as well. And then the window. So spray foam does have a bit of a debate today in regards to whether you should use it for sustainability or whether you shouldn't use it. At the time in 2011, 2012, the technology was definitely to use spray foam because it also provided insulation, but it also helped with the building seal as well. Now, it is pretty pricey. My husband was working in drywall at the time, so it was a lot more attainable for us to do that. Our attic has about an R60, about 4 feet of spray foam insulation in it. So we did definitely go all the way on the spray foam insulation. All right, so here we have under slab rigid insulation. So the insulation here, it's about a 4-inch pocket of insulation. And this is probably one of the most economical and attainable ways to insulate that basement floor. It all of a sudden becomes a very cozy basement when you've got that rigid insulation underneath, and it doesn't draw as much heat from the bottom up. So this was an easy win as far as energy efficiency goes. Now we're moving to the mechanical room. Mechanical room is where I kind of start to light up. You'll see what it's like when I get to solar. However, some of the things that make my home super energy efficient is that all the mechanical runs electrically. So I have an air source heat pump hot water tank, and it runs on the same technology that your fridge does. So it compresses fluid and uses the energy from that compression. So air source, hot water tank. And then on the flip side, we have something called a drain water heat recovery unit. And the drain water heat recovery unit allows you to recover about 40% of your wastewater heat in your home. So this is another win when people ask, how can I make my home more energy efficient? Dropping one of those in, I think installed, is about $1,200, and you save a lot of that wastewater heat. So as far as being energy efficient is also making sure to recover the heat that you've already paid and supplied. This is a board we're going to start talking about how the air flows in the home, as well as how the home is heated. So this is an air source heat pump. This is a Mitsubishi air pump. And then we have an HRV system here as well, heat recovery ventilator. So these are two really important bits in a high performance or a net zero home. So I often use the analogy that moving into a high performance house is like living in a plastic bag, right? You have a tightly sealed building envelope. And now we need to make sure that all of that air is properly ventilated and circulated. So I like to call the HRV unit the lungs of the home. So this is the unit that's going to bring in fresh air and exhaust fresh air into a home. Now, most people find it really satisfying when they put a fan on and they can hear the direct vent fanning outside. This guy, in a high performance home, everything vents directly into here and then breathes out. So these machines become really important pieces in a high performance home. Now the cool climate air source heat pump that we've got here, now my unit is outside and then it runs inside. Now, a lot of people think that I required extra ampage to the house because of the solar that I create in my home. Now my home is all electrical, and the reason why I need 200 amp service to the home is because when all of these units are working, especially in the winter, the electrical draw that comes off the grid is so large, I need that extra service. So we're going to move on to one of my favorite boards, and that is solar. I love solar energy. I first moved into the space of owning solar. So we had a north-facing duplex and we moved into our net zero home, and I became the owner of a 13 kilowatt system on this home. There was a lot of things that happened that I wasn't expecting. I was all of a sudden really proud of owning a power plant and being a micro generator and being able to overproduce and feed my neighbors clean and renewable energy. There's a lot of really good stuff in the solar space and renewable power specifically for homeowners. So I wanted to take a moment and talk about intentional living. So the home is where the heart is, and it's where we raise our children and we really grow love. And one of the ways that we all like to love each other is through food. And I've got a picture of my family here simply because that's where the love is, right? It's with your family. Everybody can relate to that. One of the ways that I've brought intention into my home is not only with the energy efficiency. I think the energy efficiency allowed access for that. It was kind of a doorway for a more intentional living. But one of the ways was food production and looking at different ways that you can produce food in your home. So one of the ways that I do it is with an urban cultivator. So it's essentially, it's a bar fridge. It's spec'd to be a bar fridge. The whole unit is roughly about, I think, 2,400 brand spanking new if you wanted to plumb it in like this. And it's just beds. I've got a bunch of my perennial garden stuff and my annual garden stuff going in here. So some flowers and sweet peas and basil and thyme. And then down at the bottom here, so the whole system is plumbed in. The water runs at the bottom down here in a big reservoir. And then I program it for light and for water, depending on the top and the bottom. So it's very, very user-friendly. It's a little on the ironic side too, because my solar panels produce power that provide renewable energy to my grow operation in here. So there's a little bit of that cycle going on as well with the energy. So in here I've got chives growing, and again I've got some more flowers for the garden. A lot of the times I'll just have beans and pea shoots growing, and then I pull them out for supper and put those out in the middle of winter. So this guy has provided a lot of entertainment and intentional living in our home. There was a lot of questions on why I wanted to put a wood-burning stove in the house. Well, that's not very carbon friendly, Tara. However, there's a lot of good ancestral, cultural, human creature comforts in an item like this. Now you'll notice in my living room, I don't have a TV down here. Our entertainment is putting this on in the evenings and enjoying the warmth and the glow from the fire. Everybody has iDevices on the sides. However, we enjoy this guy solely without any large TV around it. It radiates heat. And then we've got a little efficiency fan that runs just on heat through electricity. And I will push a lot of the heat to go up the stairs so that the bonus room can experience some of that heat as well. I'd like to take you for a quick tour through my garden. It's an edible garden, it's a food garden, it's a permaculture garden, and it's an ancestral garden. So one of the first things I'd like to brag about over here is a haspis. Now these guys are northern blueberry plants. They are beautiful. One of the first plants to come in the spring. They provide these great, juicy, slightly sour blueberries, and I've got 3 of them in my yard, in my front garden. So 1, 2, and 5 right over there. And I got the 3 of them to help with pollination and so that they can keep each other company. So moving along, I've got an apple tree here, and this apple tree came from my mom's garden. So that's where that ancestral piece comes from. I also have peonies from my own grandmother that's just growing its 3rd year. This year, you can see it's red coming up. So I'm hoping I'll have grandma flowers from the peonies this year. Moving along, this guy, I love this plant. This is a goji berry, and you can see my goji berries just starting to get its leaves in here. And the goji berry, this little plant, I've had it for about 3 years. And last year it produced so many fruit berries that every day for August and September, I was able to come out and have a very healthy feeding. And my freezer got multiple bags of frozen goji berries. But I gave it a lot of attention as well. It knows that I like it. And then I'd like to take a moment and talk about my very favorite plants. And this is a rhubarb. So again, another ancestral plant. I got this one from family. And rhubarb is such a great place to start your garden. I plant this guy, again, he's first in the spring, has no problem with the cold weather, comes back strong every year. And he has these huge leaves and they'll get massive. And he'll come up probably about 4 or 5 feet and have these huge limbs that come out, these huge leaves. Just such a gorgeous plant. He provides lots of safety and little micro environments for all of the other little helpers out into the garden. So I love rhubarb plant. One of my favorite ones to start off with. So, come to my backyard. Along the side here, this is an extremely sunny space. I've got some pollinating flowers. I'll put my sunflowers will come up here. I've got a poppy bed in here and some other cosmos and flowering plants will be out there. In this area, I've got my compost, which I just turned over, and I put the compost into the veggie bed, which I'll be planting shortly as it is May long weekend right now. And then moving over onto this side, I have a small gathering area for eating over here. And then in this area, this is called a huviculture. So basically what it is that I dug about 3 feet deep and I put in a whole bunch of like brown compost, if you will. So just stuff that will biodegrade and is natural. And then I put soil on top of it. And this allows me to only water very, very occasionally. I don't have to run out and water my plants all of the time. And because I've got a slope to my backyard, I'm currently working on tiering So I've got a step down here, another huviculture that I'm building. And then a step down, this will be another garden bed. You can see I've got more potatoes to go in. And then you've got a third huviculture. This was one of the first pieces that I started with in my backyard. And it's a circle. And it's got all of my life-giving herbs. So we've got sage that's coming back from year to year. You can start to see the thyme. Oregano is starting to come. That's a weed, but that is mint. And when it all fills in, it's just this beautiful, lush circle of life, I like to call it. So from the circle of life, it gets all of the water from the rest of the backyard, and it all comes back to this place. In wrapping up the tour today, or the EcoSolar tour bit, there was a couple notes that I wanted to mention, or just to highlight for those that are thinking of building or in the building process altogether. So the first item would be that, energy efficiency, living more intentional, and just a better way of living is part of the future. And if you enjoy it, or you like it, or you're interested in it, I highly suggest to move into that space. Start doing it, start adding it, start living it. It's things as simple as a drain water heat recovery or planting food in your garden. And then it sparks more energy and more of it starts to come in. So if you're sitting on the fence in any way, I want to encourage you that yes, you're doing the right thing, and moving in that direction is something that I guarantee you will not regret. So to get down to some of the basics, if you are thinking about it again and you get a little bit overwhelmed with all of the technology out there, my suggestion would be to find a certification program that would work for you or that aligns with your values. So whether you're working with Passive Home, whether you're working with EnerGuide, there's several different sustainability LEAF certification programs. There are a ton of them. For my home and for the builder that I was working with, we did the EnerGuide. Now this was rated down in like 2013, so it's a vintage certificate. But you can see on the EnerGuide, this is the old EnerGuide report, built year in 2013. Most homes sit at about a 70 or a 72 on this old rating. Energy efficiency is at an 80, and this home was rated at a 97. So it has it's an incredibly energy efficient certification in this program. And again, it was the builder that was working with this program, and it was something that I aligned with, and we decided to go through with it. So if you're confused about what to do, look and see what the certification programs. It'll also help you guide your build, and it'll also help you out with the resale value on the back end of that. The last thing would be choosing a builder or doing it yourself. In the space of choosing a builder, the biggest thing that I recommend is check out and see if they're walking the talk. Does your builder live in a net zero home or a high performance? Are they relatable, or is it a sales manager and you don't really get to the owner somehow? These homes come with a higher cost simply because they are more than just a home. I've mentioned that they are also a power plant as well. So in that concept, you really want to spend the time to see if your builder aligns with those values that you have. If not, it will be a disappointing experience, and you don't want to spend that extra money in disappointment. The second last is get inspired. Check out the tour, check out other people that are building stuff on the tour. What inspires you? What ignites your interest? And does that play out in a home situation? So use your intuition, get inspired. And the last comment would be, don't get overwhelmed by all of the technology and professional opinions, and I like this and I like that. Everybody's got a spreadsheet and everybody has an opinion. find your own intuition and what you want to do, and work from there. Thank you for joining me on my Eco Solar tour and joining me around the home. I really enjoyed going through all of the items in my home and talking about energy efficiency and intentional living.
That's great. Thank you very much, Tara. We're going to hand it over to Gordon for questions, and I'm going to attempt to illustrate the questions with pictures from when your home was on the tour. I believe these are from 2016, so a long time ago. Your garden hadn't come in yet. Gordon, what kind of questions have we got?
Well, thank you so much. It's lovely to hear Tara describe her home and go through such a different viewpoint to net zero than we've had before. And that, of course, that I as an engineer, I wouldn't go through it that way, but it was lovely to see her non-engineering way of describing such a lovely home and experience. I actually have remembered the herb garden fridge that she had from years ago, and I mention it every once in a while to people on Facebook because they're quite fascinated about it. So one of the questions that came in was, what was the manufacturer of your herb garden fridge?
You mean who did I buy it from?
Yeah, where did you get it from?
Urban Cultivator. They're a company out of BC. They also have large commercial, like huge, like fridge types as well, but this is just their mini version.
I was just so inspired when I saw that the first time.
Do you know, sorry, I just wanted to say one thing that's funny. Andrew, do you have any pictures of the vermicompost at all? I found it really funny that out of all the things that I did with this house, the vermicompost and the little food thing were the ones that got the most interest. Anyway, sorry, go ahead.
The vermicompost a bit.
Vermicompost, so it's, I'm just trying to see if he's got any pictures of it. It would have been a box. So in my living room, actually, in my living room, I have a coffee table that opens up and there's dirt in there that I've got put in, and it's a worm compost, so a vermicompost. Yeah, you can't really see it in there. However, a lot of people found it really interesting on the tour that I would, you know, use the compost from my kitchen, put it directly in my vermicompost that was in my living room, and then I would use that soil for the urban cultivator. And I mean, if you vermicompost, you never ever, it's right behind that lady there. Can't really see it. Anyway, but it's just really amusing that out of all the cool stuff that I did in this house, people wrote articles on the vermicompost. I found it surprising. Let's put it that way.
And the worms like it.
Yeah, worms are great little soil engineers.
I'll have to remember that word. I like it, soil engineer.
Mm-hmm.
So that one comment that came in, great example of a new net zero build, Tara. Does your backup heat kick in very often in the winter, or do you use the wood stove before that happens?
We use the wood stove quite often, actually. And again, for us, it was more of a, I like it. I find it like, it's a creature comfort, right? So we use it quite a bit. The backup heat, I really only ever noticed it like, minus 35, if that. But we would use the fire. I mean, in lockdown, in the last period of lockdown, we used the fire a lot more. But I didn't notice it as much this year because we were home a lot.
Right. Do you know how much wood you use in a year?
My husband does one harvest. He'll go out to Crown Land. You can get a $5 permit and go out and harvest. So like a truckload, and then you'd be surprised at how much my neighbors and people that know that I use it call me all the time to pick up wood. So I actually have some elm trees on the side of my house from one of my neighbors that I'm going to be hacking up and drying up soon. So let's say a truckload every year.
Who manufactures your wood stove?
That's a good question.
Where did you get it from?
I bought it through this purchase for me was more about economics. I had a like under $10,000 budget for it. If you see it sitting on a big piece of granite and then granite lines it around the bottom. I would have loved to have put one upstairs in the bonus room as well on the same lines. But because we had to keep it within a budget, really it was the one that was like $7,000 installed. I would have loved to have done it like a cool little German unit, but yeah.
Were there any home insurance or permit issues with the wood stove?
No, nothing more than what you would do with your solar.
Yeah, great. There's a question that came in. Can you confirm your depth of attic spray home? It sounded like you said it was 4 feet thick.
All right, maybe 3.5. Yeah, the attic is like, so the whole attic, and maybe I could have had my husband, maybe I can grab my husband to help you out with that one a little bit more. He did that, but the whole attic space is all spray foamed thick. And again, because my husband was working in that insulation and drywall piece, we went very thorough on the spray foam.
Yeah, which is good. Is there anything special about your wood stove other than just it's a wood stove? Like, can you cook on it?
Yeah, I cook on it quite a bit actually. I can toast things. We do. I boil water on it. I mean, when I've got it burning, why would I put my stove on and pay for the stove when I could just use the energy that's right there? And that's actually one of the beauties about living in a net zero is that you start thinking of energy differently, right? Like you're like, well, if I have energy rolling here, why would I put and pay for energy over there?
Yeah.
So yes.
Do you have an outside air intake for it, or does it use the indoor air for burning?
Yeah, that was during the construction period, we really bantered over, like in a tight building envelope. You don't exactly right there. Yeah. You don't want to put more holes than what you have to. And at the time in this build, it would have been 2012, 2013. The guys just defaulted and they ended up putting in a small vent there in the side. And then as I moved into the home, I realized the seal was so tight, I couldn't start my fire unless I cracked a seal in the house. So it actually worked out okay that way. Most of the time I just crack the back door and start the fire that way. So it's got a bit of air to get going.
So is that vent, Tara, is that connected to your HRV or is it just go straight outside?
No, straight outside. I mean, what a great idea to connect it to the HRV. But again, at the time, the builder only had so much capacity to deal with these things.
What do you use for a clothes dryer?
I hang most of our clothes in the bonus room.
Aha, that's great to see. I always hang my clothes up in the basement too. Keep the moisture inside the house. So you don't use a solar and wind dryer like the Cromwell house does?
No, it's a great idea, but no.
Your northern blueberry plant, I think that's what you called it. I'm sorry?
It's called a hospice.
How do you spell it?
Northern blueberry, HASP. Let me send it to you. I'll send you it in 2 seconds here. So what's the question?
Oh, so do the blueberries taste like blueberries?
The berries are they're just slightly more oval. Oh, wow. That's a little Terra garden in that picture. But yeah, the blueberries are they're more oval and they're slightly more tart. But they're very blueberry-esque.
Oh, I see.
I warned you that the pictures, Tara, were from 2016.
Yeah, no, that's great. It shows the development, right?
I see that somebody typed in that they're called Haskap. Does that ring a bell?
Haskap. Yeah, thank you, Shane.
And apparently they're also known as honeyberries.
Yeah, I'm actually kind of a lazy gardener. I only like to plant stuff that thrives in our colder environment and that will deal with a bit of neglect.
What percentage of food do you think you produce?
My goal has always been to produce 30% of my food. However, I think that you need to design a home that would allow that would allow way more access to work with food production.
Fortunately, our next home is going to be talking about a whole farm inside the town. So that's a good preview for the next home, Tara. Thank you.
Yeah. Okay, great.
And thank you for telling me that it's actually called honeyberries, because there's a lady at the Old Strathcona Farmers Market that makes honeyberry jelly. And I have had some, and it's very lovely, but I'd never heard of it before. Your backyard was very interesting. Do you use the swales in your backyard to retain water and reduce the need to water plants?
Yeah, I built them specifically to capture the extra water.
Is there a problem with humidity in your house at all?
You know, if it is important to really manage ventilation in the home. So if my HRV is down for any reason, or if we're not properly ventilating, the only other direct vent that I have is the stove. And if I don't ventilate properly, then I get extra smells as well as extra humidity, but I'm pretty sensitive to it on a whole. So you just got to mind it and make sure your HRV is working and it's clean.
Does your HRV operate as a function of the level of humidity, such that if the humidity goes up, it turns on automatically?
No, I have witnessed when you leave mechanical to manage things like that, because you're a living person in a home and your activities change dramatically and all the time. And if you've got a unit that's constantly doing that in your home, I have witnessed it not work very well. So I'd rather be the computer and the awareness of that, other than putting it to a mechanical system and then complaining that the mechanical system isn't doing what it's supposed to. Does that make sense? Yeah. Yeah,
absolutely. I appreciate that. And different people have different tolerances for mechanical systems too. I have an airtight house and HRV also built in 1986. And I have a great solution for my HRV, my heat recovery ventilator. I don't run it, ever.
You never run your HRV?
No.
Or no?
No, I don't. My air change rate is 1, and just because of the natural ventilation coming in, even though it's so airtight and air change rate of 1, because I'm in the house, then it's.
You don't have a 13-year-old daughter that likes to shower twice a day, though. Correct. So that makes a difference.
Correct.
That's the drain water heat recovery. The one thing, can you go back, Andrew, to the last picture? So my drain water heat recovery, if you notice, it's actually an active system. So it's got the drain water, and then it's got the reservoir, and then it's got a sensor on it.
So the big black pipe going up?
Black pipe right next to it is a reservoir. So what happens is that even when I drain my hot tub, the sensor will hit it, and I'll still recover the heat from my hot tub, even though there's not hot water going up and feeding that cycle like a shower. This particular unit recovers even more. Yeah. But it also costs a little bit of electricity. So
Yeah, it's great to see some of those things happening. There's another question here about saying that I didn't notice a water collection system in the garden. Do you have any kind of rainwater collection at all?
So the community that I live in requires me to tie all my rainwater leaders directly to the storm drain. So I don't. I am slightly resentful for that. However, my husband and I were joking about how I always use man soup for my garden. So every time anybody has a bath in this house, I use the majority of the bath water for the garden.
Oh, I see, because it's not rainwater.
Yeah, it's man soup or people soup, right?
Oh, and so does the water really like the soap?
Yeah, it actually acts the magnesium, and it's in a very low amount, so I'm not burning anything. But when you put magnesium salts or Epsom salts, it actually acts as a fertilizer and a soil booster.
Have you thought of a way to cheat a little bit in terms of the rainwater?
In my next home, I've got
Oh, I
some
see.
pretty cool concepts that I'd like to do. This one, because it was a new neighborhood, I was really restricted with a lot, and the builder, I was really restricted with a lot of those little extra things I wanted to do. I got my fireplace though, which was pretty nice.
Have you considered using a rain barrel with a spillover that drains to the municipal system?
Yes, I have. Just
How do
haven't
you-
gotten there yet.
How do you collect the bath water?
In big tubs.
Like not the tub in the bathroom though.
Yeah, like they're portable 4-liter containers.
So the bath water drains into those portable 4-liter containers?
Yeah, and then I just grab them and take them out.
And in the wintertime, you don't bother reusing them though? You just
No.
do that in the summer?
Yeah.
Okay. So could you explain, in the few minutes left, could you explain again your drain water heat recovery? The question was, is there a reservoir that the hot water sits in? And Andrew's busy right now in getting ready for the next presentation, so he can't show the slides anymore, but.
Okay. So if you think of every time you drain hot water, that hot water goes down into your drain pipe, right? Now in a passive system, when you just have the drain pipe, you just have that one drain pipe, the passive system, you only reclaim hot water when it's going down and there's hot water going up, right? So, perfect.
There's the slide. Thank you, Andrew.
So most people just have that single copper piping, and it's just
Yes.
it's an inactive system, it's a passive system, right? So it works best and you recover most water when you're taking a shower, right? Because you're using hot water and you're draining hot water.
Yes.
In this system, even when it's inactive, so I've drawn a hot tub and then I've soaked in it for an hour and then I drain it. See that yellow wire there that goes across the black tube?
Yes.
Yeah. So that's just part of a sensor
Right.
that engages it and I recover all my wastewater heat. I
Right.
think I'm wrapping up here though, right?
You are, yes.
All right, perfect. Thank you. I want to take a quick moment and thank you, thank you guys so much. This is wonderful. And it's wonderful for Western Canada and for Canada to have this information out. Thanks again.
Well, thank you, Tara. This is really interesting because our next person is also named Tara, and she's out in Beaumont, and she's got a house that we're, going to go the other way here, calling the urban farm, the Beaumont Urban Farm. And so she is concentrating more on her farm and less on her house, whereas Tara Bloom started with the Net Zero house and then is working on her garden. Tara in Beaumont is going at it the other way, starting on the garden and then moving back to the house. So we have a video to show where Tara introduces her garden, her Beaumont Urban Garden, and we'll run that as soon as it turns 3:40, so in just a few seconds. So I'll just move the video thing over here, and when we're ready, I will let her go. Here goes Tara on the Beaumont Urban Farm.
Hi there, and welcome to the EcoSolar Home Tour. My name is Andrew Mills, and today we'll be talking about an urban farm in Beaumont, Alberta. With me today is Tara Pombert, who's the homeowner of the home. Welcome to the EcoSolar Home Tour, Tara.
Thank you, Andrew. Thanks for having me.
Now, your home is an example of an energy-efficient home that features a 5-kilowatt solar array, and it has an extensive permaculture garden. So give me a bit of background on why you chose to build your home like this. What were the main things you were trying to accomplish?
Well, I chose this home because it had a really good location and great sun exposure for gardening, and of course was the right price. I've always been interested in finding ways to be part of the shift towards sustainable living. Energy, food, and waste are three of the big factors that need to be decentralized and expanded in order to create sustainable cities. This home is an ongoing personal and now business project to be as self-sustaining as possible in an urban setting through renovating and upgrading an older home. Reducing energy costs and having the security of providing some of my own energy and contributing to the energy grid has always been a goal of mine. And I'm continually upgrading this home and hope to add in drain recovery system, heat recovery system, an additional solar array with a solar covered car park, and hopefully a gray water system of some sort, and eventually upgrading the exterior walls as well.
Interesting. So just give us a background. What's the EnerGuide rating of your home?
So my EnerGuide rating was rated at 74 of 100. It was tested in 2001 or 2011. I'd like to get retesting done as I have since upgraded the attic. But the first testing was done when I took advantage of the Eco Energy Home Retrofit Grant program in 2010 to 2011. They measured the before and after, and I believe my home was around 58 out of 100 before the upgrades. I replaced the windows, added attic insulation to R50, added a high efficiency furnace, and replaced an exterior door and put in new weather stripping. At that time, I didn't know very much about things that could be done to increase efficiencies, but after being part of the EcoSolar Home Tours and visiting more of the homes, I've been learning about other options to look into and will be working towards including them in the future.
Well, I love the plug for the tour. Thank you very much, and hopefully be able to see lots of good things on this tour as well. So now let's take a look at some of the pictures. So what would you say is the standout feature of your home?
Definitely the solar panels and the garden tend to stand out. I also really love and I love my solar system in part, especially because like the online, being able to look at it online was like a big draw for me when I first got it. I would be online every day, like checking sort of like what my solar panels were doing. So that was just a really fun feature to getting solar. I also, another feature I love is just sort of the upgrades I've been doing on the interior of my home. So I like finding ways to reuse secondhand products. So like I often get secondhand doors like you see in this picture from Habitat for Humanity Restore. So these doors in this home went right up to the ceiling. So replacing those would have been really expensive and hard to find. So I have replaced them with now these reused doors, which is kind of cool. Each door is different, and it's kind of a fun way to reuse fixtures and materials and be a little bit more eco-friendly, I guess. Yeah.
So when we build energy efficient homes, we make a series of choices. What would you say are the main choices that you made as far as energy efficiency in your home?
Well, because this was an older home, I started where I could with windows, attic insulation, weather stripping to address air leaks, and of course, upgrading the furnace. I think in these older homes, mine was built in 1981, considering upgrading the exterior wall is an important step to increasing efficiency. What I found out after looking into it is it's best to do that at the same time as the windows. Focusing on leaks is important in older homes, and ensuring your lights and appliances when needing replacement are replaced with high efficiency models. It's important to do what you can within your budget while investing in efficiencies for things that have a long product life cycle. I definitely resource secondhand and visit the restore, as I already said, and look at local markets like Kijiji as much as I can before buying new. Being sustainable and energy efficient has pathways beginning from the production of the products we use. Often efficiencies can be created in how we use what we have. Remembering to put things on power bars or keeping your home and hot water tank a bit cooler, taking shorter showers are important things to improving efficiencies. So changing habits, like not flushing the toilet until few people have gone, number one, may not look nice, but it can save a lot of water. Often it's the personal habits we have that can make a big difference. As well as investing in efficient technologies.
That's interesting. Are there any other things that you're doing to save water other than waiting to flush?
Yeah, we have low flow toilets and shower heads. I hope to add in a drain water heat recovery system eventually, so that'll help with heating the water anyway. And maybe eventually hot water on demand once my hot water tank goes. I hope with my farm, I'll be able to develop a wash water recovery system as well. And I have rain barrels and and the water from washing veggies goes back into the garden as well.
Very interesting.
Yeah.
So let's talk about your garden. This seems to be one of the bigger parts of your home, and one of the things that you featured on one of our tours previously. Give us some background about your permaculture garden.
After I bought this home, I was studying in university and doing a communications degree, but ended up coming across all these amazing courses on environmental stuff and discovered permaculture, and then started experimenting with my garden and with my property. This front garden is now 12 years old, so very established, and it was a lawn to begin with. Since then, this home has become an urban farm. It has 2 greenhouses and a walk-in cooler. And the garden continues to evolve using permaculture and now regenerative farming practices, growing a portion of one's own food and increasing biodiversity in an urban environment is really important towards building sustainable cities. So yeah, so that's just some pictures.
That's a very interesting garden. Oh, there's your greenhouse.
Yeah, that's the greenhouse, and that was it growing last year. And then just my small starter greenhouse. And this is the walk-in cooler that I built, and this is part of my wash station that's still being developed this year.
Interesting. So what would you say is the most challenging aspect of upgrading your home?
I guess finding the time to learn about options for upgrades, as well as the money to continue the upgrades. Putting up the solar was the easy part. Finding ways to continue with other upgrades I'm finding is more challenging, but I hope to focus more on these next years. Already I'm looking into those honeycomb blinds that I saw in another video for the tour this year. I thought that would be a great way to improve the efficiency of my windows, because I only have 2 pane and not 3, without having to, redo them or spend a whole bunch of extra money to reduce some of those drafts and keep it a little cool in the summer.
Okay. I'm going to go to this question here. Is there anything you would have done differently in building your home?
What would I have done differently? No. I would have completed the exterior upgrade at the same time I put in the windows. Also, I would have looked into getting a little bit more efficient furnace. Mine is high efficiency, but it's like on the low end of efficiency.
Okay.
So I think investing that little bit of extra money at the start would have been worth it. I also would have put up more solar panels when I took advantage of the grant in 2017 to get the solar. I didn't realize, a few things I didn't realize about it was, one, you could the grant was based on how much energy used for how big a system you had. And I could have easily added extra solar without, getting any rebates for it. But with the guys already there, it wouldn't have been that much more money to just add a few more panels.
Right. Okay. So speaking of solar, I think you said before that the solar is one of the most satisfying things. Tell us about how you feel the solar has been working for you.
I think it's been really good. It's a good conversation starter. People are always interested in how it works. I still enjoy, going online and seeing what I produce every year and seeing the differences every year. I also want to be part of that change and help encourage others to adopt microgeneration. It'll make it cheaper, and also the more energy we all produce in our communities, just sort of the more sustainable that is, and just more stable too. So
okay. So finally, what's the part of the home that you like the best?
Definitely my garden. In the summer, it's just a wonderful space to relax and see the diversity that comes through and kind of observe that miracle of nature at work. It's kind of fun to be the weird house on my street and normalizing biodiversity in the city. Yeah.
Okay, that's great. Thanks for showing your house today. Is there anybody you would like to thank who helped you in the design or construction of your home?
Center Star Energy did my solar installation, and of course my friends, family, and my children for always being so supportive as I've pursued these sustainability goals in my life, and my neighbors who have not always agreed or understood what I've been doing, but have remained supportive even when it may have looked a bit unusual.
Okay. Well, thank you, Tara. Thanks for joining and sharing pictures today.
Well, thanks, Tara. I'm going to then hand things back over to Gordon to talk about any questions that have come in for Tara. Just line up with her presentation here so we can try to illustrate with pictures as the questions come in. Gordon, if you may.
Well, I have to say how much I enjoyed the presentation. I actually got so mesmerized in following it that I'm a bit behind in collecting questions. I'm fascinated by your garden. I haven't seen your house the other time when it was on the tour. Did you have any objections from anybody when you put in your garden? I mean, I love how it looks and I love the biodiversity, but did you have any objections?
Luckily I didn't. And I think part of that is just my location. So I'm in an older area, and I also have a field and a high school across from me. So my home is not really directly visible by anyone across the street, I guess. And I'm also kind of on a curve. So whether, that contributed to no one really complaining because no one's really completely staring at it, if that bothered them. And I mean, I do hear the odd comments, either really good ones where people love it, or, the odd comments where people are like, what the heck is going on over there? But throughout my journey, but, I don't let that stuff bother me. So.
Have you done anything for bees?
Well, this year I often have bees actually that just make their homes here. I have seen like 5 different kinds of bees on my property. Often I have a family of bumblebees that make their homes underneath sort of different things around my yard. But I don't have any bee houses or anything yet. That's something that I'm sort of working towards. This year I did plant some Monarda, so some bee balm, which is supposed to be really good for bees. And the bees seem to thrive at my house. They love the onion flowers. They're always just swarming sort of around there. It would be really cool to have my own like little beehive. I just haven't figured out where I could put it where, it wouldn't be affecting, neighbors or where I'm working. So.
Or a little bee house for one of the for the solitary bees.
Yeah, they seem to find like I have lots of old logs and pieces of wood and stuff here, so they tend to just already make homes in a lot of those places.
They tend to do that, yes. Do you know what portion of food comes from your garden?
In the summer, I purchase almost no vegetables at all. Like yeah, there's very few veggies I have to buy throughout the summer. Because I'm selling produce now, I tend not to have very much saved over winter anymore, other than like some root crops, so potatoes, carrots, that kind of thing. But like most of my summer crops I sell. So then in the winter, I have a subscription with the organic box, and I get my produce from other farmers. Mm-hmm.
Can you, thank you. Can you tell us more about the walk-in cooler and how you built it?
Well, that was a really fun project because originally I was looking for just a secondhand walk-in cooler, but they were really hard to find and quite expensive. And then I lucked out an elder in our community, an elder gentleman who is a carpenter in our community, helped me frame out the shed. So basically it's an insulated shed. And then I did some research online just on how to insulate it. And so it's got about 6 inches of insulation. I'm just trying to think what the R value is, but it's up there. I can't remember right this second. And then I got a CoolBot, which is basically a little device that tricks an air conditioner into reducing the temperature. So yeah, it works really good so far. So I've been really happy with my cooler.
Do your greenhouses able to work in the winter at all?
No, I am a seasonal farm at the moment, and I think that's where I'd like to stay. It's nice to have some time off in the winter for sure. And I am looking into, because I'm turning this property into basically, hopefully it'll be like 80% permaculture, so all perennial crops. I've been expanding on like asparagus and strawberries, raspberries, and perennial herbs. And so I want to get into drying herbs, making teas, doing that sort of thing. So that'll give me some of that winter income throughout the season.
So then a solar dryer might be fun too.
Yes, I've been looking into that a little bit, just haven't quite got there yet.
Right.
Yeah.
So you said that your garden was a business, and so do you sell produce at a market garden?
I do. I sell produce at just the Beaumont Farmers Market. This is only my second full year summer, so just finishing up the last bit of development this year and learning how to produce more food, because it's definitely not as simple as when you're growing for yourself.
Yeah. When is the Beaumont Farmers Market?
It's Thursdays from 5 to 8, and then one Saturday a month as well from 1 to 4.
Uh-huh. Do the trees in your mature neighborhood affect your garden?
I don't think so, other than there's a maple next door and I'm always weeding out maple babies.
Oh, yeah.
But otherwise, no, I have cut down a couple of the bigger trees on my property and then begun replacing them with like smaller trees to take over as like the windbreak on the northwest. I have a path right next to my house as well, so there's quite a distance between me and my neighbors, so I'm not really affected by anything around me in that way.
Do you have food production in the front yard, or is it just ornamentals there?
I have, so in the very front along the sidewalk and sort of the perimeter, I guess, is where I have like my zone 4. So all where I've been introducing more and more native crops, native species, and I don't grow any food in that front. But other than there is some wild strawberries in there and maybe some chives, but I don't really, we harvest the wild strawberries for ourselves, but not to sell. And then I sell cut flowers as well. So in those front parts, it's kind of like shrubs and stuff. So it's a barrier to stop some of the dirt and traffic, sort of traffic pollution from coming right into my yard. And then, yeah, that's about it.
What's your garden pest management plan?
I do a lot of observation. And because I have such diversity, I just try to continue to introduce plants that attract predator insects and ensure, pieces of wood and stuff act as little sort of homes for different types of good bugs. And then just observing. So when I start to see a lot of I don't know, little bugs that come on, I can't remember, aphids and things, then I do a lot of manual removal of insects. So if it's one plant is really infested, I just remove it quickly, and then that can prevent any big outbreaks going to some of the others. But a lot of the flowers tend to attract the pests or some herbs and things. So that sort of helps. And then I've pretty much stopped growing most of the cabbage family because it's hard to make money off cabbages. They take too long to grow and too much maintenance.
Too many pests?
Yeah, the cabbage butterflies. They'll just like take over. And then for slugs, I often do like beer traps. And this year, I was advised to use wood ash. It's supposed to really help too in coffee grinds. So,
do you have a favorite plant to grow?
Like I'm not sure. I love growing beans for some reason. Like bush beans. Yeah, I love growing beans. I don't know what it is about them, but I just love fresh beans, and yeah, they're fun to grow, I think.
What month do your greenhouses start working?
Well, this year I started at the end of March, probably mid to end of March. I think next year I'm going to start a little later, probably like beginning of April to mid-April. I think I started a bit too early this year.
And when you say start, was that start putting in bedding plants or?
Yeah, so just started my tomatoes and squashes, and yeah, just kind of started a bunch of stuff, flowers and things early. And I think it was just a bit too early.
What do you sell at the farmer's market?
Right now, because I'm seasonal, so right now I have asparagus, chives, green onion, mixed bouquets of flowers, and then spinach and salad mixes right now, and rhubarb.
Rhubarb too.
Mm-hmm.
Let's see, another question. Any fruit trees or shrubs that surprised you with higher than expected yields?
My cherry tree did really well. I had I think it was a Carmine Jewel cherry tree, and it did amazing. I would have bumper crops several years. Yeah, really good production on that. And raspberries always do amazing here. Yeah, those ones have been good. The rest of my fruit trees are still quite young and small, so just waiting that bit of time for them to grow up and bear their fruit.
Do you do any so you sell all your stuff, so you don't have any canning for over winter?
I do canning for myself. So berries I do harvest and freeze over the winter, and I make all my own jams that I often give away as gifts, as well as feeding my family. So I haven't bought jam in years. And then I also freeze some fruit for just eating too. So there's some places I go to pick fruit elsewhere as well. So Saskatoons and stuff that I freeze for my family. Yeah.
Did another question from the chat room, did your family change any habits at all since you added your solar system?
Well, we were doing really good, I think, in general. Like I've always been conscious of turning off lights and just any fixtures and stuff I've replaced, just making sure that they were efficient. I'd say other than that, I wouldn't say we've changed too many things about our habits. My use was pretty low before. If anything, we probably use a little more electricity, especially with COVID. People just on screens more and stuck on screens in school and stuff like this. So
yeah, that's very true. Do you get the Solar Club price in the summertime?
I don't. I know you had mentioned to me about that before, but I haven't pursued looking into that. But that's definitely something as I put on some more solar, or potentially even now, that I would look into.
And I'd be happy to walk you through it. I find it very easy, and it would be very easy to get you set up properly.
Awesome.
And I think you would find it extremely beneficial. Do you generate all of your electricity throughout over the year, or?
No.
No,
I couldn't tell you how much now because I did start renting a room in my basement. So with another person here, we are using a lot more electricity than I used to. Whereas before I might have covered probably like 70%, I would say, for sure in the summer anyway. Now it's much lower.
What's your favorite ornamental native plant?
3-flowered avens.
And they're a type of flower?
They're absolutely gorgeous. They're like little truffula trees. I have some here, and I'm hoping to collect flowers and or some seed to get more going around my yard because they're just beautiful. I also really love the low milkweed as well. It's very pretty.
Do they have a scent?
I'm not sure actually. It must not be a strong one because it's not sticking out in my mind as something really scented, but they are just really pretty looking, like really interesting. And we just have so many amazing native prairie flowers here. And they're all becoming some of my favorites just because they're so unique and beautiful. And they're so hardy. Like I do nothing and they come up every year. So
that's always fun.
Mm-hmm.
Where did you get the native plants from?
Through volunteering with the Edmonton Native Plant Group.
Oh, I see.
So I got a lot of my flowers from them. You can also buy seed through them as well. But the volunteering, then you often got to take home free plants.
So Edmonton Native Plant, did you say?
Yeah, Edmonton Native Plant Group. Mm-hmm. Sure. They're champions for protecting a lot of native prairie species.
Mm-hmm. Another question here. Do your boys help you in the garden, and do they like it or complain about it?
Definitely complain. They do help a little bit, but a lot of the work I do during the day when they're at school. So, and then I try to focus more on having family time outside of that. But they do help here and there, grudgingly. Yeah.
So from the pictures, it seems like your backyard is a fair bit bigger than your front yard.
Yes.
So in Beaumont, does everybody have bigger lots generally than in the city?
I'm not sure. I couldn't answer that question because my house is an older home, so the lots are just a bit bigger. I think the new development, I would say, is comparable to Edmonton.
Right. Yeah. I don't see any more questions on the chat room at all. Do you have, just a minute, what sort of mulch do you use around the veggies? And do you top it up annually or just move it around?
So mulch, I usually get chip drop and I use that mulch for my pathways and in my flower beds and stuff. With the veggies, I prefer to use like a cut grass or else a straw. If I'm mulching around vegetables, like around my lettuce for head lettuce and stuff like that, so it doesn't get dirty, and strawberries, something a little lighter that breaks down a bit quicker is better than using a wood mulch.
So Tara, I've got a question. You're working at you're creating a bit of an urban farm here. You're taking your produce to the farmer's market. At this scale, at this size, is it possible to get like an organic certificate for this kind of operation, or are you just too small for that?
I'm not sure. This is a direction I want to go into because I grow food at like 6 different places. So at 2 other properties in Beaumont, and then at a community gardens, an acreage, and a community farm outside of town. So because I'm at so many places, I'm not sure. And I'm also need to look into like policies of whether I can get some of the same benefits of a larger farm. Because normally a farm is like 80 acres and up. And I'm working at around 5,000 square feet at this time. So, it's still such a new thing. There's still just a lot of support that's missing for small farmers, and yeah, just kind of waiting for those things.
It's interesting you say you have 2 other sites. They're obviously nearby or just outside of town. Yeah, okay.
Well, there's 5 other sites than this one. I only have, 2 of them are permaculture like I have at my home. So I was blessed to get to take over someone else's backyard. doing permaculture, but my other properties, I do like market farming style, more market farming style farming for increased production. And those are all just like annual production, not permaculture.
Well, that would make more sense that for you to be able to go and sell at the farmer's market if you have a little bit more, I won't call it acreage, we'll call it footage.
Yes.
What is chip drop?
Chip drop is, so you can just go online. It's literally called Chip Drop. And basically all the arborists can sign up for Chip Drop because it's a lot faster and easier for them if once they're done chopping down a tree and shipping it up in communities that they can just drop the load nearby rather than having to go, say, all the way to the eco station or to wherever they're allowed to drop chips at. So you can sign up for that. And then when an arborist in your area has a load of chips, they just come to your house and they drop it off on your driveway, and it's free.
Oh, it's free. Well,
it is free.
If they took those chips to any of the landfills, they'd have to pay for disposal. So that's a good deal for them.
It is.
And less driving around. Does the mulch get dug into the soil at some point?
It becomes the soil at some point as it degrades over time. And same with when I'm, planting or mixing like in the veggie beds, the mulch definitely gets mixed in, and that's why it needs some replacing as harvesting gets done or as weeding gets done. In the chip paths, they slowly degrade into organic matter over time as well. But I don't dig them in. I prefer, you want a nice thick layer on your pathways to reduce weeds coming up.
Do you use compost? And if so, where do you get it?
I do use compost. I have a few different sources. I buy it locally at a landscaper just south of Beaumont, where they have a really nice organic compost that is free of weeds and weed seed. So that one's really nice. I do get some free compost from people as well, or at some of my garden sites, they have, chickens or goats or other sort of farm animals. And they have piles of compost or piles of manure that has composted over a few years that I get access to. So it just depends where I find it available or what is already available at the sites I'm working.
2 more questions. What future plans do you have, and what have you learned that you might do differently if you were to do it over?
Well, I'm a graduate student, so my current plans is just continuing to find ways to support and develop urban agriculture. Currently, there is some policies happening in Edmonton and in Beaumont. One is the Regional Agricultural Master Plan, and then in Beaumont, we have an environmental master plan happening, both of which are looking at ways to include and develop urban agriculture or protect lands for agriculture in the region. So my work my research is sort of evolving around those things. And what I would do different as far as my farm goes, I'm not sure. I might have done my design a little different had I known I was going to do a farm later on in the future. Definitely my front yard, the front yard of this home was done just pure experimental, whereas like my backyard is definitely more planned after I'd taken some more permaculture classes and started really learning to understand the space and how I use it and how I want to walk through it and what works the best. I think when you're planning or designing your space, if you want to turn it into something like that, think about how you walk through it comfortably and then design around the pathways of use. I think is really important for making the space user friendly and useful, I guess,
What is your graduate study?
I'm doing a master's in community engagement.
And what's your thesis title?
It's not, I'm just doing my proposal this summer. So I just finished my first thing. Right now, it's kind of around, it's kind of titled at the moment, I guess, Connecting Rural and Urban Agriculture in the City, a Badass Bridge into the Future. And it says badass because our agricultural society is the Beaumont and District Agricultural Society. So the acronym for it is badass.
Oh, that's fabulous. Sorry, master's in community engagement?
Yeah.
Wow, that's phenomenal. That's great. So one question that did come in, how do you find time for grad school plus urban farm plus raising 2 kids?
That's a good question. I'm really working on balance and just being happy with where you are at now, and that everything can get done as it gets done. Nothing is so important that it can't wait a little bit. So yeah, actually this week I'm really just kind of organizing my schedule and making sure that when I commit to family time or when I commit to rest time, that that comes first, and not stress or worry about, you know, if those weeds are getting slightly bigger or whatever. You just kind of got to do the best you can. It is a bit much sometimes. I wasn't expecting to do school this summer, but because of the policies that are going on, sometimes you just got to seize the day and ride the wave the best you can. I have a couple people that help me too, or that are going to be helping me throughout the season with washing and prepping veggies for market, and doing a bit of weeding as well. So I'm not just going to be a one-man show the whole year like I was. Well, actually, even last year I had some help with the market. So yeah.
What do you do with all the cherries? I suffer the same overproduction, was the question.
I love the sour cherries. I definitely make jams and jellies. I include them in different like crisps and stuff as well. There's this cherry barbecue sauce I really want to try this year. I love the sour cherries, even a sour cherry juice. I made like a sour cherry kind of caramel last year, which was amazing. Yeah, just finding some use for that and mixing it with other things because they are a bit tart. Oh, another way I love them is dried. That is probably one of the most popular, where when I do dry some, there's a little demand among a couple of friends who want some because they're just like a nice to throw into like a trail mix, or, you know, you buy a trail mix, you just add some of those in and they're just like so delicious, or in cookies or whatever.
How do you dry them?
I have a dehydrator. So
electric one.
Yeah, an electric one. So I just toss them in there. That's why I want to look at, you know, a solar dryer of some sort, just to sort of reduce the energy use for that. That's why I don't make as many sour cherries as dried as I would like, just because I struggle with that balance of like using the dehydrator is just so energy inefficient. I feel like, you know, compared to drying herbs, which you can dry in like bags outside, the sour cherries are a bit more work for sure.
So do your 2 boys bring their classmates, do their classrooms come on a tour of your place?
Not yet. That's something that I would like to be partnering with a bit more in the future, especially once I get my solar covered car park done, or at least the car park part done, because then I would have a covered space to run some programming and stuff, or be able to work with the schools, or you know, work with the schools and the Ag Society, delivering some sort of thing. Yeah, there is one class that comes by to look at the native plants on their way to the spray park, where they include that in their program, but I'm not directly involved at this time.
So you don't have a garage yet, and you want to make a car park?
Well, I just want to have, yeah, a covered car park area, maybe with some screens that could be rolled down or something like that. So it's not a full garage, but a covered space to do work or hold classes or something like that. Yeah.
It's really fun to see how that could relate to your master's in community engagement, which is great. And of course, the solar home tour here, I mean, this is all about community engagement too. And the reason why I set it up so long ago with some buddies is really to give you, the homeowners, a way to boast and brag and all that stuff to show off what you've been doing so that we wouldn't, and this is what I thought at the time, so we wouldn't have to wait around for companies and the government to show us what we could do. Because I myself was doing things, and I knew a bunch of other people doing things, and I thought we need to celebrate this and pass the message on. And I think it's been working well.
So thank you. I'm going to interrupt you right there. Thank you, Gordon. Thank you, Tara. We are going to move on to another home out in the Beaumont area, and another home that features a large garden. And this is the Beaumont Net Zero Energy Home. And I'll just have a video to play, a video interview with the homeowners that will introduce the tour. And we'll start that in a moment as soon as I get it set up. There is the setup. And let's play the video, and we'll introduce the homeowners and the Beaumont Net Zero Energy Home. Here we go.
Hi there, and welcome to the EcoSolar Home Tour. My name's Andrew Mills, and today we're going to be talking about a net zero energy home just east of Beaumont in Leduc County. With me today are Lorraine Hibert-Soucy and Ben Soucy, who are the homeowners. Welcome to the EcoSolar Home Tour, Ben and Lorraine.
Hi, Andrew. Thanks.
Thank you.
So your home is a very interesting example of a net zero energy home that features active PV solar and passive solar, solar blinds to help reduce the heat in the summertime, and a very interesting rainwater capture and reuse system. So give me a bit of background on why you chose to build your home like this. What were the main things you were trying to accomplish?
Well, I guess we had a growing awareness about the climate change crisis. We became aware of the EcoSolar tours about 20 years ago and started attending regularly. We then, a few years later, became empty nesters, and we wanted to downsize our home. We thought that it only made sense to build with the smallest footprint possible. And so the EcoSolar tours spurred our enthusiasm, gave us concrete ideas, and gave us a list of net zero energy builders that we could choose from.
Well, we certainly appreciate the shout out. That's great that you got something from our tour. Hopefully our viewers and people that come on our tour will be able to get as much from it as you did. So let's just start by asking you about the EnerGuide rating of your home. What was the EnerGuide of this particular home?
So when we built our home a few years ago, it was EnerGuide rated 96 out of 100, which is built green platinum. Now, today under the new EnerGuide system, our net zero energy home would be rated at 0 gigajoules per year.
Yeah, very good. That's great. So let's take a look at some things in your home. First of all, what's the standout feature of the home?
It is super insulated. So our walls are called an EnerMax system. So it's a 12 inches deep wall on the main floor. It's a 2x4 wall with a 5-inch space, and then with another 2x4 wall. And then this is all packed with insulation. So that gives us an R value of R56 on the main floor, R40 in the basement walls. Our attic is also extremely well insulated with insulation, and it is at R value 100. And our concrete slab in the basement is also insulated, and that's giving us a rating of 7.5.
Wow, that's a lot of insulation. You know, when we build energy efficient homes, we make a series of energy efficient choices. Now, you've obviously made a bunch of those. What would you say were the main choices you made for energy efficiency in your home?
Well, building the envelope the way we did with, the efficiency it had was a no-brainer. The small additional cost of building this way made it really easy for us to decide. We chose the lot because it faces south, and this was ideal for capturing the maximum solar energy for our panels. We're actually 10 degrees west of due south. We have 52 panels with micro inverters, so each panel has its own inverter. And we calculated that the savings in our energy costs would make it affordable for us to, do the installation of the panels on the house. In addition, we incorporated a passive solar heat design for the house. We have large windows on the south side, and in winter, because the sun is so low in the sky, the sun coming in heats the house really well. And in summer, with the overhangs, the sun does not come into the house, keeping it nice and cool, which saves us some energy.
Very nice.
And this is augmented by the exterior solar blinds. These solar blinds are mounted on the exterior of the house with tracks. Our research showed that if you have blinds on the inside of your house, the sun heats the cavity between the window and the blind, hence the heat is in the house already. With the solar blinds being on the outside of the house, the solar blinds prevent the heat from coming into the house to begin with.
Yeah, that's very true. A lot of people don't understand that if you keep the sun out of the house, you can keep the heat out of the house in the summer as well. Very nice.
Exactly. And another consideration was our doors and windows. The choice we took was the triple pane low E coated windows, argon filled, and they were the highest efficiency and comfort. As well, our front door is fiberglass because of its efficiency rating for energy. And because we have such energy efficient house, we're able to heat it with 2 small electric furnaces. We don't need to have a gas line, so there are no carrying costs for our house on a gas line because it doesn't exist. So everything in the house is electric, including the fireplace. And we also have high efficiency appliances as well as LED lights throughout. And
so I think we have a picture of the furnaces there.
Yes.
Yeah, there they are. So these are actually they're like a furnace, except they operate completely electrically.
Exactly.
And since your house is so efficient, these really don't operate that often. They keep the house warm enough, but they're not really a huge draw on your power, are they?
Exactly. On a sunny day in winter at 25, 28 below zero, the furnace might come on come evening. Some days it doesn't come on at all, even in winter.
That's remarkable.
And we also have a high efficient dual core life breath heat recovery ventilator, which circulates the air in the house, completely recharges the air in the house every 3 hours. And in the winter, the cold air coming in is heated by the warm air going out of the house by a heat exchange manifold.
Another area of cost savings is water costs. And I understand you have a very interesting system in your home to help save water. Tell us more about that.
Well, Andrew, we have a 3,800 gallon cement cistern that provides water for our outdoor uses, household toilets, and all the other non-potable water needs in the house. This reuse of rainwater provides us 60% of our household water needs.
That's really interesting. Just hold on to that other one for a second. So I wanted to ask you, where does that actual non-potable rainwater get used? Like where do you specifically use it in the house, if you don't mind me asking?
The rainwater gets used, like I said, in the outside taps. Inside the house, we use it in the cold water for the washing machine.
Okay.
The toilets, of course, and the cold water taps in the showers and tubs.
That's really interesting. Do you ever have to clean out that tank? I mean, you're collecting the water off the roof of your house. Does it get dusty? Does it ever need to be cleaned out?
We actually have a debris basket filter on the outside of the house. And inside the house, in line, we have a 5 micron filter. which we replace about every 4 months.
Okay.
The cistern itself, we disinfect the water with food grade hydrogen peroxide once a year.
Okay.
And we get the cistern professionally cleaned every 4 years.
Oh, that's really interesting. The last question I have, you say it uses your, it's responsible for about 60% of your water use. Does this,
actually.
okay, does it provide water year round, or is it seasonal? Do you get enough water to use it year round?
So far since we've been here in the 6 years, there are only 2 years where we ran out of cistern water February, mid-February-ish, till it started to rain in April. The other years, we've had enough to last us through the winter. So it really depends on the climate.
That's really interesting. You had some other water-saving devices too. I believe you have drain water recovery. I'll let you talk about that.
Sure. The drain water heat recovery system actually takes the hot water that we're using in the shower that goes down the drain, and as that hot water is escaping, the fresh water coming into the hot water tank wraps around that drain in a separate pipe, and the heat exchange from that copper pipe that you see here actually warms the incoming water supply by a few degrees, saving us energy in heating the hot water tank.
Very interesting. So are there any other features of your home that you want to talk about? Maybe permaculture or electric car or some other unique items? Anything else?
Yeah, so we have a rough-in for a 220-volt outlet in the garage for an electric car. We have done a lot of xeriscaping in the yard with mostly native plants. In addition, we have a large garden orchard and a greenhouse. And so this actually is, adds to our low carbon footprint because we don't, growing our own food, we don't have to make as many trips for purchasing groceries in those months.
So thank you for telling me about all those things and the features and everything else. So I've just got a couple other questions here. And one is, what would you say was the most challenging aspect of building an energy efficient home like this?
So when we were designing the home, the air source heat pump for our colder climate was something new, and it was relatively untested. So while, we considered that option, we did at the end of the day decide to go with a more conventional heating system with our two smaller electric furnaces.
Okay.
Yeah.
Okay. So overall, what would you say were the key costs in building your home?
So the energy efficient building envelope was relatively inexpensive. So that was an easy decision. The electric furnaces were about the same price as the conventional gas furnace. The triple paned windows were slightly more expensive than the double pane, but it made sense to upgrade given the insulation over the rest of the house. And the largest consideration, however, was the decision whether to install the solar PV system immediately upon building or wait and install them sometime after we had moved in.
And in effect, you put it in right away.
We did put it in right away. Yeah, after some considerable research in terms of the energy savings and the utility costs. It was determined that even if we had to borrow extra money on our mortgage, that would more than cover the cost of the savings in utility bills. So that actually made sense to install them immediately.
So the extra mortgage payment balanced your actual utilities that you would normally have paid for electricity. That's very interesting.
That's correct, yeah.
So are there any other examples of cost savings as a result of the way the home was built?
Well, we have a lot of examples. cost savings. I mean, the water efficiencies in the house, low flow toilets, faucets, etc., as well as the underground 3,800 gallon cistern for capturing rainwater means we have 65% savings on our water bill annually. Mm-hmm. And this is considerable because we're out in a subdivision in the country. Our water is trucked in from the city to a community cistern, and this is expensive. The neighbors are paying on average $200 per month for their water. Our water bill is on average $45. We have no gas line, so like I said before, we don't pay any carrying charges from the gas company for that line. And I guess the greatest cost savings for us is the electricity. Solar production provides most of our electric needs, and we have no electric bill for 6 months of the year. Mm-hmm. So, you know, this compares to similar sized homes which pay on average $500 a month for electricity.
That's really neat. That's very impressive. Is there anything else you would have done differently in building your home?
And thinking back, I think we would have added a few more solar panels immediately. We have it roughed in for an additional 20. We would have installed those 20 at the build.
Interesting. What's the part of your house that you like the best?
Not getting power bills.
That's great. Now, last question. What aspect of your home was the most satisfying to complete?
So Ben installed the solar panels all by himself.
Oh, so, nice.
Yeah, he had a tutorial from the solar provider, Skyfire. Mm-hmm. And after that, he decided he could do the install himself. So he designed a system where he could use a pulley type system to put them up on the roof. And so he installed them, and we had an electrician do the actual physical connection. So Ben, I should mention, is a former tradesman and also happens to be a bit of a MacGyver type of person, that he can figure out how to do almost any kind of trade. So that was very fortunate for us.
She says MacGyver, I'm just a good guesser.
Oh, excellent, excellent. So I hear you're going to be looking at building another new net zero home. That's very interesting. Tell me anybody that you'd like to thank about your design or in the construction of your home and what you're doing next. I'm very interested.
Well, we'd like to, thank Rosecrest Builders who helped us build this home. Mm-hmm. And we also want to thank Maxwell Realty for listing it and helping us to sell it. What we're looking at now is buying we've actually bought a small farm, 12.5 acres of organic berries and fruits, and we're looking to build another net zero home on that property as well.
Wow. Well, I wish you a lot of luck in that, and I'm looking forward to seeing your next home when you get it built. And I'll also come out this summer to see your home on the Echo Solar Tour. So thank you, Lorraine and Ben, for joining me today and sharing pictures of your home. I do look forward to seeing your home in person when the tour comes up. So I also want to thank the Echo Solar Tour sponsors. Our sponsors offer many interesting services to help you build an energy efficient home, and we encourage you to visit them. Please visit our website to find the links to all our sponsors. Okay, well, thank you, Lorraine and Ben. That was a lovely interview. We appreciate you putting the time in to do that with me. Now I'll hand things back over to Gordon. And Gordon, what kind of questions do we have?
Yes, we only have a couple right now, but so I would encourage anybody on the line to send your questions to me, the quiz master, so that I can relay them off to the Susies for a nice chat with them. So one of the questions though was, do you have anything for heat storage for your passive solar, such as concrete?
No, we don't. We've considered concrete
but in the end decided to go with a engineered hardwood floor. So I guess our heat storage is the envelope with the R56 insulation in the walls and R100 in the roof. The heat from the house dissipates quite slowly on a winter night.
Absolutely correct. Yeah. Well, yes, and all of the wood inside your house adds to general thermal mass, of course. But yeah, that's cool. So how is the temperature in your house throughout the year, especially throughout the summer?
In the summer with the solar blinds, we open windows at night on occasion to to cool it down. The house is on average 20, 21 degrees inside, except for the master bedroom. I like to keep it at 17 or 18.
And how do hot summer days affect the house?
We climatize 20, 22.
Okay, but you don't get overheating ever?
No, we don't. As a matter of fact, last week we had 29, 30, and 31 degree temperatures. And inside the house, we were at 22 degrees. The bedroom was at 20.
Isn't that remarkable? And you don't have any air conditioning, do you?
No, we don't. When we considered the air source heat pump for a furnace, we would have used that as an air conditioning source as well. But in the end, the technology at the time, we weren't really guaranteed of 100% feasibility. So in the end, balancing the costs of the air source heat pump versus a regular furnace and so on, we decided to go with the regular furnace. And as it turns out, it was a reasonably good decision because, like I said, 22 degrees in the summer inside the house is quite comfortable compared to the 31 it was outside.
Isn't that remarkable, isn't it? You insulate your house properly and you don't need aircon.
Yeah, absolutely.
Fantastic example. Thank you so much. There was a question that came in that says there looks to be lots of vents on the roof. Do you have any comments on the number of vents?
There aren't any more vents than the average roof. What you're seeing here is all the vents for the roof. The solar panels are on the back side of the house.
Yeah.
And we have half of the average number of low profile vents under the solar panels. So we've made the decision to put the vents in front to be able to accommodate the solar panels without interference.
Yeah, which is important. Thanks for getting a bunch of questions in now, which I appreciate. Did you have any regulatory issues in your use of your water?
No, we don't. We're not in the city, so the city of Edmonton, I know, have regulations around intermixing systems. We have a system that's independent. The cold water manifolds for the cistern water is independent of our other system. I do have shut-off valves and reverse flow preventer valves that I can switch from cistern water to city water without cross-contaminating one system with the other.
Yeah, which is important. May I ask how much the floor area is on the house?
What was that again?
How many square feet is your house?
The living space inside is 1,537. The exterior is 1,737. There's 200 square feet of wall because they're 12 inches thick.
Yeah. How do you control the solar blinds?
There's a remote. It's like a TV. You just click the up button and we can operate them individually or collectively. We have the capability on the remote to operate I think it's 6 different blinds at once, but we only have the 2. If you look at the slide now, where the deck furniture is the dining room. That's where the large solar blind is. And to the right that you don't see in the picture is the kitchen window that has the second solar blind. The three windows that are under the overhang are the living room windows. They're further back under the overhang, so in the summer the sun does not touch them at all.
Isn't it great when you design things well, how it can operate like that?
So you can see on this slide the windows. are recessed far enough that in summer the sun doesn't touch them at all, but in winter the sun is so low that it goes into the living room and it heats the area up really nicely.
What brand of solar blinds did you use?
Oh my God, I'd have to go back into my paperwork and review. I can't bring it up off the top of my head right now.
Yeah, no worries. How much of an overhang was needed for the passive component? Or Andrew, can you show some overhangs again? Oh, can you zoom in on that? What does it say? The green sticker that you're showing, Andrew? Do you see it?
Yeah, I see it. I just can't make it out.
Not sure.
Sorry, I can't zoom in with this particular program. Sorry, I think it says Soneto or Sonesta.
Oh yeah, somebody
Sonesta, that's right.
Yeah, somebody put in the chat room sunesta.com. Thank you.
And here I'll go back to the overhangs.
Thank you. Yes, the overhangs. It seemed to me there were some really good photos of overhangs.
Yes, the overhang from the stone pillars, which is basically the edge of the house, is a 24-inch overhang. And from the pillar going towards the window, you have another 30, maybe 40 inches.
So let me give you the reverse view. This is from the living room on one of our Echo Solar tours. I believe this was 2016 tour. And you can see there's no sunlight on the floor of the room at all. Just a little bit of glare from the window.
Yeah. Can you show us one of the other overhangs? I think on the south you had some more pictures.
This is from the exterior. That's an older picture. Here's a newer picture. You can see how the living room windows are set in quite a ways.
Yeah.
Yeah, the dining room windows where the deck furniture is, and to the far left of the photo, the bedroom furniture is slightly more recessed than the dining room, but the living room is in fact a good 36 to 40 inches deeper than the others. And they're like you see their long window, 72 inches. So in the winter they allow more sunlight to come in during the day to heat the house.
And it'd be gorgeously light there in the wintertime, wouldn't it?
Oh, absolutely.
Yeah.
When the deer and a few moose walk by and wave, we can see them quite clearly.
It's really good to make sure that part of passive solar design is done well, so that you don't obscure the heating in the winter and you don't overheat in the summer. That's great to see.
So here's the view out the back to the green space. So you would have all the animals in that green space back there.
Yeah. Now we did take the precautions of putting a page wire, 2x4 page wire fence 6 feet to keep the deer out of the garden because, we don't want to be working for wildlife. Not too much anyway.
Do you have any snow avalanche protection on the PV array, like a snow guard, or do you just let the snow avalanche off in the springtime and be done with it?
Actually, there's mini avalanches throughout the winter.
Oh yeah.
Even if it's 20, 25 below outside after a snowstorm, likely the longest I've had snow after a snowstorm is about a week. The snow will slide off the panels within a week. And, build a small snowbank on the deck a couple of feet deep, which I clear before it hardens. The deck furniture we move to the outside edge of the deck so that the snow doesn't come down on it. So, that's, I guess, the maintenance part of having the solar panels and the deck furniture there. I need to ensure that I move the furniture away from the edge of the house so that it doesn't get damaged from the snow. But in the spring, there's no avalanche because the panels clear themselves throughout the winter quite nicely.
What's the tilt angle of your roof?
It's a 612 pitch.
Uh-huh.
Well, actually, it's an 812.
812, right. Thank you. Are you a member of the Solar Club?
No, I'm not.
Who sends you your electricity bills?
We're with Spot Power.
Oh, well, they offer the Solar Club, but you haven't signed up for it?
Can you define that for me? Because
the Solar Club is a number of energy retailers under the utility net framework, of which Spot Power is one, and they will pay you 25 cents a kilowatt hour for your exported electricity in the summertime.
Oh, well, we might already be. Initially, when we built the house, we landed on Spot Power.
Sure.
My wife would switch from a fixed rate to a variable rate in the spring and in the fall, so that in winter we'd get the low rate to spend less, and in summer we'd get the higher rate to make more.
Yeah, that's the Solar Club.
Okay.
Well, at least the Solar Club is 7 cents in the winter and 25 in the summer.
Okay, then we're there. I just thought she did that on her own, but because I know that it used to be somewhere in the neighborhood of 14 cents for summer, but now it seemed to have increased quite a bit.
Yeah, there's a bunch of competition going on, which is great.
Okay.
So it was 18 last year, and now it's 25.
Yeah. So I guess already I can actually now brag her up and tell you that she's the brains of the operation, and her humility can't say no.
So you must have really nice big credits every month on your bills in the summertime.
Oh, yes, we do. In fact, we don't actually get a utility bill, sometimes well into October or November because of the credits we build.
Yes, exactly. Do you know what your annual bill is?
The annual bill, if you pull the carrying charges out of the mix,
No.
With carrying charges?
I'm sorry?
If
you add up all your bills.
Yeah, I haven't done the math with the carrying charges. I just did the consumption bills annually. And for power consumption alone, we're paying $340 a year. That includes heat.
Uh-huh. Yeah, all the
charges are the carrying charges. You're paying $80 a month.
Here, explain that to my daughter.
Regardless of what you use or don't use.
You're in Fortis's territory, aren't you?
I believe so.
Yeah, I think their annual charges are something like $400 a year, fixed charge regardless of if you use any energy. But I know that some net zero houses in Edmonton have an annual bill of $1,000 credit. So because of the Solar Club. So that's why I was just curious with yours, because your PV system is how big again?
13.5 kilowatts. Right. We have 52 panels.
Right. Yeah, which is great. Do you have any idea of the question that came in was, how is the market responding to your house?
You mean for the sale?
Yeah.
It's been very quiet this past winter because we're higher than the average housing market. It's a big number, and it's a niche market.
Yeah, absolutely. But when people come to look at your house, how do they respond to the water?
They love the efficiencies, and we've had a few comments where people are saying, "Wow, like energy efficiency doesn't have to be ugly." Whoa! So it's it's a nice mix of a good, comfortable, beautiful home and energy efficient. They really love the design and the comfort.
Yeah, and the view out the back is stunning.
Yeah, and on the east side of our house, we there's a lot that's actually an environmental reserve, so it's a wetland, and it's owned by by the province, and nobody's ever going to build there. So we only have one neighbor, and on the other side, we have families of geese in the spring that come and set up house and have their goslings pick weeds and bugs out of our backyard and so on, and we have ducks all summer, and we can hear the frogs at night. It's just a beautiful, relaxing setting.
So what learning are you taking from this house to put into your next one?
Less bling.
Less what?
Less bling.
Oh, yes.
You know, I mean, don't get me wrong, it's a beautiful house. You know, granite countertops and everything else. In the next house, we'll go with less bling. The cold room, we want to do a little more sophisticated than the one we have now, so that you know, we can accommodate the commercial crops that we're going to want to store and so on. And the solar panels will probably put more on than we did here. And we're also looking at, because it'll be in the country, in a national farm area, we're looking at a water treatment plant, sewage treatment plant, to dispose of our sewage, as opposed to a mound or a dispersal field. The subdivision we're in now has a community sewage system where each house has its own septic tank, and we pump to a general community holding tank. And we're working with Alberta Environment to get a sewage treatment plant in place. I was part of the homeowners association that is looking at trying to work this out. And in studying the designs and being involved in this, I recognized that a sewage treatment plant for an individual house is comparable in cost to a septic field or a mound. The difference is you can use that water for irrigation and so on. It's that clean. It's just one step shy of potable. So I guess that's the big lesson in this house for us.
And the passive solar, are you going to put that in your new house?
Oh, absolutely. Yeah, we'll potentially, you know, get the overhangs maybe a little redesigned so that we can save money on the solar blinds. If we have all windows recessed, then you don't have to purchase the solar blinds to begin with. So it saves you a bit of money there. It's just a few more panels that can go on the roof.
How does the sewage plant work?
It's basically a microorganism treatment where your raw sewage, the liquids, I mean, the solids go to the bottom of your septic tank and, you know, decompose and degrade like all septic systems. And the liquids get pumped into a treatment tank that is filled with ambient growing medium where microorganisms live, and they basically eat and treat your sewage through their discharge. And when they're done, it's a 3-stage system where it gets treated and then gets retreated, and then a third treatment stage where the microorganisms break it down basically to clean water.
And so then what do you do? Where do you discharge it?
And then when the clean water is ready for discharge, you have a dosing tank that holds maybe 10 or 20,000 gallons, depending on the size that you want to go with. And you have an underground feed line that would disperse it into, you can either do it out in the field away from the house. What we will do is we'll dig a dugout, and then it'll disperse it into the bottom of the dugout so that we can use that to, feed the orchards and keep the climate a little warmer in winter for the orchards.
But it's not considered potable water, though, even though
it would not be potable, but it is irrigation safe for consumable vegetables and so on.
That's fabulous. Hey, to see that being developed.
I look forward to it. We're still working on details. Of course, we need to sell this house before we can start building the other one, but we are doing our research and inquiries as to who the best supplier would be and, provider for installing the best system we can get.
And where do the solids go from your sewage plant?
Well, the sewage plant itself doesn't hold any solids. They stay in the septic tank. And like all septic tanks, depending on your volume, some houses need to get their septics pumped out every 5 years. I'm aware of people who've been in their homes for 20 years and they've never had to pump their septics. So it depends on on the family sizes, depends on what you put down there too, I guess, right? Some homes are we're as eco-friendly as we can get. We do organic gardening and farming and so on. We don't use pesticides or chemicals or anything, so we don't put anything down our down our drains that is going to cause adverse effects to the environment as much as possible. So our solids, we like to think, are very biodegradable and break down well. So there should be minimal solids in our wastage. As a matter of fact, we've been here for 6 years and our tank has not needed to be pumped out yet.
Okay, well, thank you very much. How are we doing for time, Andrew?
We are now ready for our last home of today. And so the last home today is going to be the Strathcona County Solar Home. And we have Ross Harton available on the line to walk through that with us today. So Ross, what I'll do is I'll just call up your this presentation of the pictures you've sent me, and we'll just get you to walk through that with me right starting now. Ross, welcome.
Well, hello, everybody. This is going to be a net zero home. It's built on a ICF foundation, 2.5 inches styrofoam on either side, which gives you technically an R28 wall. There's in-floor heating with 3 inches of styrofoam, which gives you an R16 insulation factor in the flooring. And then in the top of the picture, you can see a rack. That's for solar hot water. So the in-floor heating and the garage is heated as well. So that takes care of that, and the home heating as well. So it's a hot water heating system in the home. You can't see it, but I put 2 inches of styrofoam on the wall. They call it an energy wall, which now gives that wall an R32. So basically there's your OSB, the 2 inches of styrofoam, and then your inner stud. So it gives you that thermal break. Then this is a kitchen area. Nothing really, all the appliances are energy efficient, right? All the lighting in the house is all LED. There's only 2 fixtures that can have an incandescent bulb in it, but I do have an LED bulb screwed into it. The solar panels that were designed to go on the roof, last winter there was so much snow, I did not install them. I decided to put up solar hot water instead, and I'm going to be mounting them behind the garage on a solar tracker, and then it's going to be fed into the garage, into a battery system, and then fed back into the house, and then to the grid.
Well, you have a couple pictures of construction here, Ross. This is the foundation.
Yeah, that's the ICF foundation. There was quite a bit of rebar because it is a 9-foot. It really jumps from, if you only had an 8-foot wall, you only need them at 16, and because it's 9 feet, that 2-foot exposed, the rebar almost doubled. So this is an ICF foundation. I have not hooked up the solar yet. I wanted to intentionally get a sense of what it would cost to heat this place. And this is a picture of the styrofoam on the basement for the in-floor heating. And of course, the vapor barrier for your radon gas, right? This silver pipe here on the wall, there is a wood stove upstairs, and I have a blower kit for that. So when I have a wood fire on in the evening, I can close the doors, and there's a sensor on there, and I can turn the heat and blow the excess heat down into the basement to help heat it as well. So very energy efficient. This is the hot water heater system with the boiler tucked in behind in the corner, and that this is also a backup solar electric hot water heater, because I wasn't 100% sure on the calculations. You know, computers do make mistakes, and I didn't want to run out of hot water. So I put this in as a backup, and this is solar ready. So this is an A.O. Smith hybrid electric heat pump technology hot water. So I have, abundant supply that if we happen to get only a few hours or that week with only a, very limited sun, then this electric hot water can supply all the natural hot water consumption for your washer, dryer, showers and stuff. And then the other system can heat the house and heat the garage floor and the basement floor of the home.
So this one here, this looks more like a ducted system. Is this somehow hooked into your in-floor heating?
This just generally heats. This is your ductwork that goes all to the bedroom. So this is for the house heating.
Right.
The hot water heating, you can't really see it, but it's piped through the wall. It's controlled. This little box here, where you see this little red tank, and then stay in this picture. You see this little red tank here, and you come back to this black thing right beside the furnace. So that's the expansion tank. You follow that line down. This is the solar controller, and that controls the hot water up on the roof and pipes it into the tank. So when the in-floor heating, it turns on this pump right there where you're circling around. And so when I need heat for the in-floor heating, there's 3 pumps, each a zone. So one zone for the home heating, which is a thermostat upstairs. The second pump you can't see is tucked in behind in the corner. That is for the in-floor heating. And the third pump is on a controller for the garage, because obviously I'm not going to have it as hot as the rest of the home. So I have 3 separate zones heated through this system.
Okay, well, I think here's a picture of your solar collectors on the roof. This is your solar thermal collectors.
Yeah, they are. Yeah.
So tell us a little bit about
so basically
those,
they heat at the very top of that is your header, and that's where the glycol runs through. And these are vacuum tubes with like a brass rod through the middle of it, and it's like an induction convection that it rises to the top and it heats that, and then of course the pump pumps the glycol through it. So obviously it's very functional through the day, but obviously in the evening I have a backup boiler in the system that if I do need it, right? And this is the hot water, 80 gallons of hot water plus the in-floor. So with the styrofoam and stuff, they're saying in an 8-hour period that it might only drop 1 or 2 degrees and should be more than enough that I shouldn't need the boiler to heat the floor because of the mass of the concrete and the thermal storage of it. Yes, in this corner, this is the electric boiler here that I'm talking about, that if I did need heat through the night, then that kicks in if you, on a really cold day, or if you need heat for the house, or you have to warm up, the thermostat comes on and the floor gets a little cold and it's calling for a little more heat, and it's at night, then that kicks in.
This is
actually called for 75 amp breaker on it, but we put a meter on. It's only drawing 22 amps, so I don't know why they rated it so high. And that was right from when we energized it initially at a cold start. And it doesn't take long to heat the water, that's for sure. I did install a filter kit on it, just because, as you know, boilers can be quite maintenance, and of course I'm on well water, so I want to purify and keep out all the sediment and stuff. So I'm on track to change that about every 3 months, and I think the filter is about $48 or whatever. So a little bit of maintenance, a little bit more money than I counted on, just because with COVID, this disconnect box here, I couldn't get an 80 amp, so I had to buy 100 amp and then put time delay fuses in. So it did add a little bit to the cost. I think in the future, I mean, I love my system, very cost efficient, but it's a little bit more money than I planned on, because you have to have all the shutoff valves, and there's a pressure reducing valve there. There's like $400 that, you know, the salesman never told me about. So if I ever built another home, I think I'd just go all electric heat. I'd still put the in-floor heating and stuff like that, but I would not go with the boiler system, right? I just do electric heat. It would be way cheaper.
Oh, I
with
see.
the solar panels, more solar panels, and by that time, battery storage to store the energy, right?
But this is an electric boiler, this backup. This boiler that's here, this is an
This
electric.
tank is right in the picture. It does have an electric backup in it,
Yeah.
but so let's just say you have 3 people showering, it won't keep up. The main boiler will kick in then. But if it's only just a temperature drop like 1 or 2 degrees in the tank, there is a small little heater in that to maintain the temperature in this round 80-gallon tank. But when you start turning on the dishwasher or the wash machine and start sucking a lot of hot water, then obviously if it's in the evening, the boiler will kick on to supplement the demand, right?
So this unit in the back, this is the boiler here. Is that right, Ross? This is the boiler, this guy in the back here, the square box?
Yes, that is correct. Yep.
And that's electrically or
Yep.
gas powered? Electrically powered.
No, that is electric.
Okay, all right. That was my question. All right, great. Now here's your solar panels. So you say you're going to be putting this on a post-mounted tracking array. That's unusual. We don't have a whole lot of tracking arrays. I don't think I've seen one since about 2014. Tell us more about this.
Well, I got involved in solar probably about 2010, and I've seen quite a few in Ontario. Yes, they are a little bit more money than putting it on the roof, but with all the changes, and you have to put the squirrel guard and everything like that, this system come with the racking all in one. So if you subtract that from the price of the tracker, there's maybe an $800 to $1,000 difference, but I'm going to get 20% more power. So when we stand this up, we face the main post. It's like a teeter-totter. We face it directly south, and then the panels will teeter-totter from the east to the west. There's about a 3-foot linear hydraulic cylinder that's going to tilt that from the east all the way to the west. So I'll get 20% more tracking the sun. So at the end of 10 years and the price of solar today, it'll pay for itself, quite handsomely.
Oh, very good. I think there's another picture here too. There we go. There it is, just about ready to go up. How close are you to putting this up?
Yeah. That's probably, I hope to have that up within a couple of weeks.
Very good.
And then we should hopefully, once we get the inspection done and everything, my goal is to be shipping to the grid for the 1st of July.
Okay, so you are grid tied then. Okay, I think this is the last picture I have, Ross. Just hang on. Let me just double check. Yeah, that's the last picture I have. So any of these other pictures you want to go back and talk about a little bit more?
Yeah, so that'll be mounted behind the garage on Lego blocks and fed in through the garage into the house, right?
Back to the house.
Now there is battery storage inside the garage, so I'm going to store my power and hopefully that I won't have to draw anything back from the grid. I'll be able to ship everything to the grid.
Okay, well, tell us a little bit more about this solar system, Ross. How many watts of solar are you talking about, and how big is your battery system? I'm curious to know what that might be.
Well, I have 8 L16 batteries in the garage. So that's going to give me about a 3-day standby rating, load rating. And then there's 20 of these panels at 325, right? And I have the option, there's enough room at the back of the garage that if I do need more power, I do have another tracker that I could put up. But as you know, once you produce so much, they start to clip you. So I wanted to see energy efficiency. I delayed hooking to the grid so I would know my consumption, and then I could pass on the savings and say, this is what it costs to heat this new house, and this is what the system is generating in your payback, because that's what everybody wants to know, is the cost and the payback. And obviously in a new house, when you build an energy efficient, it's pretty hard to know what it's going to heat to it. If I would have hooked up the solar and everything initially, then I would have no cost factor to know exactly how much I saved. So that was part of my logic behind of the delay of hooking up the solar hot water is in there, but I did not energize it. I used all electric this past winter, so I'd have a real sense of what the savings would be with these two systems in place to pass on to customers or people that are interested in the savings by using this system, right?
Very interesting. So how are you actually heating the house? It's you showed us a couple of pictures. There's the in-floor heating that's heated by the thermal collectors on the roof, and then you also have the air source heating. How is that air source heated? Is that just an electric furnace, or is that an air source heat pump as well?
That's from the hot water. So
you have a hot water coil in that air duct.
Yep.
I see. Okay.
Yeah. So I did not turn on the solar collectors and everything is ready to be turned on, but I intentionally used the boiler this winter to know how much energy to heat this house, so that I can effectively pass on that information. Because as you know, out there, there's not a lot of solar hot water installed on a house in this system. So I wanted to have a firm price of knowing this is almost a 2,000 square foot home. That cold snap in March, when it was -40, I had the boiler going and my hot water heater and a couple little space heaters, because I did not have the solar hot water hooked up from the roof. So I'm almost completed my 12-month period, and then I'll energize everything. Then we can compare, next year exactly the savings. And I think that bill in that cold -40 was running just a little over $400. I have no natural gas here, but that's everything in the house.
Interesting. Very interesting. All right. Well, Gordon, I'm going to invite you to pull in any questions we have for Ross. Gordon, what kind of questions have we got today?
Yes, thank you. So I'm very intrigued by the solar thermal system. Well, one of the questions was, I didn't understand how your solar hot water works. Can you explain it again? Is it for heating? That was the question. So yeah, that's a good slide there, Andrew.
Yeah.
So go ahead.
So on the very top of that is what they call a header. And so the glycol runs through the very top of this system, the silver part that they're showing here with the pointer right at the very top. The tubes are under vacuum, and inside that glass tube is a brass rod that runs all the way to the bottom. So as the sun hits these tubes, because they're round, it's like a convection, and it just starts wrapping around there and creates your induction, and of course heat rises. So when the glycol comes through there, it gets extremely hot. I do believe Cintas in Edmonton, the uniform company, has a whole whack of these up on their roof because they use so much hot water to wash the clothing. And I'm not sure if it's the Edmonton location or in the Calgary location, but it's very efficient in the summertime. In the wintertime, you always have pros and cons, and every salesman wants to sell his system because it's the best. I'm pleased so far with the cost ratio and the payback of the system. And this time next year, I'll be able to give you an actual cost analysis of exact numbers, whereas right now it's only computer generated, and that does not come into, location, wind, snow load, all that stuff plays a factor, right? I am in the rural setting, so the wind blows pretty strong through this, we're in the northwest side of the house, but that location also, I put that intentionally there at the top of the roof, so I get the sun in the morning in the winter time. Because these tubes are hollow, it's going to heat from the front side, which is, your east rising in the sun, and it'll set in the west, and it'll still, so you utilize, it was initially designed on the back side of the roof where I felt I would lose, almost an hour of sunlight before it would heat them tubes up, right?
Which brand of solar thermal system did you get?
This is a company out of Quebec called Hydro Solar. And of course, the system is comparable to Sun Rain, which is sold by Northern Lights. They're almost identical as far as specs go. So it's really just the capacity, the controllers, the pumps, the flow meters that just changes the system from brand to brand. So there's not a whole lot of difference in suppliers. This is the tank part of the solar solution, right? And they're out of Quebec, based out of Quebec, but they get most of the stuff, or the parts obviously come from China, right?
Yes, apparently China is the world's largest manufacturer of evacuated tube solar thermal collectors. Yeah, it's extremely.
So a question for you, Ross, from me. Yeah. On these solar thermal systems in the summertime, they sometimes have a tendency to overheat. How do you deal with the overheating potential in this particular system? What have you got in place?
Well, there's a sensor. If you go back to the tubes at the top, there's when you're showing on the roof there's a sensor up there that when it gets too hot, it dumps it somehow, right? These black hoses, there's a sensor runs in this black hose here at the top of this header, and there's a dump valve up in there, and it just opens when it gets too hot, right?
Usually there's a radiator of some kind, but yeah, okay, so there's a radiator.
Yeah, and that's where the radiator is, right at the very, very top here. So right. When it gets too hot, it just dumps it to the outside, right? In the summertime when it gets too hot.
Okay.
Pressure relief, I guess. And then in the wintertime, we use that heat so it can actually turn it on and pump it into the house, right? It has, that's the fail-safe on that system, right?
Who designed your solar thermal system?
Hydro Solar out of Quebec.
And how long has it been operating for?
It hasn't been energized yet because, like I said earlier, I wanted to rack up the electricity charges to know. So the glycol and everything is ready to be commissioned. I just have not used it yet because I wanted the full 12 months to know what it cost to heat this house. So then I can say to everyone, okay, well, this $9,500 now can be paid back in 5 or 6 years because this is the money I'm saving with it, right? Or it's going to be 7.5 years. And there's very, I mean, I've been involved in this a long time, and there's just so many conflicting reports. And it depends on whether you're Eastern Canada, Western Canada. And as you know, I drive from Edmonton home out here, and 9 times out of 10 it's snowing, it's 2 degrees colder in location. So I wanted a proof in the pudding to actually have hard facts to pass on to interested people in the solar for this system, rather than just hearsay and a computer generated printout, right? So I'll actually have hard costs of what to heat this house, and when I energize this system, the savings and how much money it's going to make me.
That's a very interesting tactic. It's going to be interesting to see what the results are at the end of your year.
Yes. Well, and then of course, as you know, then I would also qualify for the leads. Then I get 50% of my building. So part of this, yes, it's a short-term pain. It's only a year, but then for the leads portion of that, then I have proof exactly. And then when we introduce the solar and the hot water, then you see the savings and all that stuff. And we're still waiting to get the blower test to have them to part of that qualification so that I'll get 50% of my building permit back.
So did you buy the solar thermal system directly from the hydro solar?
Yes, and I'm actually a distributor for them here in Western Canada.
Oh, cool. And you said it was $9,500 or something?
Yeah.
For how many? For what size? How many tubes do you have?
So there's 30 tubes up there. There's 15 in each row. Now this is so the house is 1,973 square feet, and then there's another, I think, 550 square feet of garage floor, plus the calculations to do all the hot water and the heating of the home. So that's why I had to put up the second collector. I could have got away with one, but I couldn't make up my mind because, as you know, we all hate shoveling snow, and I almost put in a heated walkway. So he oversized it that if I did, and I said, I don't know if I have the money, but that was part of my plan. And as time went on, I did not put in the heated walkway. So there's plenty of tubes there to provide the necessary heat load calculations for the home.
Ross, what's the angle of the tubes to the sun? What is their angle above grade, or however you want to measure
that? Honestly, I never measured it, but that looks to be about 50 degrees, right? I mean, it's just like your solar panels. You try and match them to the sun angle, and I think we're closer to the 58 parallel, and everybody says that closer to the 58 parallel generates the most power through your solar panels, right? So I did not actually measure it, but just looking at it, it's definitely more than, a 45. I think it's closer to the 50, 51 degrees. Okay. That come right from the factory at that setting.
Oh, I see. Okay, so they built the rack for you at that angle.
Yeah, I bought everything, the kit and everything. It is a little bit steeper because I did put it right at the top of the roof. A lot of them are mounted a little bit lower down on the slope, but then you're going to hide that backside of the tubes, and we have such short sunlight in the winter that you're going to lose that first hour of sunlight. So that's why I put it right at the top of the roof. So for the winter time, for heating capacity, I'm going to get that extra hour and a bit, maybe even 2 hours of sunlight. If they were slid down a little bit lower on the roof, then the sun wouldn't come in there and you wouldn't get a whole lot of heat. You get some, but it'd be minimal. So I intentionally put that right at the top of the roof.
Hey, that's all very interesting. I'd look forward to coming out and seeing it at some point when the virus.
Yes, for sure. Everybody's welcome to come view it. There's lots of, so hard to talk about and remember everything that you do when you build a project like this. But I was even the siding, I tried to leave an eco footprint. It's not a cement board. It's what they call a smart board, and it's got a little bit more recycled content in it, and it takes less energy to build rather than your hardy board, cement board. So I've been very conscious to leave as little footprint as possible, and to generate as much power back to make the greener.
I have a number of questions here, which I'm appreciating. You have a wood stove, right?
Yes, I do. Yep.
How big is it?
It is capable of heating a 2,000 square foot home.
with where the home is super energy efficient or or a standard home?
Yeah, well, there's more personal preference. You know, you come home from work and you want to sit in front of the fire, and it's just so inviting. And you know, I have lots of woods here in the country, so you know, I decided to put in a fireplace. I've always had a fireplace. I mean, really, the savings is more for comfort. I mean, there probably is some, but by the time you pay the gas and your chainsaw and stuff like that, it offsets. It's more for personal pleasure, really.
Sure, which is great. What battery technology are you going to use?
I'm going to move AP microinverters, the 600Ys, because they capture a higher percentage than a string inverter. And as you know, we get quite a bit of hail in Alberta, and I want to be proactive. So if I'm off the grid with a string inverter, if we happen to get a freak hailstorm and it smashes, you know, 6 or 7 of them panels there, I'm without power. So with a microinverter, you know, I can carry a spare one in my pocket and swap it out quite easily, or even for a customer than a string inverter. And most of my off-grid systems, I do the microinverter systems because it's you get that extra 5 or 6% power, and it converts it right at the panel, so you get a little bit more power. You don't have the line loss. So at the end of 10 years, initial cost, you know, might be say $3,000 more than a string inverter, but you got peace of mind. I've never ever seen them all go out at once, and they're so easy to change, and you don't lose the whole system. I say it's like, you know, they manage 2 kids at a time. They marry up 2 panels together, where a string inverter, depending on your voltage and stuff, you might have 10 or 12 or 14 or whatever they're pushing out. And then when you knock a couple of them out, well, then you only have the other 6 to produce your power. And of course, with a off-grid home, it just is not enough. So that's why I opted for the microinverters.
How are you going to use the microinverters in an off-grid situation?
Well, they have an anti-idling built right into them. They're like a small little computer. So they sense line, like if the power goes out or whatever, that's your energy code, right?
Anti-islanding, they call it, anti-islanding.
But if you're off the grid, then you're not connected to the utility grid. So how can you worry about outages if you're off the grid?
Well, I call it an off-grid system. I mean, I'm going to be shipping power. I do have a meter in here. Obviously, I'm going to hook it and get a micro grid application going so that I can ship the excess power back to the grid. So there will be, you know, you still have the option. Technically, an off-grid is I'm going to overproduce so much power that technically I won't need to use much from the grid. With the battery storage and everything, I'll ship the excess power to the grid. But technically, I built it as an off-grid system, but I'm still hooked to the grid, if that makes sense.
No, it doesn't.
So Rob, just a quick question. So are you going to have a transfer switch in here that will actually disconnect you from the grid in the case of a power outage on the grid, so that you can actually then use your batteries to power your home?
Yeah, I do have another inverter in the garage, and it's designed for an off-grid application and battery charging. So that controls everything. So when the power goes out, it shuts it out, right?
Oh, I see. So it disconnects you from the grid in the event of a power outage.
Yes, it does. Yeah.
Yeah, it's usually called transfer switch or something like that.
Right.
I do believe the terminology they do right now is called a rapid shutdown something.
No.
Well, there is a rapid shutdown, but that's in the inverters. That's fine. Okay.
What battery technology are you using?
Right now is a Surratt's.
Oh,
and
so
they are an AGM.
AGM batteries. Oh, yeah.
Yes.
Okay.
How are you going to measure the savings between the year that you're doing now and the year that you will measure it against?
Well, I'm hoping that the batteries, with having the cost of what it charges me right now. So let's just say that the bill is $300. There's $100 in line charges and stuff like that. So by having the batteries and not having to, I'm storing that energy here on location, I should see little or no line charges. So you can take that $100 a month or whatever that figure may be and apply that to the cost of the batteries. So round numbers, we'll say the batteries are $4,000. I calculated very lucratively and erred on the side of, unforeseen problems or maybe a bad battery. But with the battery storage, I'll have that saved for 3 years. They have a warranty of 10 years on the battery. So after they're basically paid for, it's just like saving for a rainy day. So you take some of that savings, put it away for battery replacement in 10 years. And some of them, they're telling that they last 12, 15 years, depending on the cycles. They're a cycle rated battery. So if they don't, I have everything all LED in this home. So it's really hard to tell the depth of discharge and the cycles that they're going to be used. So, I could potentially get 15 years out of them batteries, which then again would result, in additional savings, but that's just too hard to forecast, right?
Did you have to drill a well?
No, there was a well already drilled here.
Okay, thank you. I'm just reading the questions that have come in. What was the permitting process for the solar thermal system?
I just put it in with the building permit portion of it.
Right, yeah.
Now the solar panels is a separate one, but that falls under plumbing and heating, right? The hot water system,
the hot water is plumbing,
was sent to the county when I first applied for the building permit, and that all them load calculations and everything for the solar hot water was submitted at that time.
Interesting. Now, interestingly, the permit for your ground mount tracking array, which would be a separate permit, was there any issues with that? Did they have any questions back to you on that?
They still haven't come to inspect it, and I'm waiting for drawings. I took the liberty, and I'm waiting for an engineer drawing to come back for it, because the manufacturer calls for a pad and we've mounted on Lego blocks. So I have an engineer report coming back that equals or to the drawing from the manufacturer from a poured concrete pad, right?
The question came in, why did you use an electric boiler instead of a heat pump?
Well, and I ask myself that sometimes too, is, when you first get into it, I did do some research. The boiler was recommended with this system that it would do quite well. But then as later on, everybody has their own story to tell, and you listen to the salesman, and then later on you learn, oh, well, someone else put in a better system and the heat pump is more efficient. So, hindsight is always 20/20. I probably would have been a little bit more efficient with just a heat pump system, but I wanted to, try this solar hot water to see how feasible it was, because potentially I am looking in the future for a greenhouse, and I thought, well, I'd try it on my house to see whether it works in the winter, and if it doesn't, then I just won't incorporate it into any or more buildings. We'll move more to more solar panels, baseboard heaters, and of course your heat pump for hot water cooling, a mini split system, right?
Right. Thank you. One last question was, how much was the electric boiler?
I'm gonna say it was actually, I priced it here in Edmonton and they were quite pricey. So he gave me a pretty good deal. I think part of the package, it was under $2,000, $1,895 maybe. And I know I priced it locally here and it was over $2,500. So the cost, which really surprised me, and the heat pump probably would be a little bit less expensive, but hindsight is always 20/20, is we had to put that 100 amp disconnect switch in because we couldn't find an 80 amp breaker with COVID anywhere with time delay fuses. So that was an extra, $400 added to the system. And then each pump, because of the 3 systems, was another $150 in your shutoff valve. So yes, there is a lot more plumbing on the plumbing side. And I think that's, if we ever have to do it again, I would probably lean more to adding just more solar panels, maybe more battery capacity, and definitely a heat pump or a mini split system to compensate and not even have the electric boiler in there.
Thank you, Ross. I'm going to stop you there. We are done for the day. So thank you very much for showing us your very interesting solar home. That is probably the first solar thermal system we've seen in Edmonton for quite some time, active solar thermal. There have been some other passive ones, but that's the first one we've seen in Edmonton for a number of years. So very interesting to be able to talk about that. So we're going to just wrap up here, be very brief. Basically, I want to start by thanking our sponsors, our Edmonton sponsors who have graciously provided us with the funding to be able to advertise and promote the tour in Edmonton. Were the City of Edmonton, EPCOR, DeWalt Developments, Park Power, Habitat Studio, Innotech Windows and Doors, Butterwick, Skyfire Energy, Rosecrest Homes, Camrose Energy, and our in-kind sponsors, Solar Alberta, Lynn Allen Photography, and the Unitarian Church of Edmonton. Now, I want you to make sure you don't forget that we have other tour days coming up. We have next weekend on June 12th and 13th, we have 10 sites in Calgary that are going to be coming up. And we encourage you to log back on next weekend, again, starting at noon each day, to see the Calgary sites. And then a week after that, we're going to have the Lethbridge tour. This is going to be our very first ever Lethbridge tour, where we have 5 sites lined up for Saturday, June the 19th. Now, today's tour was recorded, and the recording will be posted on our website soon. We do have to do a little bit of work with it before we're ready to post it. And then you can still send questions. I know we covered a lot of questions and a lot of issues today, but if you still would like to send questions, you can use the web address, the email address, info@ecosolar.ca. We'll forward that on to the homeowner, or we'll get you an answer somehow, either from ourselves or from one of the homeowners. So thank you for attending today. I'm now going to stop the live stream. It'll take a few seconds for that to stop.